Welcome to this introductory course on Git and GitHub. Git and GitHub are widely used in the industry for version control and collaborative software development. Version control and collaboration software are crucial for completing software development projects effectively. Employers expect skills in Git and GitHub for software development careers. This course suits anyone who wants to learn version control and collaboration with Git and GitHub. No prior background knowledge is required, just basic computer and IT literacy. This course is particularly suitable for those interested in roles such as software engineers, application developers, data scientists, and data engineers. We're excited that you're here. Your instructors for this course are Ravahuja and Upkar Leader. Ravahuja is a global program director at IBM and leads growth strategy, curriculum creation, and partner programs for the IBM Skills Network. Upkar Leader is a senior product manager with 15+ years of experience in IT development, including team management and functional and technical leadership roles. When you complete this course, you will understand basic Git and GitHub concepts in the context of distributed version control. You will be able to create repositories, collaborate on team projects by sharing and integrating your changes, and even build a GitHub portfolio. Now, let's look at what you will learn from the 4 modules in this course. The first module begins with the basics of Git and GitHub. It covers repositories and how to edit and push files in GitHub. This module will also introduce you to GitHub branches. As part of hands-on activities, you will create a GitHub account and a project repository. You will also create branches and merge a pull request on the web user interface. In Module 2, you will learn about Git workflow and Git commands. You'll also learn to use branches, fork, and clone public repositories, and collaborate using Git commands. As part of hands-on activities, you will use cloning and forking in a GitHub project. In Module 3, you'll consolidate your learning with a 2-part final project, one based on the GitHub user interface, or UI, and the other on the Git command line interface, or CLI. You'll apply your knowledge by creating a GitHub project, adding, committing, and pushing files, and sharing the project publicly. After your project submission, you will evaluate your peers' projects based on a rubric that will be provided to you. Additionally, you'll explore an optional topic on GitHub Copilot. In the final module, you'll explore optional topics on using GitHub from your Windows desktop. You will learn to install Git Bash, generate an SSH key, and add it to GitHub. To get the most from your course, watch all videos, complete the hands-on activities to practice your new skills, attempt all quizzes, complete the final project, and create your shareable portfolio. Remember to use the discussion forum to connect and collaborate with your peers, or seek assistance from the course staff. Let's get started on this exciting journey. Welcome to this introductory course on Git and GitHub. Git and GitHub are widely used in the industry for version control and collaborative software development. Version control and collaboration software are crucial for completing software development projects effectively. Employers expect skills in Git and GitHub for software development careers. This course suits anyone who wants to learn version control and collaboration with Git and GitHub. No prior background knowledge is required, just basic computer and IT literacy. This course is particularly suitable for those interested in roles such as software engineers, application developers, data scientists, and data engineers. We're excited that you're here. Your instructors for this course are Ravahuja and Upkar Leader. Ravahuja is a global program director at IBM and leads growth strategy, curriculum creation, and partner programs for the IBM Skills Network. Upkar Leader is a senior product manager with 15+ years of experience in IT development, including team management and functional and technical leadership roles. When you complete this course, you will understand basic Git and GitHub concepts in the context of distributed version control. You will be able to create repositories, collaborate on team projects by sharing and integrating your changes, and even build a GitHub portfolio. Now, let's look at what you will learn from the 4 modules in this course. The first module begins with the basics of Git and GitHub. It covers repositories and how to edit and push files in GitHub. This module will also introduce you to GitHub branches. As part of hands-on activities, you will create a GitHub account and a project repository. You will also create branches and merge a pull request on the web user interface. In Module 2, you will learn about Git workflow and Git commands. You'll also learn to use branches, fork, and clone public repositories, and collaborate using Git commands. As part of hands-on activities, you will use cloning and forking in a GitHub project. In Module 3, you'll consolidate your learning with a 2-part final project, one based on the GitHub user interface, or UI, and the other on the Git command line interface, or CLI. You'll apply your knowledge by creating a GitHub project, adding, committing, and pushing files, and sharing the project publicly. After your project submission, you will evaluate your peers' projects based on a rubric that will be provided to you. Additionally, you'll explore an optional topic on GitHub Copilot. In the final module, you'll explore optional topics on using GitHub from your Windows desktop. You will learn to install Git Bash, generate an SSH key, and add it to GitHub. To get the most from your course, watch all videos, complete the hands-on activities to practice your new skills, attempt all quizzes, complete the final project, and create your shareable portfolio. Remember to use the discussion forum to connect and collaborate with your peers or seek assistance from the course staff. Let's get started on this exciting journey. Welcome to Overview of Git and GitHub. In this video, you will explain what Git and GitHub are, along with some basic terms related to Git and GitHub. You will also grasp the concept of the version control system and how it is related to Git and GitHub. Git and GitHub are popular environments among developers and data scientists, but you can't discuss them without a basic understanding of version control. A version control system lets you track your changes to the source code. This makes it easy for you to recover older versions of your document if you make a mistake. Along with this, it makes collaboration with other team members much easier. Here's an example to illustrate how version controls work. Let's say you have a shopping list and want your roommates to confirm the things you need and add additional items. Without version control, you've got a big mess to clean up before you can go shopping. With version control, you know exactly what you need after everyone has contributed their ideas. Git is free and open-source software distributed under the General Public License, or GNU. Git is a distributed version control system, or DVCS, meaning users anywhere in the world can have a copy of your project on their computer. When they've made changes, they can sync their version to a remote server to share it with you. Git isn't the only version control system out there, but the distributed aspect is one of the main reasons it has become one of the most popular version control systems available. Version control systems are widely used for things involving code, but you can also version control images, documents, and any number of file types. Note that Git also supports branching strategies, such as feature branching, to organize and manage development. You can use Git without a web interface using your command line interface, but GitHub is one of the most popular web-hosted services for Git repositories. Others include GitLab, Bitbucket, and Beanstalk. There are a few basic terms that you will need to know before you get started. The Secure Shell, or SSH protocol, is a method for secure remote login from one computer to another. A repository contains your project folders that are set up for version control. A fork is a copy of a repository. A pull request is how you request that someone review and approve your changes before they become final. A working directory contains the files and subdirectories on your computer that are associated with the Git repository. Commit is a snapshot of the project's current state at a specific point in time, along with a description of the changes made. A branch is a separate line of development that allows you to work on features or fixes independently. Merging combines changes from one branch into another, typically merging a feature branch into the main branch. Cloning creates a local copy of a remote Git repository on your computer. Let's recap. In this video, you learned that Git is a versatile version control system used for tracking changes in code and collaborating with others on software projects. Due to a distributed version control system, Git enables you to revert to the previous state or review the history of the project. Git supports branching strategies, such as feature branching, to organize and manage development. GitHub is one of the most popular web-hosted services for Git repositories. Basic terms associated with Git and GitHub are SSH protocol, repository, fork, pull request, working directory, commit, branch, merge, and clone.
Welcome to Introduction to GitHub. After watching this video, you will be able to describe the purpose of source repositories and explain how GitHub satisfies the needs of a source repository. Linux development in the early 2000s was managed under a free-to-use system known as BitKeeper. In 2005, BitKeeper changed to a for-free system, which was problematic for Linux developers for many reasons. Linus Torvalds led a team to develop a replacement source version control system. The project ran in a short time frame, and the key characteristics were defined by a small group. These include strong support for nonlinear development. Linux patches were then arriving at a rate of 6.7 patches per second. Distributed development. Each developer can have a local copy of the full development history. Compatibility with existing systems and protocols. This was necessary to acknowledge the diversity of the Linux community. Efficient handling of large projects. Cryptographic authentication of history. This makes certain that distributed systems all have identical code updates. Pluggable merge strategies. Many pathways of development can lead to complex integration decisions that might require explicit integration strategies. What is special about the Git repository model? Git is designed as a distributed version control system, primarily focused on tracking source code during development. Contains elements to coordinate among programmers, track changes, and support nonlinear workflows. Created in 2005 by Linus Torvalds for distribution of Linux kernels. Git is a distributed version control system that is used to track changes to content. It serves as a central point for collaboration with a particular focus on agile development methodologies. In a central version control system, every developer needs to check out code from the central system and commit it back into it. As Git is a distributed version control, each developer has a local copy of the full development history, and changes are copied from one such repository to another. Each developer can act as a hub. When Git is used correctly, there is a main branch that corresponds to the deployable code. Teams can continuously integrate changes that are ready to be released and can simultaneously work on separate branches in between releases. Git also allows centralized administration of tasks with access-level controls for each of them. Git can coexist locally, such as through the GitHub desktop client, or it can be used directly through a browser connected to the GitHub web interface. IBM Cloud is based on sound and established open source tools, including Git repositories, often called repos. GitHub is an online hosting service for Git repositories. GitHub is hosted by a subsidiary of Microsoft. GitHub offers free professional and enterprise accounts. As of August 2019, GitHub had over 100 million repositories. A repository is a data structure for storing documents, including application source code. a repository can track and maintain version control. GitLab is a complete DevOps platform delivered in a single application. GitLab provides access to Git repositories controlled by source code management. With GitLab, developers can collaborate, reviewing code, making comments, and helping to improve each other's code, work from their own local copy of the code, branch and merge code when required, streamline testing and delivery with built-in continuous integration, CI, and continuous delivery, CD. In this video, you learned GitHub is the online hosting service for Git repositories. Repositories store documents including application source code and enable contributors to track and maintain version control. What is special about the Git repository model? Git is designed as a distributed version control system, primarily focused on tracking source code during development. Contains elements to coordinate among programmers, track changes, and support nonlinear workflows. Welcome to GitHub repositories. After watching this video, you will be able to explain how to sign up for a GitHub account and describe how to create a repository. Signing up for a free personal account on GitHub is quick and easy. Start at the GitHub site, https://github.com. You'll need to choose a username, enter your email address, and select a password. Then click Sign up for GitHub. Next, you'll have a short test to prove that you're a person. Click Verify and solve the puzzle presented. When you're done, click Join a free plan, and then you'll be taken to a screen where you can select the type of account. Most likely, a free personal account is all that you'll want. Choose to set up a personal free account, which is the default. GitHub asks some questions about your work, programming experience, and interests. You can skip these if you want. Finally, you'll have to respond to an email that you receive which proves that you link to GitHub from an account that you access. GitHub provides you with some starting points. You can choose to create a repository or an organization, or you can take the Introduction to GitHub course. Remember, a repository is a data structure for storing documents including application source code, which tracks and maintains version control. An organization is a collection of user accounts that owns repositories. Organizations have one or more owners who have administrative privileges for the organization. Or you can skip this for now and get straight to work. GitHub provides many resources to help you work efficiently. When you have time, read the GitHub guide. The heart of a Git-based project is the repository. This contains all your code and the related artifacts, including things like a README file to describe the purpose of the project, a license to express the ways in which people can use your code, etc. You can also make your repository private, only available to people with accounts that have permission to see it, or public, searchable and seen by everyone. When you create your repository, you'll notice that it has a number of tabs and is open to the Code tab. Code. This is where all the source files reside. Git was initially created as a source code repository, and now all sorts of files end up in here. If you created a README and/or license, that's all that's here right now. Issues. As you can imagine, you can track and plan with tools such as Issues that lists all open items against your project base. Pull requests. This is part of the mechanism for collaborating with other users. Pull requests define changes that are committed and ready for review before being merged into the main branch. Projects. All the tools for managing, sorting, planning, etc. your various projects. This is the core of the collaborative power of GitHub. Wiki, security, and insights. Often left for more advanced users, these tools provide a communication base to the external user community. Settings. GitHub allows for a lot of personalization, including changing the name of your repository and controlling access. In this video, you learned How to create and verify a GitHub account. Repositories are storage structures that can hold code, track issues, and enable you to collaborate with others. In the previous video, you learned about Git and GitHub. Before you continue with this video, register for a GitHub account and log in. Let us start by creating a new repository. Click plus, then click New Repository. To create a new repository, you need to provide these details. Give your new repository a name. Optionally, add a description of your repository. Choose the repository visibility, whether you want it to be public or private, and choose the option to initialize this repository with README file. Then click Create Repository. You will now be redirected to the repository you have created. The root folder of your repository is listed by default and it has just one file, readme.md. Now it's time to edit the README. You can do this in your browser. Just click the pencil to open the online editor and you can change the text of the README. To save your changes to the repository, you must commit them. After you have made your changes, scroll down to the Commit Changes section. Add a commit message and optionally add a description. Then click Commit Changes. Commit Changes is used to save your changes to the repository. Go back to the home screen by clicking the repository name link. Note that the README file is updated and verify your changes. Let's learn how to create a new file using the built-in web editor provided by GitHub, which runs in the browser. Click Add File, then click Create New File to create the new file. To create a Python file called firstpython.py, first, provide the file name. Next, add a comment that describes your code. Then, add the code. Once finished, commit the change to the repository. You can see that your file is now added to the repository, and the repository listing shows when the file was added or changed. When you need to change the file, you can edit it again. Click the file name, then click the pencil icon, make your edits, and commit the changes. You can also upload a file from your local system into the repository. From the home screen of the repository, click Add File and choose the Upload Files option. Click Choose Your Files and select the files you want to upload from your local system. The file upload process may take a short time, depending on what you are uploading. Once the file finishes uploading, click Commit Changes. The repository now reflects the files that were uploaded. In this video, you learned how to create a repository, edit files, and commit changes using the web interface.
Welcome to GitHub Branches. After watching this video, you will be able to explain the purpose of branches in GitHub and describe how to merge changes into branches. All files in GitHub are stored on a branch. The main branch is definitive. It stores the deployable version of your code. The main branch is created by default. However, you can use any branch as the main, finished, deployable version of the code. When you plan to change things, you create a new branch and give it a descriptive name. The new branch starts as an exact copy of the original branch. As you make changes, the branch you created holds the changed code. To create a new branch, click the drop-down branch, Main. Add new branch name into new branch text and select Create Branch. GitHub branches can be very complex for large software projects. For a simple project such as the ones we are exploring, consider the following. Start with a common base, the initial source for this project. At one point, the code is branched while new features are developed. In this example, both branches are undergoing changes. When the two streams of work are ready to merge, each branch's code is identified as a tip, and the two tips are merged into a third, combined branch. Developers work on source files in a branch. Since some projects take a while, the source doesn't make sense right away. To change the contents of a file, select the file, click the pencil icon, make the changes, commit the changes. When the developer has completed their assigned work, to save their changes, they commit the code. Commit indicates that the developer is convinced that the code represents a stable platform for the feature or set of features being developed. When a developer commits a change source to their path, they are required to write a comment that describes the changes. The comment should be meaningful and descriptive. The developer can choose to commit to the current branch or create a new branch. Finally, click Commit Changes. Some best practices while writing a comment. Don't end the comment message with a period. Keep commit messages under 50 characters. Use the extended window for the details. Always write in an active voice. Pull is used to initiate the merging of branches in a way to capture changes. A pull request makes the proposed committed changes available for others to review and use. A pull can follow any commits, even if the code is unfinished. A pull requires a user to approve the changes. This can be the author of the change, or it can be assigned within the team. Note that GitHub automatically makes a pull request on your behalf if you make a change on a branch that you do not own. Since the log files are immutable, it is always possible to find the person who approved the merge of the change. To open a pull request, click Pull Requests and select New Pull Request. Select the new branch from the Compare box. Scroll down to view the changes. Confirm that the changes are what you want to assess. Add a title and description to the request. Click Create Pull Request. The intent of Git repository is for the main branch to be the only deployed code. Developers can change source files in a branch, but the changes are not released until they are committed. A pull command is issued. The code is reviewed and approved. The approved code is merged back into the main code. To merge a committed code change into your main code, click Merge Pull Request. Click Confirm Merge. When all changes for a branch are complete, that branch is considered obsolete and should be deleted. In this video, you learned all files in GitHub exist on a branch. The main branch contains the finished, deployable version of the code. Create new branches when you need to change the code. The new branch starts as an exact copy of the original branch. As you make changes, the branch that you created holds the changed code. More than one branch can be undergoing changes at the same time. Saved changes are called commits. Pull requests enable other users to review and use the proposed changes committed. When you are ready to merge the changed code into the main branch, you merge the committed code changes into your main code. Welcome to the overview of Git workflows. After watching this video, you will be able to describe the steps in a Git workflow and explain the workflow in a real-life scenario. Imagine yourself joining a team developing features for an e-commerce platform. Your task is to add a product recommendation feature. The team uses Git and GitHub for version control and collaboration. How will you collaborate effectively with the team using Git and GitHub? A clear understanding of Git workflows ensures you can use Git effectively for version control and collaboration. The knowledge will help you avoid issues such as code conflicts and unintentionally overwriting a team member's work. The first step is cloning a repository that your team has hosted on GitHub. Cloning creates a copy of the project's code and its complete version history from the remote repository on your local computer. The connection established during cloning enables you to push code changes to the remote repository. You can also pull any changes from the remote repository to your local repository and update it. You can implement the product recommendation feature by updating the project files in your local repository. As a developer, you might try multiple ways to code the feature. You may not want the changes to affect the main branch until the code is ready. A good practice is to create a branch from the main branch and then work on the newly created branch. A branch in Git is an isolated development space based on the main branch where you can make changes, in this case, add a feature, without interfering with the main codebase. After developing the feature, the next step is to select the changed files and move them to a staging area. The staging area is a temporary storage space where you collect the selected files before asking Git to save them in the local repository. You can now commit the files to the newly created branch. Committing files allows you to record the changes and ensure your new feature becomes a part of the branch. When you commit files, including a commit message provides context for you and your team members to understand the change. For example, include a commit message like Implemented Product Recommendation Feature. The next step is pushing the changes in the branch to the remote repository. Most often, the code is reviewed by a maintainer, who is responsible for managing the repository before it is merged into the main branch in the remote repository. To merge the branch, you create a pull request. It is a request to the maintainer to review and approve the changes in the branch. After the maintainer merges the pull request, the changes in the branch will be reflected in the main branch. Similarly, if you have maintainer access, you will receive pull requests from your team members, and you will review and approve their requests. You learned about the typical workflow in a software development project. There may be situations where you start a project from scratch and intend to collaborate with others. You can initialize a local project directory as a Git repository so that Git starts tracking changes in your project directory. The next step is to select all project files that you want Git to track, move them to a staging area, and then do an initial commit. After this, you will create a blank repository and link your local Git repository to the remote repository. Then, you will push all project files from your local repository to the remote repository. Other developers can clone the remote repository and follow the regular workflow for updating project files. Let's understand the workflow better with a use case. A company assigns a team of developers, testers, and product manager to a new web application development project. Anne, the lead developer, initializes a Git repository in her working directory. She creates project files, moves them to the staging area, and does the initial commit. She then pushes the commit to a blank remote repository she created. All developers clone the remote repository and start working on it by creating branches. One of the developers, John, is responsible for implementing a user authentication feature. He creates a new branch named User Auth from the main branch. John completes the feature development and commits to the User Auth branch. After thorough testing, he pushes the branch to the remote repository and creates a pull request. Anne reviews the pull request and approves it to merge the changes into the main branch, so other developers can access the changes made by John. Similarly, other developers push commits to the remote repository for the features they worked on. At this stage, feature development is complete and the project is ready to be released. Anne creates a release branch named Release 1.0 from the main branch in the remote repository. The team pulls the changes from the remote repository so that their local repository is up to date. They perform final testing, bug fixes, and documentation updates in the Release 1.0 branch. After testing, they commit the changes, push the commits to the remote repository, and create a pull request. Anne reviews and merges the changes into the main branch and tags the release as Release 1.0. Let's now recap what you learned. In this video, you learned about the steps in a Git workflow. When you join an existing project, first clone the remote repository. Then, create a branch from the main repository and work on the branch. Add updated files to the staging area and commit to the branch. Push commits to the remote repository. Create a pull request to merge the branch into the main branch, which will be reviewed and approved by the maintainer. When you start a new project, initialize a local Git repository. Then, select the files you want Git to track, move them to a staging area, and perform an initial commit. Create a blank remote repository and establish a link with your local repository. Push the changes so other developers can clone this remote repository and follow the regular workflow for updating project files. Welcome to Overview of Git Commands. In this video, you will examine some basic Git commands and the functions and applications of basic Git commands. Git commands are used for various purposes, such as tracking and saving changes and sharing your changes with others. Typically, many of these activities are performed through the web interface. Command Line Interface, or CLI, is another option to perform these activities. Let's consider a scenario to understand some general command line commands, such as mkdir, cd that can help in smooth functioning of the project. We will also discuss some basic Git commands, such as git init, git add, git commit, git log, git branch, git checkout, git merge, and git status. Consider you are a part of a web developer who wants the addition of a new HTML file to enhance the features of his web application. In this scenario, you wish to experiment with your codes without disturbing the main code. Let's explore the steps. Let's start by creating a new directory named My Repository by using the mkdir command. The mkdir command stands for Make Directory. Once you have created the directory, navigate to the directory using cd My Repository command. This command is used to navigate into a specific directory. Let us now create a new repository in this directory using the git init command. It sets up the necessary files and data structure for Git to start managing your project's version control. You can create a new HTML file that has the necessary content. Let's say you create index.html file. Now, add this newly created file to the staging area using git add command. This command moves changes from the working directory to the staging area. Now, you decide to commit the addition of the new HTML file with a message. For this, you use the git commit -m command that takes your stage snapshot of changes and saves them to the project with a descriptive message. This message explains the purpose of the git commit. So, in this case, created a new HTML file can be your commit message. If you wish to review the commit history to confirm the commit is recorded, run the git log command. It enables you to browse previous changes made to a project. Here, your commit history will reflect created a new HTML file. Now, what if you want to experiment with your code, but you do not want to disrupt the current flow? Let's learn to create a branch using git branch command. To work in the isolation, you can use git branch command that lists, creates, renames, and even deletes branches within a Git repository. So, say you want to create a branch called code list. For this, you may use the git branch command. To switch to the newly created branch to start the development, use the git checkout command. The git checkout command lets you switch between the existing branches. You can now make the changes to the index.html file in the code_list branch. Once done, run the git add changes to add the newly made changes in your file to the staging area. As stated earlier, let's now commit the new changes made in the code_list branch with a descript message such as updated index.html file in branch. Let's now browse the commit log in the code_list branch using the git log command. Your output will now display updated index.html file in branch. To see the status of all the changes you made in your Git working directory, let's run the git status command. This command git provides information about the state of your files in relation to the repository. Finally, git merge lets you put everything back together again and merge the feature branch with the main branch. In this example, we will use git checkout command to navigate to the main branch first. Then, use the git merge followed by the branch name, which in this case is the code_list. Let's now recap what you learned. In this video, you learned about the CLI commands that you can use to perform various activities. The commands are mkdir to create a new directory, cd to navigate to a specific directory, git init to initiate a Git repository, git add to move the changes from the working directory to the staging area, git commit to commit the changes to the project, git log to browse the previous changes, git branch to create a new branch, git checkout to switch between the existing branches, git merge to update the branches with the master branch, and git status to see the status of your working directory. Welcome to the video demo, working with branches using Git commands. In this video, you will examine the functions of various Git commands and how to manage Git branches using commands. Branches allow you to work on features, experiments, or fixes independently in a structured and organized manner. The Git branching workflow is crucial in version control and collaboration when working on software development projects. The workflow allows the teams to work on different features, bug fixes, or experiment in isolation without disrupting one another's code. Let us now focus on how to efficiently use Git commands to facilitate the branching workflow process. To do so, first, let us clone the repository so that you can have a copy of that repository on your local machine. Navigate to the GitHub repository, then click Code and copy the URL under the HTTPS section in the terminal window and change to the target directory when you want to create a copy of the repository. Run the git clone command with the repository URL. Once you have the copy, you can create branches, make changes, and sync those changes. Change to the directory that was cloned. Now, let us focus on the git branch command. Run the git branch command, followed by the desired branch name, to create a new branch so that you can work on it without impacting the main code. Let's say that to create a branch named patch1 adding headers, you will execute git branch patch1 adding headers. The new branch created will be a copy of the branch you are currently on. Note that you will not be taken to the newly created branch automatically. To switch to branch patch1 adding headers, use the git checkout patch1 adding headers command. Now that you are on branch patch1 adding headers, you can make your changes. While on the patch1 adding headers branch, let's say you add a header, such as welcome to KIV, to your index.html file. Next, run the git status command to check the status of your working directory. This will highlight the modifications made to your index.html file. To stage the changes in your patch1 adding headers branch, execute the git add index.html command. This command will specify that the changes are now ready to be committed. You can finally run the git commit -m command with the message added header to save your changes. The -m in the git commit command adds a message to your changes. Now, the changes in the index.html file are part of your patch1 adding headers branch's history. Let us now focus on merging the patch1 adding headers branch with the main branch. To do so, firstly, switch back to the main branch by running the git checkout main command. By doing so, you are no longer on the patch1 adding headers branch. Now, run the git merge patch1 adding headers command. This command will integrate your changes from the patch1 adding headers branch into the main branch. The header change from patch1 adding headers is now incorporated into the index.html file located in the main branch. To make these changes accessible in your remote repository, use the git push-u origin main command. This command will push the main branch, including the changes merged from the patch1 adding headers branch, to your remote repository. Finally, run the git status command to ensure the changes have been made and the branch is up to date. That's it! You have come to the end of this video. In this video, you learned how to effectively work with branches using Git commands. You started by listing branches with the git branch command, then created the patch1 adding headers branch using the git branch patch1 adding headers command. Then, you switched to the new branch using git checkout patch1 adding headers command, made and staged changes using git status, git add index.html, git commit -m commands, and finally, merged patch1 adding headers with the main branch using git checkout main and git merge patch1 adding headers. You concluded this exercise by pushing the main branch to your remote repository using git push -u origin main.
Welcome to Cloning and Forking GitHub Projects. After watching this video, you will be able to clone and sync repositories, fork a project to make a base for a new project, use Git commands to communicate with other developers. GitHub has over 100 million existing repositories, including some very useful projects. Whether you are joining a team or basing your own project on prior work, some of the most powerful tools are forking and cloning a repository. Cloning generally refers to creating a copy of a repository on your local machine. Cloned copies can be kept in sync between the two locations. Forking allows you to modify or extend a project without affecting the original project. Frequently, this is used to take an existing project and make it the starting point for your new project. To clone a GitHub repository, navigate to the repository that you want to clone. Under the repository name, click Code. In the Clone with HTTPS section, click the Clipboard button to copy the URL. To download the source code, you can click Download Zip, but without the version control information. On your local machine, open a terminal window and change to the directory where you want the clone to be copied. Type git clone followed by pasting the URL that you copied above, and then press Enter to execute the cloning. When you have made your changes and are ready to sync your code back to GitHub, first, you must run the git add files command. This moves the changed files into a staging area on the GitHub repository. The staging area is an area where commits can be formatted and reviewed before completing the commit. Next, when you are ready, run git commit-m message, and this will commit changes in the staging area. When you are ready to move your changes fully into the GitHub repository, use the get push command. This will push all the committed changes into the repository. Remote repositories are repositories that are stored elsewhere, on the internet, on your network, even on your local computer. You can have several remote repositories, each of which generally is either read-only or read-write for you. Collaborating with others involves managing these remote repositories and involves push, pull, and fetch operations to and from them when you need to share work. Use get push to transfer your changes to the remote repo. Use get fetch to transfer any changes from the remote repo to your local repo. It does not merge those changes to the branch you are working on. You can perform a merge manually if you want. Use get pull to transfer any changes from the remote repo to your local repo and merge them to a branch. Developers use the terms upstream and origin when talking about remote repos. Origin generally refers to your fork, and upstream refers to the original work. These are the norms. You can, of course, name them anything you like. Forking is used to take a copy of a GitHub repository and use it as the base for a new project. You can also use forking to submit back changes into the original repository. This is also used to independently make changes to a project. In that instance, when you are satisfied with your changes, submit a pull request to the original project owner. They can decide whether or not to accept your changes. It is often a legal requirement to keep a copy of the license file. Even if no legal requirement exists, it's good practice. Navigate to the repository that you want to fork. In the top right corner, click the Fork button. To keep a fork in sync with the original work from a local clone, first create a local clone of the project. To configure Git to sync your fork, open a terminal and change to the directory containing the clone. Type git remote-v. This gives you the remote repository. Type get remote add upstream with the pasted-in directory that you used in creating your clone. Adding upstream adds the original repository as a new remote repository labeled upstream. If you type git remote-v, you'll see the change reflected. Other commands of interest include get fetch upstream to grab upstream branches, and Git merge upstream master, which merges changes into the master branch. You will also see Git pull upstream, used to fetch and merge the remote branch in the same step. Git pull upstream reduces the number of steps to sync with a remote branch, but the automatic merges are not always desired. In this video, you learned GitHub has over 100 million existing repositories that you can use. You can clone a repository to copy it to your local machine and sync changes back to the original repository. You can fork a repository to use it as the base for a new project or to work on a project independently.
Welcome to Cloning versus Forking. Until now, you have delved into the concepts of cloning and forking, but have you ever paused to think about their differences? In this video, you will learn the difference between cloning and forking repositories and when to use them. You will also describe the cloning and forking workflow. GitHub allows multiple developers to collaborate on their codebase in parallel. A project in GitHub.com resides either as a public or private repository. Each developer working on that project may have their own copy of the repository on their computer, which they refer to as their local repo, and one that is on GitHub.com, which they refer to as the remote repo. Let's say you have an existing project named Grand Messaging, and you are looking to create a new or derivative project, Grand Messaging Plus, which offers additional features and improvements over the original. There is no need for you to start creating your codebase again. You can simply fork the existing Grand Messaging project, create Grand Messaging Plus, and develop on top of the existing codebase, offering new and improved features. To fork a public project, you can go to its GitHub project page and select Fork at the top of the page. This fork option is available only while using the web interface. There is no native Git command to create a fork. The repo from which you create the fork is referred to as the original upstream repository. Once you fork the original upstream, the forked copy of the repo becomes the origin, and developers with access to the origin can create clones of it on their local machines. After cloning, you can create branches and easily make changes to the codebase, like adding features, enhancements, or fixing bugs. Finally, you can add, commit, and push your changes to the branch and request to merge the branch with the main branch in the origin. However, it is important to note that the synchronization of changes using push and merge can only be done with repos that the developers have write access to. But what if you want to contribute your changes back to the original upstream that you do not have write access to from where it was forked? In that case, you can submit a pull request for your proposed changes by selecting New Pull Request from the Pull Requests tab. The maintainers of the upstream project can review the changes in the pull request, provide feedback, and merge accordingly unless there are any conflicts to be resolved. Now let's look at how you can create branches and synchronize changes. To create a branch, you can use the git branch command, and then make the branch active using the git checkout command. Once changes are made, save and stage them using git add and git commit. After the intended changes are completed, you should set up an upstream branch for the newly created branch and push the changes to the new branch. Then, you raise a request to the maintainer to merge the changes in the new branch to the main branch after reviewing it. Let us revisit the forking workflow. First, you create a fork of an upstream project, which then becomes the origin. The developer can create clones on the local machines, make changes, and then use git push to push the updated main branch back to the origin by creating pull requests. The upstream project maintainers review the changes and then merge if there are no conflicts. One thing to note about the git merge command is that it lets you take independent lines of development in git branches and integrate them into a single branch. Now, let's say a new developer joins your project to upgrade the Grand Messaging to Grand Messaging Plus. How are you going to share the remote repo with the new developer to collaborate on the project? This is where cloning comes to your rescue. You can clone any public repo in GitHub or a private repo that you have access to by going to that repo and selecting the Code button. You can then get the entire codebase of the remote repo in various ways. GitHub also gives you the ability to copy the HTTPS URL and then execute the git clone URL command from your local machine. After cloning, you can follow the same process of updating your codebase and merging with the main branch. Let us quickly look at the entire clone workflow. Cloning comes into the picture once you have forked your repo and it has now become the origin. You then use the origin to create an identical copy of the remote repo using the git clone command that the developer can use on their computer. Then, the new developer creates a new branch, makes changes, and saves them using add and commit operations. After that, they push the new branch to the origin to get their changes reviewed. A reviewer or maintainer uses the git fetch or git pull command to get the latest copy of the repo and the git diff command to help identify and compare the changes in the branch. Once reviewed, they can use git checkout and merge the branch to the main. Lastly, anyone with maintainer access can create a pull request to the original upstream to initiate the changes in the original repo. Let's recap. In this video, you learned that if you want to create a derivative project from another project as the starting point, you can choose to fork a project. The repo that you fork from is referred to as the upstream repo. To contribute your changes back to the upstream project, for which you do not have write access, you can submit a pull request, commonly referred to as PR. The maintainers of the upstream project can review the changes in the pull request, provide feedback, and merge accordingly unless there are any conflicts to be resolved. You can create an identical copy of the remote repo using the git clone operation. The remote repo from which the project is cloned is also referred to as the origin. To create branches and synchronize changes, the git commands used are git branch to create a branch, git checkout to activate the branch, git add and git commit to save changes, git push to push the branch to the remote repo, and git merge to merge the changes to the main branch. Welcome to Managing GitHub Projects. In this video, you will identify the common roles of version control or Git in the project and list Git commands to communicate with other developers. You already know that GitHub is a popular platform for version control and project management. You require managing your GitHub projects for effective collaboration and project organization. Multiple roles are involved in managing a project: a developer, an integrator, and a repository administrator. A developer working as a participant in a group project needs to learn how to communicate with others and use these commands in addition to the ones needed by a standalone developer. When working with Git, you can use Git commands or a desktop tool such as GitHub Desktop. Git clone is used to create a copy from upstream, a remote shared repository that the developer wants to work on. Git pull and Git fetch are used to pull or fetch the repository from origin to keep up to date with the upstream. Git push is used to push commits to the shared repository if you adopt a concurrent versioning system for the repository workflow. And Git request pull creates a summary of changes for your upstream to pull. An integrator in a group project receives changes made by others, reviews and integrates them, responds to pull requests, and publishes the result for others to use. Integrators use the following commands in addition to the ones needed by participants. Git pull helps you merge with your trusted lieutenants. Git revert will undo any botched commits. And Git push will help to publish the project from the local repo to the remote repo. The repository administrator structures how the repository is organized and how users interact with the repository. They also manage communities, asset types, relationships, categories, and attributes. A repository administrator sets up and maintains access to the repository for developers. They also configure the servers needed for accessing the web services and documentation, define email and index settings, and manage the look and feel of the application. Repository admins can use GitHub Actions to automate software workflows, including continuous integration and continuous delivery, or CI/CD. Let's recap. In this video, you learn that multiple roles are involved in managing a project: developer, integrator, and repository administrator. Each role uses different Git commands to communicate with collaborators. A developer working in a group project uses commands like git clone, git pull, git fetch, git push, and git request pull, in addition to the ones needed by a standalone developer. An integrator in a group project reviews and integrates changes made by others. Integrators use commands like git pull, git revert, and git push, in addition to the ones needed by participants. The repository administrators structure how the repository is organized and how users interact with the repository. They also configure the servers needed for accessing the web services and documentation, define email and index settings, and manage the look and feel of the application. Welcome to GitHub Copilot. After watching this video, you will be able to describe the features of GitHub Copilot and the typical workflow that you might follow when using GitHub Copilot. Imagine you have a friend who teams up with you on a project, helping you write code faster and better by providing hints and suggestions. That would be awesome, right? GitHub Copilot is designed to do exactly this, using the power of artificial intelligence, or AI. GitHub Copilot is an AI-powered tool that assists developers in writing code. It is designed to work as a plugin for various code editors, including Visual Studio Code, and provides contextual code suggestions. Let's look at the features of GitHub Copilot. The first one is code autocompletion. GitHub Copilot suggests whole lines or blocks of code based on the context of the code you are currently working on. It can complete entire functions, classes, or other code structures. GitHub Copilot offers real-time suggestions as you code, making the development process smoother. You can save time on writing repetitive or standard code. GitHub Copilot generates suggestions based on the code context, including function names, variable names, and even algorithm implementation. For example, while coding in a Python project, when you start writing a for loop and declare a variable such as total_quantity, GitHub Copilot can provide suggestions for the loop structure and calculations. It supports a wide range of programming languages and is designed to provide you assistance across various popular languages, such as Python, JavaScript, Java, C++, and many more. GitHub Copilot integrates with various popular code editors and integrated development environments, or IDEs, such as PyCharm. This makes it easy for you to access it from various development environments. GitHub Copilot keeps learning from the shared knowledge in public code, documents, and educational resources. It uses this knowledge to make better suggestions over time. How would you use GitHub Copilot in your work? Let's look at the typical workflow that you might follow when using GitHub Copilot. The first step is installing the GitHub Copilot extension in your Visual Studio Code environment. You can find it in the Visual Studio Code Marketplace. After you install the extension, you will activate the extension within Visual Studio Code. This step typically involves signing in with your GitHub account and allowing the necessary permissions. You will then open an existing coding project or create a new one. GitHub Copilot will work within the context of the programming language and framework you are using. You will begin writing code as you normally would. GitHub Copilot will start to provide suggestions and autocompletion based on the context of your code. For example, when you start writing a function in your code, GitHub Copilot generates function bodies. Another example is where GitHub Copilot offers autocompletion suggestions for variable names when you begin declaring a new variable. To accept a suggestion, you can use the Tab key or select the suggestion. After generating or editing the code, you will review it to ensure it aligns with your project's requirements and best coding practices. You will test the code to verify that it functions as expected. If any problems come up, you will need to debug the code in the same way you would with any other code. GitHub Copilot does not help you with debugging, so it's important to perform this step to make sure the code works properly. After you are satisfied with the code, you can commit the changes to your version control system, such as Git, and push the changes to the remote repository. Make sure you document any code changes or additions with comments and explanations so that other developers can easily comprehend the code. GitHub Copilot helps you work faster, especially with repetitive or standard code segments. However, remember that it is just a tool to assist you and must not be relied upon for writing critical or complex code. You should use it wisely, review its suggestions, and make sure the code is good, secure, and follows best practices. Let's now recap what you learned. In this video, you learned about GitHub Copilot. GitHub Copilot is an AI-powered tool that assists developers in writing code. It provides features such as code auto-completion and real-time and contextual code suggestions. It supports a wide range of programming languages, popular code editors, and IDEs. GitHub Copilot keeps learning from shared knowledge to make better suggestions over time. You can install the GitHub Copilot extension, activate it, and use it for existing projects or new projects. You must review the suggestions from GitHub, address any issues through debugging, and make sure the code is good and follow best practices. Welcome to this course about the React JavaScript framework. A recent Stack Overflow survey reports that over 40% professional developer responses rated React as their top web technology. The React front-end JavaScript framework makes coding elegant and dynamic user interfaces efficient and intuitive. Take this hands-on IBM course designed for web and mobile application developers if you want to skill up or start a new career in this field. This course suits both existing and new developers as well as graduates seeking to further establish client-side skills and IT leaders who manage cloud-centric projects. In this course, you will learn to use React to build cross-platform, interactive, user-friendly client-side web applications. The framework uses a special markup language called JSX that is closely related to HTML. You'll build function and class components and apply this modular coding method to handle data and user events effectively. You'll use components to manipulate the DOM and for form management with hooks and the Redux library. You'll explore the usefulness of hooks, states, props, and the Redux library in conjunction with components to create robust interfaces written with easy-to-read code. You will learn how to build client-side React applications through instructional videos reinforced by hands-on labs. You assess your learning with practice, graded quizzes, and strengthen your knowledge with reference materials such as glossaries and coding cheat sheets. A culminating practice and final project in the last module provides you with the opportunity to apply your knowledge to build a complete React application. You can readily share this project in your portfolio from your GitHub account with potential employers to showcase your talents. Each module has one or more hands-on projects. These labs reinforce the instructional videos by applying what you've learned in realistic project scenarios. Lab topics include building a content rating application with like and dislike capabilities, an event planner, a to-do list application, fetching data from a database, and rendering e-commerce data. Then, in the final module, you'll integrate all of the skills learned throughout the course in a culminating project in a shopping cart app. If you want more guidance before the final project, you can develop an event expense planner application. For you to succeed in this course, you should have a working knowledge of HTML and CSS. Additionally, you should know fundamental programming concepts in a language such as JavaScript or Python. You will use Git and GitHub as your code repository. To learn these skills or about various ecosystems of which React is a part, consider taking one of the multiple programs containing this course if you aren't already enrolled. These programs include IBM Full Stack JavaScript Developer Professional Certificate, IBM Full Stack Software Developer Professional Certificate, IBM Front-End Developer Professional Certificate, Cross-Platform Mobile App Developer Professional Certificate, JavaScript Programming with React, Node, and MongoDB Program, Cloud Application Development Foundations Program. So there is a lot to cover here. To get the most from this course, watch each video, complete all hands-on labs, and check your learning with each quiz. We're very happy to have you with us as you start your developing front-end applications with React journey. If you have any trouble with any of the course material, please don't hesitate to contact us in the discussion forum. Let's get started. Welcome to Introduction to Front-End Frameworks and React. After watching this video, you will be able to compare libraries and frameworks, define front-end frameworks, describe React's prominent features. Nowadays, developers are widely adopting React to build modern web applications. But before exploring the concept of React, you should first understand the fundamentals of libraries and frameworks. You will use libraries and frameworks frequently in software development, each serving unique roles and purposes. Let's discuss each of them. A library is a repository of pre-written code segments that provides reusable functions and routines for utilization by other programs or applications. These libraries often target specific tasks or functionalities, allowing developers to integrate them into their codebase as required. Examples of JavaScript libraries include jQuery, Lodash, D3.js, and React. A framework is a comprehensive software development platform that provides a foundation and structure for building entire applications. Unlike libraries that offer specific functionalities, frameworks impose a particular architecture and provide tools, libraries, and guidelines to streamline the development process. Frameworks address broader concerns, including handling user requests, managing data flow, and structuring the application's overall architecture. Some popular examples of JavaScript frameworks include Angular.js, Ember.js, Svelte, and Vue.js. When it comes to web development specifically, a specialized type of framework emerges, the front-end framework. These frameworks focus on building the user-facing side of web applications. Front-end frameworks leverage technologies like HTML, CSS, and JavaScript to create dynamic and interactive user interfaces, UIs, that communicate with the server behind the scenes. A few popular front-end frameworks are React, Angular, and Vue.js. React is an open-source JavaScript library developed by Meta, a company that runs Facebook and Instagram. It facilitates the creation of dynamic and interactive user interfaces for web applications. The prominent features of React include component-based architecture, declarative syntax, virtual DOM, one-way data binding, JavaScript XML, JSX, and hook employment. React's flexible component-based architecture enables the creation of reusable UI elements. In React, developers build UIs by composing independent components representing a specific web page feature. For example, developers can divide a website with headers, left and right sidebars, or footers. This modular approach allows developers to encapsulate UI functionality in individual files, making it easy to reuse components across multiple pages without duplicating the code. React uses a declarative syntax that updates how the UI should behave when data or states change. This declarative paradigm lets developers focus only on specifying the intended UI behavior, while React efficiently manages the underlying DOM. In essence, developers instruct React on what to do rather than how to do it. React also utilizes a virtual DOM instead of direct manipulation. React generates virtual DOM copies when changes occur in any component and then compares them with the real DOM, updating only the essential segments. This strategy optimizes performance and improves speed by minimizing unnecessary DOM modifications. Next, React implements one-way data binding, ensuring data flows unidirectionally from parent to child components. This approach simplifies data management, reducing the risk of bugs caused by an inconsistent state. React also utilizes JSX, JavaScript XML, a JavaScript syntax extension enabling HTML-like code within JavaScript. JSX makes creating and visualizing UI components easier, seamlessly integrating HTML and JavaScript. React employs hooks, a feature introduced in React 16.8. Hooks allow developers to handle states and other React features seamlessly, eliminating the need for class-based coding. Hooks simplify component logic, promote code reuse, and make it easier to manage stateful behavior. In this video, you learn that libraries offer reusable code components, while frameworks provide a comprehensive structure for building applications. Front-end frameworks focus on building the user-facing side of web applications. React is an open-source JavaScript library developed by Facebook that facilitates the creation of dynamic and interactive user interfaces for web applications. React features include component-based architecture, declarative syntax, virtual DOM optimization, one-way data binding, JSX integration, and React hooks employment. Welcome to a video on the React structure. After watching this video, you will be able to describe the Vite build tool to create React projects, list the steps to create a React project, list the directories and files in a React folder structure. You can create a React project using the CRA tool as shown in the code. This code will also install some files and folders you may not require for the project. As a result, this tool can lead to a large file size. React officials have now come up with a new tool, Vite. Vite is a build tool that is an improved development tool for front-end projects in the current web development scenario. You can use it with React, Angular, or plain JavaScript, as well as any new JavaScript library or system. Vite is a tool that speeds up the building and development of web projects by making optimum use of how current browsers handle JavaScript modules. The handling is done by bundling code only when required, which speeds up time for programming and building. To create a project with the Vite tool, use the following steps. 1. Write npm create command in the terminal of your code editor. 2. Give the project name. A list of frameworks will be displayed. Select React using arrow keys. 3. Next, select JavaScript as the scripting language in which you want to work with. A folder will be created with the given project name. 4. The terminal will give you the following instructions to start working on your project. cdlearning_react will navigate you to the precise location of your React project. npm install will install all essential files and packages needed to run the React project. npm run dev initiates the React application, facilitating its rendering within a web browser. 5. The link and port number will be displayed, using which your React application can be opened in any browser. 6. The command npm run dev will display the output as shown. Now let's understand the folder structure of React. Navigate inside the React project from the Explorer section of your code editor, which will show this structure. After creating a React project with Vite, the folder structure consists of the following directories and files. The Node modules directory contains all the dependencies installed through npm or yarn. The public directory contains static assets like HTML files, images, and fonts. The HTML file serves as the entry point for the React application. The src directory contains the source code for the React application. Inside the src folder, you will have app.jsx, app.css, main.jsx, and index.css files. Main.jsx is the entry point for the React application. It renders the root component into the HTML file located in the public directory. App.jsx represents the root component of the React application. It may contain other components and logic to compose the UI. This will contain the boilerplate template for React. The other files in the structure are as follows. Package.json contains metadata about the project and dependencies. It also includes scripts for running, building, and testing the application. Vite.config.js contains configuration settings for the Vite build tool, such as customizing the build process, specifying plugins, and configuring development server options. .gitignore specifies which files and directories should be ignored by Git version control. README.md file provides information about the project, including setup instructions, usage guidelines, and project documentation. Index.html is a fundamental part of web development projects, serving as the entry point for web applications. The slint.rc.cjs file is a configuration file used by ESLint, which is a popular linting tool for JavaScript. The .cjs extension indicates that it is a common JS module, which means it follows the common JS module format for Node.js applications. Now, you can start building the application by creating more folders and files. In this video, you'll learn that Byte is a build tool which is an improved development tool for front-end projects in the current web development scenario. Byte handles JavaScript modules by bundling code only when it's required, which speeds up time for programming and building. After creating a React project with Byte, the folder structure consists of many directories and files like node modules, public, src, main.jsx, app.jsx, package.json, and so on.
Welcome to Expert Viewpoints, using front-end JavaScript frameworks. In this video, we will listen to several application development professionals discuss working with front-end JavaScript frameworks. So, which front-end JavaScript framework or frameworks do you use, and why do you prefer those over other options?
My favorite front-end JavaScript framework would be React.js. I love the whole component-driven design and architecture that you have to follow when you create a React.js based application. I also like the idea of props and states to hold the state of your application. Believe it or not, I also like the concept of having all of my style, my HTML or JSX for a component in the same file. It makes it really easy to work with components by themselves, and then at the end, plug these different components together to create my application.
We use React JavaScript framework. It is better than Angular in terms of speed and efficiency. React is easier to learn than other JavaScript frameworks, which makes its adoption in the team easy. It also resolves the problems related to cross-browser issues. Another great feature of React is the use of JSX. JSX is helpful when working with UI inside the JavaScript code. It helps React to show more useful error and warning messages.
So among the front-end JavaScript frameworks, I prefer Vue. I just find it friendlier. I like the documentation. However, React has a big community and the documentation is very extensive, and it makes sense. And another benefit of React is that there's React Native. So if you're really comfortable with writing React, you can repurpose that code to be a mobile application that's cross-platform compatible, which is a huge benefit. And if you're writing your application in Vue, then you can use something like, there are some ways to make that a web application, like by using a progressive web app, but React Native out of those three, Angular, React, and Vue, by far is the easiest kind of crossover to get into native app development. Angular, it just seems more verbose. I never really got into it except for some student projects, and fortunately I've never had to go into it any deeper than just editing existing code.
Welcome to Introduction to ES6. After watching this video, you will be able to define ECMAScript 6, also known as ES6, and describe how to use new features that have been added to JavaScript as part of ES6. ES is short for ECMAScript. ECMA is a standards organization that creates a wide range of global information and communications technology standards. JavaScript adheres to ECMA specification ES6, which came out in 2015. The newer versions of ES are named after the year of release. The most recent is ECMAScript 2020. ES.next is a dynamic name used to refer to the forthcoming version of ECMAScript. ES6 is a version with changes that had a major impact. In JavaScript, the main changes are let, const, arrow functions, promises, and class. You are familiar with using variables, or vars. A var has a global scope. Once declared, a var can be used or referred from anywhere in the code. This is challenging, especially with huge projects where you have many variables to maintain. In ES6, you use let and const in addition to var. Let allows you to restrict the scope of variables within the block where they were declared. This limited scope is called local scope. In this example, num has scope just within that block. Line 7 will throw an error as num is out of scope. Const allows you to declare constants whose values cannot be changed. Line 3 throws an error because num is defined as a constant whose value is 5. You can use both let and const in React programming. Arrow functions allow you to declare functions the same way that you declare variables. Using this syntax is a shorter and cleaner way to work with functions. What you see here is how a function was written in the older ES5 JavaScript. Below, you can see how it is written in ES6. A function can also be declared with let and const just like a variable. This function does not take any parameters and has only one statement. Notice that there are no curly brackets. Arrow functions are called like normal functions. They can also be passed as parameters for callbacks. Here, the arrow function sayHello is passed as a callback parameter to setTimeout. Arrow functions also take parameters like normal functions. They can return a data type or an object. Here you can see a function that takes one parameter. The function brackets are not mandatory. There is only one line of code, but because the code returns a value, it must be in curly brackets. This is a function that takes two parameters. The function brackets must be put around the parameters list. This function also has just one line of code and returns nothing, so it does not need curly brackets. This is a function that takes two parameters and returns one value. And this is a function that takes two parameters and has two lines of code. The promise object represents the eventual completion of an asynchronous operation and its return value. When you invoke an asynchronous operation, a promise is in a pending state. When the operation executes successfully, the promise is said to be fulfilled. When the operation fails, the promise is said to be rejected. In the first example, you have an arrow function promise argument, which takes two parameters, resolve and reject. If the current time in milliseconds is divisible by 2, this arrow function invokes resolve with success as a parameter. If not, it invokes reject with failed as a parameter. This function is passed to the constructor of the promise object. In the second example,
Instead of defining promise argument separately, the function is directly passed as an argument to the promise constructor.
the behavior in both cases is identical. Object-oriented programming was made feasible in JavaScript with the introduction of class. Class is a template or blueprint for creating objects. Classes in JavaScript are built on prototypes. Prototype is a property of all JavaScript objects, including functions. A function can be used to create an object instance. Here, this refers to the current object, but not all object-oriented programming concepts are available with function prototypes. The concept of class was built on the premise of function prototype to extend object-oriented programming to JavaScript. Here, the first console log will print the entire prototype of the person1 object. The second console log will print the name, and the third console log will print the age. Class can have a constructor, which is a method that is called when you want to create an object of class. The body of the class is the part that is in curly brackets. Here, rectangle is the general class. All rectangles have some height and width, which are the properties. When you create a rectangle object, you pass the height and width as parameters to the constructor. MyRectangle is an object constructed with the rectangle class. In this example, an object of the class can be created using the new keyword. The properties are set to the current object that is being created using this as the keyword. Rectangle is the blueprint. The keyword helps to set the properties for the MyRectangle object. In JavaScript ES6, a class can inherit from another class. The superclass is the class being inherited by the subclass. The subclass inherits all the attributes and methods of the superclass. React components use inheritance to build user-defined components. The subclass has a special privilege to call the superclass constructor with the super method call. A square is a rectangle with the same value for width and height. Here, if the height is not the same as the width specified, the width will become equal to the height. In this video, you learned that new features that were introduced in JavaScript as part of ES6 are let, const, arrow functions, promise, and class. You can create different types of arrow functions depending on the parameters, return values, and lines of code. And object-oriented programming was made feasible in JavaScript with the introduction of class.
Welcome to Introduction to JSX. After watching this video, you will be able to explain the purpose of JSX, describe JSX syntax, explain why JSX needs compiled, summarize the benefits of JSX. Essentially, JSX combines JavaScript with HTML. JSX makes building user interfaces more conceptual. It reads similarly to HTML, yet also supports JavaScript expressions. JSX is short for JavaScript Syntax Extension and is also called JavaScript XML. The JSX syntax looks like XML or HTML, using elements enclosed in angle brackets to indicate how the elements appear on screen to the user. Let us look at some sample JSX code. The code shows a construct that displays the heading, "This is a sample JSX code snippet." The code snippet looks like HTML, but note the JavaScript-like variable, which is neither HTML nor JavaScript. It is JSX. You use JSX syntax to create React elements. React then renders these elements to the document object model, or DOM. Browsers don't understand JSX, so you need to use Babel to compile your JSX code and transform it into standard JavaScript objects. The JavaScript engine then parses these objects. Fortunately, you can use the command create React app to handle the compilation. Let's discuss some benefits of using JSX. To start with, people who don't know JavaScript or other programming languages can more readily understand and modify it. People who use markup languages such as HTML will find JSX more familiar than JavaScript alone. When you use a compiler to transform your JSX, you'll find errors earlier that might be difficult to spot otherwise. JSX helps keep code simple and elegant with its use of inline styles. JSX outperforms JavaScript because it optimizes during the translation to JavaScript. Finally, JSX automatically handles output sanitation issues, such as converting expressions to strings, preventing attackers from embedding an executable script before rendering. Now, look at the code for a React component that uses JSX. Compare it to a regular JavaScript function call. This code creates a div element with a list of 2 items that display items number 1 and 2. The app function contains code that looks extremely similar to plain HTML and uses the same XML-based syntax. This example shows the previous code using JavaScript function calls. You can see how this code is more difficult to read and understand its logic, as well as ugly and difficult to maintain. JSX combines the beauty of HTML with the power of JavaScript. In this video, you'll learn that JSX reads similarly to HTML. JSX uses HTML elements combined with JavaScript expressions. JSX relies on compilers to transform HTML-like text into standard JavaScript objects. The benefits of using JSX include easily readable code, error identification, improved performance, added security. Welcome to Introduction to Components. After watching this video, you will be able to explain what React components are, describe the features of React components, compare and contrast the 3 types of components, and create a Hello World React component. You create React applications with modular chunks of code called components. Components are the building blocks of React applications and make building complex user interfaces easier by breaking down the UI into individual pieces. Then, you merge them into a parent component that forms what the user sees and interacts with. React components enable you to break up the user interface into separate elements. These can then be reused and handled independently. A React component takes on optional input and returns a React object, which is rendered on the screen. The React component renders pieces of the web page. You develop the component's code so it knows how to behave and update when the user interacts with it. This modification of the component is called a state change. You also manage events, such as selecting a button with a component state. A component is composed of 3 aspects: properties, events, and states. You use a component's properties to store and pass data from a parent to a child component. Events manage the document object model, DOM, as a result of the user's interaction with the system. You use a component state to update the UI. React has 3 types of components: class, functional, and higher order. Functional components are written like JavaScript functions. They can take arguments and return JSX. Before React version 16.8, functional components were stateless. You can now use function components with states as of the introduction of hooks in version 16.8. Developers generally now prefer function components because they are relatively easy to read and test. This code example shows a simple functional component in React. In the code, the function demo component returns the phrase welcome message as JSX. You can use JavaScript ES6 classes to create class-based components in React. You can pass data from one class component to another class component. They use the main React functions such as state, props, and lifecycle methods. After the introduction of hooks in version 16.8, developers tend to prefer functional over class components because class components are more complex. A higher order component, HOC, allows you to reuse component logic. You can compose components together by taking a component as an argument to another component. It renders the parameter component along with additional features. In this video, you learn that you create React applications with modular code called components. Components break up the user interface into separate parts that you can reuse and handle independently. A React component renders the initial user interface, manages and handles events, updates the user interface according to its state. The 3 types of React components include functional, class, and higher order. Welcome to a video on working with React class components, props, and event handling. After watching this video, you will be able to define a class component, describe how a class component works, describe how to manage the state in the React class component, describe how to use props in a class component in React, describe how to handle events in class components. A class component in React is a JavaScript class that extends the React.component from the React library. Class components were the primary way of defining components in React before introducing hooks. They encapsulate UI components and their behavior into reusable building blocks. Class components are defined using ES6 class syntax, and they manage states, handle lifecycle events, and define component methods within the class. Let's look at a basic example of a class component. In the class component, you first write import statements. Import React, component from React. This statement imports React and the component class from the React package. React is the core library for building UI components in React applications, and component is a base class from which React class components are created. Next, you declare the class, and the class myComponent extends component provided by React. This statement means myComponent is now a React class component, inheriting all the functionality provided by the component class. Then, you use the render method within the myComponent class. This method is required in every class component and is responsible for returning the JSX React elements that represent the UI of the component. In this case, it returns a div tag containing an h1 element with the text "Hello World." JSX allows you to write HTML-like syntax directly within JavaScript code. The final statement is the export statement with the export default myComponent. This statement exports the myComponent class as the default export from this file. It allows other files in the project to import and use myComponent by importing it using import myComponent from myComponent. State management is a crucial aspect of React class components. State represents the data the component needs to render and respond to user interactions. You can initialize the state in the constructor using this.state and update it using this.setState. You can manage the state in a class component as shown in the code. The code defines a class named Employee Details that extends the component class provided by React. In the constructor, the component initializes its state with two properties, EMP-ID and EMP-email, both set to empty strings. This initial state represents the initial values for the input fields, where users can enter their employee ID and email. The component defines a method named handleInputChange to handle changes in the input fields. This method is triggered whenever a change event occurs in the input fields. When the input changes, the method extracts the name and value from the event target, input field, where the name corresponds to the state property to be updated, EMP-ID or EMP-email, and the value corresponds to the new value entered by the user. It then updates the component state by calling this.setState with an object containing the updated property and its new value. React automatically merges this object with the current state, updating only the specified property while keeping other properties unchanged. The render method delivers the component based on its current state. It dynamically binds the value attribute of the input fields to the corresponding state properties, EMP-ID and EMP-email. This binding ensures the input fields display the current values stored in the component state. When the user interacts with the input fields, the displayed values update in real time as the state changes. When the Show Details button is clicked, an alert is triggered, displaying the current values of EMP-ID and EMP-email. The alert directly accesses the state properties EMP-ID and EMP-email to display their values. Since React manages the state, it ensures that the displayed values are always up to date with the current state. In React, props or properties send data from parent to child components. The child component receives the data from the parent component and can use it. The props thus received by the child component are read-only and unchangeable. They can also pass methods or functions from parent to child components. Let's look at a code example. The parent component is organization-details.jsx. Within the JSX, the prop value of employee designation is declared within the class component and is passed to the employee details component as an attribute. The value of employee designation, project manager, is passed as the value of the prop. Let's look at how the child class, employee details, can access the data from the parent class, organization details. In the code, the employee designation prop is accessed within the employee details component by destructuring it from this.props in the render method, as shown in the code. This method allows the child class to access the employee designation prop passed from its parent class, organization details. In the JSX, the employee designation is concatenated with the other values EMP-ID and EMP-email. When clicking the Show Details button, an alert is triggered, displaying the values of EMP-ID and EMP-email and employee designation. Event handling in React is responding to user interactions, such as clicks, mouse over, mouse out, form submissions, and so on, within a React application. For example, event handling is done in the given code using the onClick property in JSX. An arrow function is called when clicking the Show Details button. The values of EMP-ID, EMP-email, and employee designation are used by this arrow function to create a warning message using template literals. This arrow code is run when the onClick attribute is set, showing the user alert message. This method lets you handle events directly in the JSX code, making adding user interactions to React components easier. In this video, you learn that a class component in React is a JavaScript class that extends the React.component class from the React library. Class components encapsulate UI components and their behavior into reusable building blocks. Class components manage state, handle lifecycle events, and define component methods. State represents the data the component needs to render and respond to user interactions. In React, props or properties send data from parent to child components. Event handling in React is the process of responding to user interactions, such as clicks, mouse over, mouse out, form submissions, and so on within a React application. Welcome to Introduction to States. After watching this video, you'll be able to explain the use of states in class components, explain the use of props in class components, compare and contrast states and props. States allow you to change data in an application. In class components, the state object includes key value pairs that specify different types of data you want to track in the application. React class components have a built-in state object. You can store property values that belong to the component in the state object. A change in the state object re-renders the component. React components have two types of state in an application, local and shared. Local states live in a single component and cannot be accessed by other components. A component that shows and hides information would use a local state. A shared state can be accessed and changed by more than one component. A list of orders in an ordering application would likely be a shared state. A class component state is a plain JavaScript object used by React to represent information about the component's current situation. The heart of every React component is its state. States determine how a component renders and behaves. A state allows you to create dynamic and interactive components. In class components, the state is an instance of the component class with a set of observable properties. These properties control the behavior of the component. You manage and preserve the state in the React component. In other words, you control the state of a component with an object that contains information that may change over the component's lifecycle. If your component changes or needs to change during user interaction, you use its state. A state allows you to track the change in the component. This includes updates to forms, buttons, and timers. For example, consider a simple application with a button and a counter. When the user presses the button, the counter variable increases by 1. As the count changes, you hold that value in the state. This code example shows how you can create a test component that contains the state with attributes such as ID, name, and age. The component's render function returns the state attributes name and age. Props is short for properties. You use props to pass data between components. React's data between components flows from parent to child only. Props are read-only components. Prop objects store the value of attributes of a tag and work like the HTML attributes. They behave like arguments to functions that you can pass from one component to another. Props are immutable and cannot be modified from inside the component. If a variable gets modified during a process, it should belong to the component state. You can also use props to allow child components to access methods defined in the parent component. You should manage the state in the parent component. The child component does not have a state of its own. Let's look at an example with props. This code creates a class named test component that extends the React component. It renders props that accept the name attribute. Then, you can pass props to the test component that accepts different names like John and Jill. Let's compare states and props. You cannot access or modify the state of a component outside of the component. Props, on the other hand, make components reusable by allowing a child to receive data from its parent. Components create and manage their own data with their state, whereas they receive data from outside with props. You use a state to manage data and props to pass data between components. You can modify state data within the component, but cannot access it outside of the component. Data from props is read-only. You cannot modify using another component. You can modify a state using the setState method, whereas you can only pass props from a parent component to a child in a unidirectional flow. In this video, you learn that a state is a JavaScript object that represents information about the component's current situation. The state allows you to create interactive components. Any changes in the state data cause the component to re-render. You use props to pass data between components in a unidirectional flow from parent to child. Components create and manage their own data with their state, whereas they receive data from outside using props. Welcome to the class component lifecycle. After watching this video, you will be able to explain a component's lifecycle, describe each phase, and list methods used in each phase. React class components have life cycles, meaning they go through 3 phases over their lifetime. During each phase, React provides lifecycle methods you can access. A component's lifecycle has 3 main phases. These phases include mounting, updating, and unmounting. In the mounting phase, you instantiate the object using the component class constructor and assign it a default state. In the update phase, the states and props of a component change due to user events. Changes can also occur within the component due to a change in the backend. The component re-renders in this phase. Finally, there's unmounting. As the name suggests, the component is removed from the page. The component lifecycle refers to the component's relationship with the DOM. The component lifecycle starts when components are created and mounted on the DOM. Once mounted, React updates the DOM according to the component logic. Then, the components die when the system unmounts them from the DOM. React automatically calls the responsible method according to its phase. Although React automatically invokes these methods, you can manipulate them to gain more control over component behavior. 2 of the methods used when the component mounts include component will mount and component did mount. The rendered method is also called for the first time. The system invokes the component will mount method prior to the first execution of the render function. The system invokes the component did mount method right after the render function executes for the first time. Methods specific to the update phase include get derived state from props, get snapshot before update, and component did update. You use the get derived state from props method if you have updated props and want to reflect that in the component state. Another method, get snapshot before update, gives you access to the component's previous props and state before updating. The last method invoked in this phase is component did update. This method allows you to create side effects, such as sending network requests or calling the this.setState method. You will also call the render method, but this method does not exclusively belong to this phase. The render method in this phase updates the component in the UI. The unmounting phase has only one lifecycle method, component will unmount. The system invokes this function before removing the component from the page, denoting the end of its lifecycle. This method performs necessary cleanup, such as canceling network requests or removing listeners. In this video, you learn that a component's lifecycle refers to its relationship with the DOM. The 3 phases in the lifecycle include mount, update, and unmount. In the mount phase, the methods include component will mount and component did mount. Methods invoked during the update phase include get derived state from props, get snapshot before update, and component did update. In the final unmount phase, React calls the component will unmount method. The render method is called in both the mount and update phases.
Welcome to passing data and states between components. After watching this video, you will be able to describe the lifecycle of React components and explain how to pass data and states to components. Each React component has 3 phases in its lifecycle. Mounting is when the component is first created. Updating is when the component is rendered on a change of state or properties, props. And unmounting is when the component is removed from the document object model or DOM. In mounting, 4 methods are called in this order: The constructor method constructs the object. This may call the superconstructor with the props object if any specific props are being set. The getDerivedStateFromProps method is used only when the state depends on the changes to props. The render method is mandatory in a React component. This method makes the component appear. It must return a DOM element, and it can return only one root element which may or may not have many nested child elements. The componentDidMount method is invoked immediately after a component is mounted or inserted into the DOM tree. When the componentApp method is created, the constructor is invoked. The constructor first calls the super and then logs on to the console. Then the render method is invoked. This method logs on to the console and then renders the component. And lastly, the componentDidMount method is invoked. You can see this in the order of the console logs in the page rendered. In updating, 5 methods are called in this order. The getDerivedStateFromProps method is used only when the state depends on the changes to props. The shouldComponentUpdate method by default returns true. Every time there is a change in state, this method is called to check if the component should update. It is not called during the initial creation of the component. Make this method return false only if you don't want to render the changes in state. The render method is the same render method used in mounting, but here updates the component. The getSnapshotBeforeUpdate method is invoked just before the changes are rendered. It helps keep track of what has changed. Any value returned by this lifecycle will be passed as a parameter to the componentDidUpdate method. And componentDidUpdate is invoked immediately after updating occurs. When the state of the component app is changed, it is updated. Consider an app component with a click counter maintained as the state. With the on-click of the button, increment counter is invoked, increasing the counter state by 1. Every time the state changes, the component is re-rendered, but this can be controlled. The shouldComponentUpdate method returns true by default. This method is rarely overridden, that is, its behavior is rarely changed. It usually inherits from the superclass and returns true. The render method logs on to the console and then renders the component. Lastly, the componentDidUpdate method is invoked. You can see this in the order of the console logs in the page rendered. When a component is unmounted or removed from the DOM tree, the componentWillUnmount method is called. In this example, you have 2 components, AppInner and App. AppInner is rendered inside app with a state. ComponentDidMount of the app component's mounting phase is handled, and a timer for 5 seconds is started. After 5 seconds, a callback is invoked, changing the state of the inner component to a div element instead of the AppInner component, which removes or unmounts the component. Then componentWillUnmount of AppInner is called. You can see this in the order of the console logs in the page rendered. You can pass data between React components. Consider the relationship between components. 3 types of relationships are parent to child using props, child to parent using callbacks, and between siblings using Redux. Redux is not within the scope of this module. Here you have 2 classes, AppInner and App. The App component contains the AppInner component. App is the parent and AppInner is the child. App sets the property color and name for AppInner. The data is passed to the child every time a new value is entered in the input boxes in the parent. On the browser, when the component loads, you see the default name John and color green. When the values of color and name are changed in the parent component, they are passed to the child component, which is re-rendered. Here, you will pass data from child to parent. You pass a callback to the child as a property, and then, through the callback, pass data to the parent. Callback is a normal method, but is called at a later time when a condition is met. In this example, app is the parent component, which contains a child component, AppInner. In the parent, you pass the callback func1 as a property to the child. Func1 is a parent component function which takes a string argument. On component didMount of appInner, you invoke the sendData method. This method invokes setInterval at a 1-second interval. SetInterval takes a callback as a first parameter and a second interval in which the callback should be invoked as the second parameter. In this case, every 1 second the current time is obtained and the method set as parent callback is invoked, passing the time. The method set as parent callback is the parent class method which sets the state of the parent component, thereby re-rendering it. You can see the current time being passed from the child to the parent through callback. The parent is re-rendered every second. In this video, you learned that each React component has 3 phases in its lifecycle: mounting, updating, and unmounting. When a component is created or updated, methods are called in the same order. And you can pass data between components from parent to child using properties, from child to parent using callbacks, and between siblings.
Welcome to Working with Function Components, Props and Event Handling. After watching this video, you will be able to explain the value of props and default props in components, summarize how to use props to pass data between components, describe props principles, discuss how events work in conjunction with props. In function components, properties are referred to as props. Primarily, props allow you to pass data from one component to another. Essentially, a prop works similarly to an object. A prop stores the attributes of a component and allows you to pass these attributes from a parent component to its child. However, you should note that you cannot change these attributes. Props are immutable, meaning the data is read-only, and you cannot change them within a child component. In this example, this app component functions as the primary component of the project. Inside the app function component, data gets passed into a child component named employee data. The app's return statement assigns the employee data component's name attribute to John. Note that these examples do not include import or export statements. Now, examine the employee data component, shown here. You can see the props parameter passed into the component. You could provide any object name instead of props, but conventionally, you should use props to improve readability. Inside the h1 element within the return statement, you use the name with the dot operator. The props object contains all the properties passed to a component. When you use a component and pass it an attribute, such as name equals John, that attribute becomes a property of the props object within the component. You can also pass the data in other formats as well. In this example, change the app component's return statement. Notice that in this version, you declare a const named employee ID and assign the value 111. You can pass this prop dynamically to the employee data component using curly braces. Also, the key department ID prop is set to the static value 567 directly in the return statement. To do this, use curly braces around the 567 prop value. The structure discussed establishes the foundation for rendering UI elements and passing data within the React application. You can then access these details using the props object and render these attributes on the front end using the dot operator. You can define default values for a component's props. If the parent component does not provide a value for a particular prop, its child component will use the default value specified in the child component's default props object. This statement appears immediately before the export statement. The default value of the employee data component ensures consistent rendering even if you do not explicitly provide these values in the parent component. In this case, if the parent component does not pass in the det_name attribute, the component supplies the default value, human resources, to the department name prop. The principles behind the usefulness of props and function components include reusability, unidirectional data flow, customization, and composition. Let's discuss each of these. Regarding reusability, passing different props allows you to create variations of the same component without duplicating code. You can customize the behavior and appearance of your components based on different conditions or data. The unidirectional flow of data makes it easy to see how data gets passed and updated throughout your application, enabling errors to be spotted easily. Props enable customization. You can write code that is simple yet robust. You can use the same components, but the props provide flexibility. Props facilitate component composition throughout communication among these simpler components to build complex UIs. Let's also consider using event handling with props as an example. In this app example, we pass an attribute named increase with a value of $10,000. In this component named props, the useStateHook manages the state of the showIncrease value. Showing an increase determines whether or not to display the annual salary increase information. Hooks and states are important parts of React function components. Here's how the useStateHook and the click event work in the component. The useStateHook creates state variables. In this case, the showIncrease state variable holds a Boolean value indicating whether the app should display the annual salary increase data. When the user selects the Display Annual Salary Increase button, it triggers an arrow function defined within the onClick event handler. Call the setShowIncrease true inside this arrow function. This function sets the state of showIncrease to be true, indicating that the UI should display the annual salary increase. The component uses the conditional double AND expression for conditional rendering. If showIncrease is true, the yearly increase information displays within a div element. Otherwise, the component does not display this value. This image shows the output of this code. You can see that when the showIncrease Boolean value is false, the increase amount is not displayed. When the user clicks the button label changes, and the UI displays the value of the increase attribute. In this video, you learned a prop stores the attributes of a component and allows you to pass these attributes from parent to child. You pass a props object as a parameter into a component. Define the data using the dot operator in the format props dot attribute name. Props principles include reusability, unidirectional data flow, customization, and composition. You can use the useStateHook in conjunction with an event to control a child component. Welcome to Component Composition. After watching this video, you will be able to describe the purpose of component composition, explain principles of function component composition, provide an example of component composition. You can combine multiple components using composition. With function components, you combine multiple smaller components to create complex functionality. You can build a larger UI structure using small building blocks. Let's discuss a few principles of function component composition, including abstraction, reusability, hierarchy, props and children, and higher order components, also called HOCs. Let's discuss these aspects, starting with abstraction. The abstraction principle means you can make reusable components that encapsulate UI features. It provides a way to break down a large abstract UI into smaller chunks of code. Component composition allows you to reuse these chunks of code, making it easier to organize and maintain. You avoid duplicating the same code. The hierarchy principle allows you to arrange components in a hierarchy with parent and child components. This hierarchical structure also assists with organization and modular design. Component composition allows you to pass data from one component to another easily. Props allow you to pass data from a parent component to its child. Components allow you to pass the entire component into other components. You can write functions, called higher order components, that accept components as input or return a component with enhanced functionality. Higher order components allow you to add components features such as state management or logic without modifying its implementation. Let's walk through an example demonstrating the use case of these composition principles. Consider a blog for writing about novels. The following code examples encapsulate specific features to create a generic blog post for novels, such as title, author, type, and description. In a real application, you would organize these components into separate files for better code organization and maintainability. In this example, each component implements one feature. Each primary feature has a similar structure. Let's take a look. Here, you see the title component. Notice the structure. Import the React library. Define the function with its name and its parameter. Return the formatted content. Export the component. Recall we need additional components for author, type, and description. Let's look at these in comparison to the title component. Here's the author component. Note the similarity in their structures. You simply replace the function name and its parameter. Then you format the content with appropriate HTML tags. Last, you change the name of the exported component. Similarly, you make the same replacements with the description component. Change the name of the function, change the HTML, and change the export statement. And same for the type component. Change the function name, the HTML, and the name of the exported component. Now let's look at the code for a higher order component. This component pulls in the other components to create a page containing all of the data and formatting. Note that each component we discussed gets imported: title, author, type, and description. You name the function novel blog, then take each imported component as the function's parameters. You return the component styled with appropriate HTML tags. This component is a function that takes components as its parameters and then returns a more complex component. Then finally, you will see the main application component code here. Let's walk through it. You import the components into the main app component, where you define the app function and compose them to create the front end. You create an instantiation of the novel component with appropriate data for the title, author, description, and type components. In this lesson, you learn that you use component composition to combine smaller components to create a complex UI. Principles of component composition include abstraction, reusability, hierarchy, props and children, and higher order components. Welcome to State Management in Function Components. After watching this video, you will be able to explain the concept of state management, explain the value of state management when developing function components, describe the syntax of the useState hook, manipulate a component state using the useState hook. In React, you will use states to manage data that can change over time within a component. A component state refers to the condition of that component at a specific time. The state of an object holds information that influences its behavior and renders it based on that information. Before the introduction of hooks, React could not manage the state of function components. Now, function components have local state management capabilities. You will see a demonstration of the useState hook function in this video. Hooks enable you to reuse code logic across components without changing component hierarchy or introducing unnecessary nesting. They also make it easier to share and compose functionality across different components. Let's look at a commonly used hook named useState. The useState hook allows you to add state management functionalities to function components. It returns a stateful value using one variable and a function to update the value of that variable. You can see the syntax here. You call the useState function and pass in the initial state as a parameter. Assign the return value to a const array variable. The array has two values, the state name and the state name prefixed with the keyword set. Let's take a closer look at each of these tokens. This syntax uses array destructuring for the const variable. Array destructuring allows you to extract values from an array and assign them to individual variables. Using this feature to assign variables with an array simplifies your code when accessing array elements by avoiding repetitive indexing. In this case, it extracts two values from the array returned by useState and assigns them to variables named stateName and setStateName, respectively. The stateName variable stores the current state value. This variable represents the current state of the component. You can access it and update it as needed. You can use the setStateName function provided by the useState hook to update the state value. When you call setStateName, React will re-render the component with the updated state value, triggering any necessary UI updates. You pass the initial state value into the useState function as a parameter. This value initializes the stateName variable when first rendering the component. Next, you will see this syntax demonstrated with an example. Let's look at the code used to develop a UI similar to what is shown here. Before the user selects the button, the interface displays, "The name is John." After the button selection, the interface will display, "The name is John Doe." You can use this component, state management, to manage and display the component state with the useState hook. The component imports the necessary dependencies from the React package, including React and the useState hook. Inside the component function, you declare a state variable name function, setName, to update the namestate variable using the useState hook. The code sets the initial value of the namestate variable to John. The useState hook returns an array with two elements, the current state value of the name variable and a function, setName, to update that state value. You use array destructuring syntax to assign these elements to variables. The component returns JSX elements encapsulated within a fragment. It includes an H1 element displaying the title, State Management using useState, and a paragraph element showing the current value of the namestate variable using JSX interpolation. Next, we take a closer look at the purpose of setState. Say you initialize the name value to John, as in the previous example, and now you want to update the user's name from John to John Doe when the user selects a button. In this code, we named the object setName. You should use the setState function for this. This code adds a button element to the JSX returned by the component. This button has an onClick event handler attached to it. When the user clicks the button, it calls the updated name function, which in turn calls the setName function embedded in the updated name function with the argument John Doe. The setName function updates the namestate variable to John Doe. As a result, after pressing the button, the component re-renders and displays the name John Doe. After the button click, it becomes disabled with the help of the button-clicked useState variable. Let's examine another example where you define a component named toggleMessage. You could use this component to show or hide a message. Inside the component, use the useState hook to declare a state variable named isVisible and initialize it to true. This variable represents the visibility state of the message. Define a function toggleVisibility that toggles the value of isVisible when the user clicks a button. It negates the current value of isVisible, thus toggling between true and false. The JSX code renders a div element containing an H2 heading, a button, and a paragraph. The button has an onClick event handler that calls the toggleVisibility function when clicked. The button text changes dynamically based on the value of isVisible. If isVisible is true, the button text displays hide message. Otherwise, it displays show message. The paragraph conditionally renders based on the value of isVisible. If isVisible is true, the UI shows the paragraph. This is a hidden message. When the value is false, it remains hidden. In this video, you learned state management allows you to manage data that can change over time within a component. The useState hook enables function components to manage the component state locally. You can use this syntax when using the useState hook. Call the useState function and pass in the initial state as a parameter. Assign the return value to a const array variable using a destructured array. The array has two values, the state name and the state name prefixed with the word set. You should use the useState hook when you need to make a component dynamic and interactive. Welcome to Function Component Lifecycle. After watching this video, you will be able to define functional components in React, recognize the 4 different phases of a functional component in React. In React, functional components are the fundamental building blocks for creating user interfaces. Understanding the lifecycle of functional components is essential for managing the behavior and state of components throughout their existence. While functional components lack traditional lifecycle methods found in class components, developers can achieve similar functions using hooks such as useState, useEffect, and useReducer, among others. The lifecycle of a functional component in React undergoes 4 distinct phases: mounting phase, updating phase, unmounting phase, and error handling phase. The first phase is the mounting phase. During the mounting phase, React initializes the functional component, preparing it for rendering on the DOM. The important steps involved in the mounting phase include initialization, state initialization, and side effects. The first step is initialization. In this step, React runs the function body of the functional component, setting up the initial structure and behavior of the component. After initialization, React performs state initialization. In this step, React utilizes the useState hook to declare and initialize state variables within the component. These state variables hold data that may change over time, triggering re-renders of the component when modified. Let us look at an example. In this example, the useState hook creates a state variable called count, initialized to 0. This state variable can be actively updated using the setCount function, triggering re-renders of the component whenever its value changes. Finally, React performs side effects such as data fetching, subscriptions, or DOM manipulation using the useEffect hook with an empty dependency array. This step ensures that side effects execute only once after the initial render, optimizing performance and preventing unnecessary re-execution. Here is an example. In this example, the useEffect hook fetches data from https://api.example.com/data when the component mounts. It then sets the retrieved data using setData with an empty dependency array to ensure the effect runs only once after the initial render. We will now discuss the updating phase. During the updating phase, React responds to changes in the component state or props by re-invoking the function body of the component. This phase triggers a re-evaluation of the JavaScript XML, JSX, allowing React to determine the new UI to render. Here is an example. In the updating phase of the functional component, myComponent, the useState hook initializes the count state variable to 0 point. On clicking the button, the increment function invokes updating the count state by incrementing its previous value by 1 using setCount. This step triggers a re-render of the component, displaying the updated count value on the screen. The updating phase involves responding to user actions and state modifications, ensuring your UI stays in sync with the underlying data. Let's now learn about the unmounting phase. During the unmounting phase, React executes cleanup operations when removing a component from the DOM. These operations involve the component itself actively cleaning up event listeners, subscriptions, timers, or any other resources it created during its lifecycle. Here is an example. In the unmounting phase of the functional component, myComponent, the setInterval function within the useEffect actively sets up an interval timer. This timer executes a callback method every 1,000 milliseconds, logging interval tick to the console. The component actively returns a cleanup function from the useEffect hook to ensure proper cleanup and prevent memory leaks. This cleanup function uses clearInterval to clear the interval timer when the component unmounts, thereby freeing up the resources associated with it. This active cleanup mechanism ensures that the interval timer's resources are released when the component is removed from the DOM, thus preventing potential issues or memory leaks. But what happens if an error occurs during rendering or within a child component's lifecycle method in React? React will handle the error in such cases by routing it to the nearest error boundary. This error handling mechanism is the final phase of the functional component's lifecycle. Error boundaries are special components in React that catch errors during the rendering phase or lifecycle methods of their child components. Instead of crashing the entire application, error boundaries display a fallback UI, preventing the error from propagating further up the component tree and ensuring the rest of the application remains functional despite the error in a specific component. In this video, you learned that React's lifecycle phase includes mounting, updating, unmounting, and error handling. The mounting phase initializes the component, sets up the initial state, and performs side effects. In the updating phase, React re-invokes the function body and re-evaluates JSX. In the unmounting phase, React executes cleanup operations when removing a component from the DOM. React handles the error by routing it to the nearest error boundary.
Welcome to Testing React Components. After watching this video, you will be able to explain what is testing, list the advantages and disadvantages of testing, describe the different approaches of component testing, and describe the testing tools. Testing is a line-by-line review of how your code will execute. Testing can also be done using a suite of tests for an application that comprises various bits of code to verify whether an application is executing successfully and without error. Testing is essential but has certain advantages and disadvantages. The advantages are that it prevents unexpected regression. Then, it also allows the developer to focus on the current task rather than worrying about the past. In addition, it allows modular construction of an application that would otherwise be too complex to build, and it reduces the need for manual verification. The disadvantages are that you need to write more code as well as debug and maintain the code, and non-critical test failures might cause the application to be rejected in terms of continuous integration. Testing of React components is done to ensure that your application will work as intended for your end users. The tests verify the code prepared by the developers to check that it runs without errors. Testing also tests the functionality of the application by replicating the actions of the end users. You should also conduct tests to verify that any updates done on the application do not affect the overall working of the application. Testing your application also prevents regression, which is the reappearance of a bug that had been previously fixed. This can make the feature stop functioning as intended when a certain event occurs. Now, there are two approaches to React component testing. You can render component trees in a simple test environment and assert their output. This kind of unit testing involves an isolated part of your application. It is done in combination with shallow rendering. For example, a component can render with default properties. The second approach requires the running of a complete application in a realistic browser environment, also known as end-to-end testing. This involves a multi-step process that combines multiple units and integrates the test into one big test. Tests are done in a simulated browser. There may or may not be a UI while the test is running. For example, testing an entire authentication flow. Component tests flow through three phases. Arrange. During this phase, the component properties are prepared. Act. In this phase, the component needs to render its DOM to the user interface. It then registers any user actions or events that may trigger programmatically. And assert. Finally, the expectations are set, verifying certain side effects over the component markup. This form of unit testing is known as Arrange, Act, Assert. When choosing testing tools, it is worth considering the following points. First, we have speed versus environment. Some tools offer a very quick feedback loop between making a change and seeing the result, but do not model the browser behavior precisely. Other tools might use a real browser environment, but reduce the iteration speed and are unreliable on a continuous integration server. Then there's what to mock. With components, the difference between a unit and integration test can be indistinct. If you're testing a form, should it also test the buttons of the form? Or should a button component have its own test suite? Should refactoring a button ever break the form test? There are various testing libraries for your React components. The React ecosystem with a Node.js background has Mocha, Chai, and Sinon to test JavaScript applications. Mocha is used as the test runner. Chai can be the assertion library.
and Synon can be used optionally to test your JavaScript logic with objects, such as spies, stubs, and mocks. These objects are pieces of code that can be used for different types of testing. All three of these testing libraries can be used to test React applications, though there is another library called Enzyme that is added to the mix to render your React components. Now, you can test React components by using Jest or React Testing Library. Jest was released by Facebook to test React components and brings the combined power of Mocha, Chai, Synon, and more. React Testing Library is a set of helpers that lets you test React components without depending on their implementation details. Jest is a JavaScript test runner, assertion library, and offers spies, stubs, and mocks as well. Jest can be combined with Enzyme or React Testing Library to test your React components in an even more powerful way. It allows you to access the DOM via JS DOM for testing React components. Jest provides a great iteration speed combined with powerful features like mocking modules and timers so you can have more control over how the code executes. Jest includes a command line tool for test execution. It also allows us to create mock functions with almost zero configuration and makes assertions easier to read. Furthermore, it offers snapshot testing, which helps us check and verify the component rendering result. Jest is installed as a dependency to React when using npx create React app along with the React Testing Library. The React Testing Library provides light utility functions on top of React DOM and React DOM or test utils in a way that encourages better testing practices. The utilities provided by this library facilitate querying the DOM, finding form elements by their labels, and finding links and buttons from their text like a user would. It also exposes a recommended way to find elements where the text content and label are not understandable. This library encourages your applications to be more accessible and allows you to test your components the way the end user will use them. This library is a replacement for Enzyme. This example shows how to use React Testing Library to test components. The test code above used React Testing Library's render method to render the component virtually. You can access the rendered HTML through the screen object. The primary purpose of React Testing Library is to increase confidence in your tests by testing your components in the same way as an end user would use the components. Users are unaware of the back end of an application and are aware of only the output. This library enables you to write your tests based on the component output. And rewriting your tests in React Testing Library is worthwhile because you'll be trading tests that slow you down for tests that give you more confidence and increase your productivity in the long run. In this video, you learned that testing is a line-by-line review of how your code will execute. You can render component trees in a simple test environment or a realistic browser environment. Component tests flow through three phases: arrange, act, and assert. React components can be tested using Mocha, Chai, Synon, Jest, and React Testing Library. And finally, React Testing Library increases confidence in your tests by testing your components in the same way as an end user would use the components.
Welcome to working with arrays and React components. After watching this video, you will be able to define arrays and their importance in React components, describe how to declare arrays in React, describe how to traverse arrays in React components, describe how to work with arrays in React. An array is a data structure in JavaScript used to store multiple values in a single variable. It is defined by enclosing a comma-separated list of elements within square brackets. Arrays can contain elements of any data type, including numbers, strings, objects, or even other arrays. In React, arrays are commonly used to manage lists of data and are essential for building dynamic and interactive user interfaces. React components often render arrays of elements or data, and there are various ways to declare arrays in React and traverse their elements within components. You can declare an array using the array literal notation as shown. Arrays can be stored in component state using the useState hook as shown. Arrays can be constructed dynamically based on application logic or received data, as shown. Traversing arrays in React components is a common task, especially when rendering dynamic content or managing lists of data. By using methods like map, forEach, forOfLoops, or index-based traversal, you can efficiently work with arrays in React components to create dynamic and interactive user interfaces. The map method is commonly used to iterate over each element of an array and return a new array of React elements, as shown. The forEach method iterates over each element of an array and executes a callback function as shown. You can use the forOfLoop to iterate over the elements of an array as shown. You can access elements of an array using their indexes, as shown. You can render a list of items by mapping over an array and returning a JSX element for each item. Array declaration. Inside the component function, an array named items is declared and initialized with 4 string elements: autumn, spring, summer, and winter. These represent the seasons. JSX rendering. The component returns JSX markup representing the structure of the component's output. It includes a div element containing an H1 heading, season names, and an unordered list, UL element. Mapping array elements. Within the UL element, the map method is utilized to iterate over the items array. For each element of the array, a li list item element is dynamically generated. The key attribute is assigned to the index parameter of the map function to help React efficiently identify each list item. In the output, the items in the array are displayed under the heading Seasons Names as autumn, spring, summer, and winter. You can add or remove items from an array using state and React's setState method as shown in the code as follows. State management. The component utilizes the useState hook from React to manage its state. 2 state variables are declared. Items. Holds an array of strings representing seasons, initially set to autumn, spring, summer, winter. Input value. Represents the value of the input field used for adding new items to the array, initially set to an empty string. Adding items. The add item function is called when the add button is clicked. It appends the current value of input value to the items array using the setItems function and then resets input value to an empty string. Removing items. The remove item function is triggered when the remove button next to each list item is clicked. It creates a new array, new items, by copying the items array and removes the item at the specified index using the splice method. The updated array is then set as the new state using setItems. Rendering JSX. The component returns JSX markup representing the structure of the component's output. It includes an H1 heading, seasons, an unordered list, UL, and a dynamic list of list items, LI, generated using the map method. Each list item displays a season from the items array and contains a remove button. Clicking the button triggers the remove item function for the corresponding index. Below the list, an input field allows users to add new items to the array. The input value state variable controls the value of the input field. Clicking the Add button appends the current value of the input field to the items array and clears the input field for the next entry. The output displays as shown with a Remove button against each array item and an Add button at the bottom. After entering data in the input field, the output will display as shown. The output shows Monsoon has been added in the array list. And if you want to remove, then click on the Remove button against an item, and the item will be deleted. Suppose you have clicked on Autumn Remove button, like shown in the image, then the array list will look like as shown. You can conditionally render components based on the content of an array. For example, the explanation for the code is as follows. State management. The component uses the useState hook from React to manage its state. One state variable is declared. Items. Holds an array of strings representing front-end languages. Rendering JSX. The component returns JSX markup representing the structure of the component's output. It includes an H1 heading, front-end languages. It conditionally renders either an unordered list, UL, containing list items, LI, representing front-end languages, using the map method if items is not empty, or a paragraph, P, stating no front-end language is available if items is empty. The output will display as shown. In this lesson, you learn that arrays are basic data structures that are often used to store groups of items in a single variable. Some important array methods are map, which makes it easier to make new arrays by applying a function to each element, for each, which runs a function on each array element without creating a new array. Also, push and splice methods can be used to add and remove elements. Arrays are a powerful data structure for quickly changing and traversing data. Welcome to a video on how Virtual DOM works in React. After watching this video, you will be able to define Document Object Model, DOM, and its components, describe the working of a Virtual DOM in React, list the advantages of Virtual DOM in React, compare normal and virtual DOMs. The Document Object Model, DOM, is an interface for web pages and documents used to represent an HTML structure as a tree-like structure. Each node represents a part of the document, such as elements, attributes, and text. The DOM allows programs to access and manipulate web documents' content, structure, and style dynamically. The components of a DOM are nodes, elements, attributes, and events. The DOM represents the document as a tree structure composed of nodes. There are different types of nodes, such as element, text, attribute, and so on. Elements are the building blocks of HTML documents. They represent the content of the document. Attributes provide additional information about elements. They can specify properties, styles, or behavior. DOM events allow JavaScript code to respond to user interactions or other actions in the document. The virtual DOM is a concept used in frameworks like React to optimize the performance of web applications. It is an abstraction of the actual DOM implemented in memory and is kept in sync with the real DOM by React's reconciliation process. Let's discuss how the virtual DOM works. Upon the first rendering of a React component, a virtual model of the DOM is created. When changes are made to the state or props of a component, React creates a new virtual DOM representation. React uses a diffing algorithm to compare the new virtual DOM with the previous one and identify the smallest changes required to update the real DOM. React uses batching to optimize changes by grouping and applying them to the real DOM efficiently as a patch, which helps minimize wasteful re-renders and DOM operations. Virtual DOM is important in React. It offers speed enhancement, simple development, cross-platform compatibility, state management, and debugging and testing. The virtual DOM boosts web application speed by reducing the frequency of DOM changes. Developers can concentrate on developing declarative code without being concerned about the intricacies of DOM manipulation. Due to its cross-platform compatibility, React's virtual DOM abstraction enables efficient component rendering on various platforms, such as web browsers and mobile devices. React's state management, in conjunction with the virtual DOM, facilitates effective updates and re-renders in response to alterations in the application state. Virtual DOM simplifies debugging and testing React apps by allowing developers to examine the virtual version of the DOM while developing. The advantages of virtual DOM in React are efficient updates, component reusability, easy updating to declarative syntax, and improved server-side rendering. React's virtual DOM ensures that only the necessary changes are made to the actual DOM, leading to better performance and faster rendering. Virtual DOM allows developers to create reusable components that can be composed and updated efficiently. React's declarative syntax allows developers to describe the intended UI state, and React updates the virtual DOM and renders the components accordingly. Virtual DOM enables server-side rendering in React, improving the initial page load performance and web application search engine optimization, SEO. The normal and virtual DOM differ in their loading process. In the normal DOM, when a web page loads in a browser, the browser analyzes the HTML content and creates the DOM tree from the HTML code. The process includes analyzing the HTML markup, generating the DOM nodes, and displaying the content on the screen. Rendering complex web pages with huge DOM trees can be expensive. In contrast to the regular DOM, the virtual DOM is an abstraction that resides in memory and is not connected to the browser's rendering engine, which means it will not update the changes directly in the real DOM. Upon loading an application, React creates a virtual DOM tree representation in memory called the virtual DOM. This virtual DOM is constructed based on the React component's initial state and properties. When updates are made to the DOM, such as changing the content of an element or modifying its attributes, the browser directly manipulates the corresponding DOM nodes. In contrast, in the virtual DOM, React compares the current virtual DOM with a new form that shows the updated state when changes are made to a React app. Then, React figures out the smallest changes that need to be made to the DOM to represent the new state. These changes are made all at once and then applied to the real DOM, so there are as few transitions and updates as possible. The reconciliation process in React makes sure that only the necessary changes are made to the DOM. This makes it faster and more efficient. Each update triggers a reflow and repaint of the affected parts of the document, which can impact performance, especially in large applications. Let's create a simple React example with two components, a parent component, app.jsx, a first child component, and a second child component. The first child component renders a list of items, and the parent component updates only one item without re-rendering the entire list. But it will also make sure that the second child component will not re-render again. In this example, the app component maintains the state of a list of items. The first child component has a list of array items with one button to update the first element of that item. The second child component only shows information related to that component. The output of the above code is as shown. If you inspect the console logs, you'll notice the following behavior. For the first time loading, all the components will render. When you select to update the item, only the first child component will be re-rendered. Neither the app component nor the second child component will change. React's virtual DOM compares the updated app with the previous virtual DOM and determines that only the state of the first child component has changed. Therefore, it only updates the relevant part of the DOM, the child component, without re-rendering the entire list. This example demonstrates how React's virtual DOM updates only the necessary parts of the DOM, improving the application's performance, especially in scenarios where only specific components or elements need to be updated. In this video, you learn that the DOM allows programs to access and manipulate web documents' content, structure, and style dynamically. Virtual DOM is an abstraction of the actual DOM implemented in memory and kept in sync with the real DOM by React's reconciliation process. React's virtual DOM updates only the necessary parts of the DOM, improving the performance of the application, especially in scenarios where only specific components or elements need to be updated. Welcome to Hooks. After watching this video, you will be able to explain the purpose of using hooks, list the advantages of hooks, summarize best practices for hook development, and contrast standard and custom hooks. Introduced in React version 16.8, hooks alleviate many challenges posed by writing class components. Hooks provide a way to write functional components with the same capabilities as class components. Namely, you can access a component state using hooks with function components. The component preserves its state when it updates and re-renders. So now, function components provide the same functionality as class components, with less complexity in the code. As the name suggests, they enable you to hook into React state and lifecycle features from function components. You can even write customized hooks. You can write a custom hook for multiple components instead of duplicating code from one component to another. Advantages of using hooks include easier to read code. Your code chunks become more manageable in size. Hooks help to optimize your code, enabling you to write code producing complex behaviors in the UI. They simplify your code. Hooks help you handle events and subsequent logic without classes. Hooks also provide a performance boost to your components. Now let's discuss some best practices when using hooks. You can only use hooks exclusively with function components. You must call a hook at the top level of a component tree. In other words, you cannot call hooks within child components. You cannot call a hook from a normal JavaScript function. You cannot call hooks inside loops, conditional statements, or nested functions. Regarding versioning, hooks require the Node.js version 6 JavaScript platform. In addition, they use the Node Package Manager, NPM, version 5.2 or higher. You should use the npm create byte at latest my app template React tool to set up your React app using Byte. It simplifies configuration and the need for multiple build tools and automatically optimizes your app. Let's explore some of the most commonly used hooks. The useState hook allows you to access the state of the component in your function component. The useEffect hook manages side effects such as document changes and HTTP requests. You will use it if you need to fetch data from a database. The useContext hook manages context changes and provides access to a context. The useReducer hook manages Redux state changes. Like a light form of Redux, this hook provides a dispatch function and a state while taking a reducer and an initial state. You will learn more about the Redux library in another lesson. Custom React hooks let you add unique functionality to your React applications. You name custom with use as a prefix. For example, you could create custom hooks named use local storage or use authentication. A custom hook is a new composition of one or multiple hooks. Since you can treat hooks as functions, they have the same features. You can reuse and combine them as needed. In this code example, this code imports the useState hook to access the component's local state. This hook returns and assigns values with a destructed array. The current count state is the first array element, and the second variable sets the count, allowing you to make updates. The initial count is passed as a parameter in the useState hook function. After that, you call this function from an event handler to utilize it. In this video, you learn that hooks provide function components with the same capabilities as class components. Hooks enable you to write simpler, more readable, and a lesser amount of code, providing more complex behaviors and improving performance. You must call hooks at the top of a tree and cannot call them from regular or nested functions or inside loops or conditions. Standard hooks include useState, useEffect, useContext, and useReducer. And finally, you can add unique functionality using custom hooks. Welcome to a video on side effects management and custom hook. After watching this video, you will be able to define the role of useEffect and side effects in React. Describe how useEffect and side effects works in React. Describe the various dependencies in useEffect. Describe a custom hook in React. useEffect is a React hook that allows you to perform side effects and functional components. A side effect refers to any operation that you need to execute as soon as the page loads, without calling those operations/functionalities separately, such as fetching data from an API, subscribing to events, manipulating the DOM, or setting timers. Side effects are actions that occur asynchronously, which affect the application state or the UI. Here's a simple example to understand useEffect and the side effects in React. Suppose we have a component that fetches a list of food items from an API and displays them. In this code example, the components are as follows. State management with useState. The component utilizes the useState hook to manage the state within a functional component. Specifically, it declares a state variable named foods using useState, initializing it with an empty array. This variable will later hold the data fetched from the API. Performing side effects with useEffect. The useEffect hook is employed to execute side effects in functional components. In this component, useEffect is utilized to fetch data from an external API when the component mounts. Data fetching. Inside the useEffect hook, a fetch request is made to the specified API endpoint as shown. The fetch function returns a promise that resolves to the response from the server. Upon receiving the response, response.json parses the response body as JSON. The parsed JSON data is then available in the next then block, where it is logged to the console for debugging purposes and subsequently passed to setFoods to update the food state variable with the fetched data. If an error occurs during the fetch operation, it is caught in the catch block, and an error message is logged to the console. Rendering the fetched data. In the JSX returned by the component, a list, UL, of food items is rendered. The map method is used to iterate over the foods array and generate a list item, LI, for each food item. For each food item, details such as name, description, price, category, ingredients, and an image are displayed. The image is rendered using the image tag with the URL obtained from the image_URL property of each food item. Component export. Finally, the side effect component is exported as the default export, making it available for use in other parts of the application. In React's useEffect hook, dependencies refer to variables or values which are used to determine when useEffect should run. Dependencies are specified as an array argument to the useEffect function. The following are some dependencies. When you provide an empty dependency array, the effect runs only once when the component will load for the first time. It does not depend on any specific variable or state changes. This behavior is used to execute tasks only once at the time of loading. For example, in the code, the page will only load once at the loading of this page. When you provide values in the dependency array, the effect runs whenever any of these values change. For example, the count value as shown in the code. If any of the dependencies have changed since the last render, React will rerun the effect. In the code, the effect runs only when the count state changes, ensuring that the useEffect hook executes whenever count is updated. Therefore, the count variable is included in the dependency array. If you omit the dependency array entirely, the effect will run after every render, including the initial render and subsequent updates. This means that the effect will execute both after the initial render and after every re-render of the component, regardless of whether you change any values. This behavior with no dependency will cause the effect to run after every render. You can use a custom hook in React to create reusable logic. Custom hooks allow you to abstract complex logic that you can easily reuse across different components in your application. Let us understand this with an example. You have two components, toggle button and useToggle. Let's go through the toggle button code. The toggle button component imports and utilizes a custom hook named useToggle, which uses the logic for toggling between true and false states. Within the toggle button component, the useToggle hook is used to manage the state of a button. The hook returns two values, isToggled, representing the current state, either true or false, and toggle, a function that toggles the state between true and false when invoked. In the JSX, a button is rendered with a text content of on when the state is true and off when the state is false. Upon clicking the button, the toggle function is triggered, updating the state accordingly. This setup provides a simple and reusable way to create toggle functionality within React components. The reusable code of the useToggle custom hook is as shown. It manages the true and false state of the toggle button. The output before clicking the toggle button will be as shown. After clicking the toggle button, the output will be as shown. This toggle will be performed as long as the user clicks on the button. In this video, you'll learn that useEffect is a React hook that allows you to perform side effects in functional components. Side effects are actions that occur asynchronously, affecting the application state or UI. In React's useEffect hook, dependencies refer to variables or values which are used to determine when useEffect should run. Custom hooks allow you to abstract complex logic that you can easily reuse across different components in your application. Welcome to a video on connecting React to external services. After watching this video, you will be able to define external services, describe how third-party services retrieve data using the Fetch API method and Axios library. External services are third-party platforms, applications, or systems that your application connects to over a network. These services are typically hosted outside your app's environment and provide additional features, tools, or data that your application may need. They allow your app to interact with external resources or services through APIs, application programming interfaces, enabling data exchange, feature integration, or service execution. Application programming interfaces, or APIs, let your application talk to and exchange data with outside services. Third-party services offer them. APIs enable you to acquire data, execute operations, or add extra features to your application. Third-party services provide data you can retrieve using multiple API methods, such as Fetch API method and Axios library. Let us understand fetching data using API with the help of an example. In the code, a constant variable, API URL, is used to store the URL of the outside API from JSON placeholder, API, which is used to create fake JSON data for testing and development. Then, the fetch method sends a GET request to the given URL, API URL. This starts the process of getting info from the outside API. You connect the then method to the fetch call. This method takes a callback function as an argument and runs it when the fetch action is successful. It also takes an argument for the response object. You use the callback function to call the answer object's JSON method. This method takes the answer body as JSON and gives you a promise to work with the JSON data. You add another then method to deal with the JSON data that was read in the last step. This method takes a callback function as an argument. The callback function runs when the JSON parsing is complete, and the parsed JSON data is given as an argument. In the callback function, you write the info to the console. You add a catch method to the chain to deal with errors during the fetch process. As an argument, this method takes a callback function that runs if there is an error. You log the error to the console inside the callback code so that you can use the error messages to help with debugging. Overall, this code shows how to use the fetch function to make a simple GET request to an external API, handle the return data, and properly handle any errors that may happen during the fetch operation. The output of the API fetch method code is as shown. Axios is a popular JavaScript library for HTTP requests from web browsers. Let us see an example of Axios that shows how it works and differs from the Fetch API method. To use Axios, you first need to install using npm install Axios. Then, you need to import it using import Axios from Axios. Next, use the axios.get method to make a GET request to the specified URL, API URL. Axios automatically handles the creation and execution of the HTTP request. In this code, Axios offers additional features such as automatic JSON parsing. Therefore, there is no need to call response.json separately as you did with the Fetch API method. You chain a .then method to handle the response from the API. The response object is passed to the callback function when the request is successful. You access the response data using response.data and log it to the console. You add a catch method to the chain to deal with errors during the fetch process. This code generates the same output, but less is executed. In this video, you learn that external services are any program, platform, or infrastructure your application uses to connect to and work with other applications over a network. APIs enable you to acquire data, execute operations, or add extra features to your application. Third-party services provide data you can retrieve using multiple API methods, such as Fetch API method and Axios library. Welcome to Implementing Forms. After watching this video, you'll be able to explain the purpose of forms, compare and contrast controlled and uncontrolled form components, summarize the benefits of the React Hook library for form development. Forms allow users to interact with data on a web page. For example, you would use forms for user registration, surveys, or when a user places an order. Areas in which users interact with the data are called fields. There are many types of fields, such as text boxes, drop-down menus, radio buttons, and checkboxes. When taking input from a user through a form, you also need to handle the submission logic and validate the data. In React, you handle these capabilities with components. You generally capture the input on the client side and temporarily store it in the component state. You do not submit the information directly from the form to a server. HTML provides some form capabilities such as input, text area, and select. The browser manages the state of these elements. In React, you use the component state to store input and make updates using the component's setState method. In addition to providing the data fields the users interact with, your form must also provide submission logic that tells the application when to accept the user's input. For example, you would not want to accept a user's password until they click a Submit button. This provides some degree of assurance the user input the password they intended. Regarding validation, when users create passwords, applications often require the user to type the password twice, as well as have rules for the password, such as a minimum number of characters. Generally, form validation requires the following tasks: getting the input, managing and updating the form state, validating input values, displaying appropriate error messages. React form components can be controlled or uncontrolled. Let's discuss the difference at a high level and then examine each one more closely. With uncontrolled components, you use React to place the value on the page, and the browser keeps track of the rest. With controlled components, the React state manages the form data. This means that you must explicitly write the code to create the state and tell it how to update when the data changes. So, although uncontrolled components use less code and are easier to develop, ultimately they are less robust. As the name suggests, you have little control over the former and more over the latter. When you write uncontrolled components to handle user input, the browser handles the form elements. Similar to working with HTML form elements, the values in an uncontrolled component are stored in the DOM's input node. Inputs get updated automatically. When writing an uncontrolled component, you write a ref function to get the input values from the DOM. You do not need to write event handlers when the state changes. If you decide to use controlled components, you explicitly handle all state changes, such as responding to a key press, a mouse click, or a tap. Rather than the DOM handling the input, you tell the component where to store the data and return any values to display as a result. You write functions to handle data getting passed into the component with on-change events, such as tapping a specific location of the screen. Often, you will use the setState method to save the updated input. You also write the event handlers to update the state of the variables. This simple controlled component handles a registration form. The component implements the useState hook to track the state of the email address. To ensure that the email address is updated when the form is submitted, you must add an input element with value and on-change attributes to it. When the user taps the Submit button, the component writes the email address to the console. You can use the React Hook Form library to help you with state management and validation for React applications containing forms. This reduces the amount of code developers need to write when creating forms. It also helps improve performance by eliminating unnecessary form component re-rendering. You can install React Hook Form using the Install React Hook Form command. In this video, you learn that forms provide a way for users to interact with data in a web application. Forms usually require input fields, submission logic, and validation rules to handle user interactions. The browser keeps track of data and state of elements with the DOM in uncontrolled components. Controlled components require you to explicitly manage the UI input data with the component state. The React Hook Form library optimizes performance by reducing the number of times a component renders. Welcome to Introduction to Redux. After watching this video, you'll be able to compare and contrast component versus application states, explain purpose of the Redux library, describe when to use Redux, summarize the benefits of using Redux. In order to understand the usefulness of the Redux library, you should first understand the differences between component and application states. An application state, as opposed to a component state, holds information about the entire application. You can access this state from anywhere in your application, not just a specific component. For example, consider an e-commerce application that provides users with a cart feature. You should let your users access the cart feature anywhere in the application so they can view or edit its contents or check out at any time, regardless of any particular state of a specific component. The Redux library helps you handle the application state. Instead of individual components handling their own state, Redux can maintain the state of the application state and pass information from the application to a component whenever it gets called. In general, the larger the application, the more useful Redux potentially becomes. As the number of components in your application grows, it becomes increasingly difficult to manage all of those component states. A large number of components indicates that you should turn to Redux for help rather than frequently passing props through your component tree. Also, you will likely have components that use the same data but are randomly located on the DOM tree. So, passing data from one component to varying locations on the tree becomes cumbersome and hard to track. Because Redux handles states globally, you can make updates to the state from anywhere in the application. This prevents the need to create new objects with each state change. Note that you can use the Redux library with frameworks other than React, like Angular, Vue, and just standard JavaScript. However, most developers who use React also use Redux. Redux handles multiple state changes in a place called the Redux store. A store refers to a data structure that stores and manages data. Developers sometimes refer to the Redux store as the single source of truth. You will find using Redux beneficial for multiple reasons. Using state at the application level can reduce code complexity and improve readability. You don't need to reason about a component's particular status to understand the application's behavior at a given point in time. Redux makes it easier to predict the application state at any particular point in time because you don't need to pass the data between components as much. Redux makes code maintenance easier by eliminating the need to trace components up and down the tree to determine their state data. Using Redux can help optimize performance because it reduces the number of page renders. It reloads only the necessary updated parts of the page rather than the entire page. In this video, you learn that an application state holds data about the entire application, and you can access this data from any particular component. You can use the Redux library to manage your application state. You will find Redux useful when you need to pass data from one part of your component tree to another. Benefits of Redux include reducing coding complexity, improving code readability, better performance, and easier code maintenance. Welcome to Essential Concepts of Redux. After watching this video, you will be able to discuss Redux concepts such as action, store, and reducer, describe the principles behind Redux architecture, explain the terms dispatching and action creators, relate the concepts action, store, and reducer to a user interface example. Redux offers a centralized state management system for your application. When you use Redux, you do not need to manage component states. Redux manages the states at the application level, not the individual components. Using this approach, you should treat the component properties as immutable. You create new state objects rather than changing existing ones. Redux uses actions, stores, and reducers when updating component properties. Let's briefly discuss each and then discuss them in more detail later. The store contains all the current states of the application. You call an action object to indicate the need for a state update, but the action does not specify how to change that state. Instead of specifying the how in the action, you write a reducer function to how to update the state in the store. Before going into more detail, consider an e-commerce application cart. From the user's point of view, they expect the total number of items in the cart to increase by the number of items they add to the cart after selecting Add to Cart. Let's see what happens behind the scenes regarding actions, the store, and reducers to make this work correctly. When the user selects Add to Cart, it starts an action creator function. Let's say you name the function addItem. The addItem function is an action creator. It creates and returns an action object. Your component sends that action object to the store using a dispatch function. This entire process is called dispatching an action. The store contains all application states, including the state of the cart. Part of the cart's data includes its current number of items. The store itself uses a data structure called a state tree to store and manage the application's states. The tree is a JavaScript object with methods for managing its properties. The action object describes the action that needs to be performed. It contains properties including type and payload. The store uses the action's type property to determine which reducer should process the action. The payload property stores other data needed to update the state. In our example of adding items to a cart, the payload would include the cart's increased value. The store then calls the reducer, which tells it how to change the state. When the store receives the action, it calls the appropriate reducer and passes both the action object and the state object to the reducer function to calculate the new state. Note that the reducer is a pure function, meaning it always returns the same output when given the same inputs. It has no side effects or mutating functions. Using reducers may seem like an extra step in the Redux architecture. However, this architecture enables a predictable state container by ensuring explicit state changes. It makes reading the code easier when you need to track state changes by separating the action description and the specifics of how the state changes. In turn, this makes debugging easier and helps simplify code maintenance. In this video, you learn that the action object describes the action that needs to be performed. The store maintains all of the application's current states. A reducer tells the store how to change the state. The dispatching action process uses an action creator function, which returns the action object and sends the object to the store using a dispatch function. The Redux architecture makes states predictable because changes are explicit through actions, reducers, and the application store. Welcome to Async with Redux. After watching this video, you will be able to explain the differences between synchronous and asynchronous operations, explain challenges with asynchronous operations in Redux, provide examples of complications posed by asynchronous operations, describe how you can use Thunk and Saga to handle async, compare and contrast Thunk and Saga's pros and cons. Code that operates in a synchronous or sync fashion implies that, given two operations, one operation must complete execution before the second one begins. If your code has two operations and the first operation starts, it blocks the second operation until the first operation finishes. Asynchronous or async operations run in parallel. This means that a second operation can begin execution while the first is still being processed. The situation dictates which behavior you need. You will generally prefer asynchronous behavior when you don't want an operation to prevent the user from continuing to use the application. So operations such as network requests, memory-intensive calculations, and loading large files should usually be performed asynchronously. These operations can run in the background while the user completes other tasks. Synchronous behavior can also pose problems. Situations often require processing events one after another. For example, if the user wants to add 2 items to a cart, they first need to enter the number of items they want, then click the Add to Cart button to update the cart. If the Add to Cart button event occurs before updating the number of items, an incorrect number may be added. In this case, you prefer synchronous behavior. JavaScript behaves asynchronously. However, state management in Redux requires synchronous behavior. Recall the sequence of a Redux state change. It begins with a call to an action creator function, which returns an action object. Next, the action object is dispatched to the store. Then the store calls the appropriate reducer based on the action object's type property. Consequently, the reducer updates the state object. Dispatching actions sometimes requires asynchronous operations. For example, say your user needs the application to fetch data from the server. If the application behaved in a synchronous manner, it would block the user from any other interactions with the application until the server returns that data, causing a frustrating user experience. In this case, you want to dispatch operations asynchronously to manage the application's states and maintain responsiveness. Though required, actions and reducers will not suffice to handle this asynchronous behavior. Middleware allows you to interact with asynchronous data. To perform state changes, you use actions provided by the store. If necessary, the middleware intercepts the actions and delays them to support asynchronous behavior. Once the asynchronous process is complete, the rest of the Redux flow continues as usual, where the reducer receives the action type to compute the new state. The final action dispatch restores the synchronous data flow. Let's discuss the 2 most popular middlewares used with Redux to support asynchronous behavior: Thunk and Saga. Recall that action creators return an action object. With Thunk, the action creators also return functions. These functions allow you to interact with the Redux store. These functions can perform async operations, such as API calls, as well as synchronous ones from within functions. The store then dispatches actions based on the results. Thunk middleware is suitable for simple applications and relatively easy to learn. However, concurrency issues within Thunk require careful consideration, nor does Thunk scale well if your application grows. Another middleware option for handling async operations is Redux Saga. It uses special functions introduced in ES6 called generators. These generator functions, called sagas, allow you to encapsulate logic for handling asynchronous operations. Sagas can multitask with the Redux store dispatch process by pausing and resuming execution as needed. Sagas include several features to make testing and debugging easy. They are pure functions that enable time travel and complex flow logging. Sagas also scales well as your application grows. In turn, the robust nature of Saga middleware makes it more complicated to learn. An in-depth understanding of generators is required to use them well. In this video, you'll learn that synchronous operations block the next operation until the previous one finishes. Asynchronous operations can run in parallel. JavaScript behaves asynchronously, but Redux architecture requires synchronous behavior. Thunk action creators return functions that allow you to perform sync and async operations. Thunk middleware is suitable for simple applications and relatively easy to learn. Thunk does not scale well and requires planning to handle concurrency issues. Saga uses generator functions, which allow you to multitask in conjunction with the Redux store dispatch process by pausing and resuming execution as needed. Saga includes numerous features that make testing and debugging easy. The robust nature of Saga makes it more complicated to learn, requiring an in-depth understanding of generators.
Welcome to Binding Redux and Flow. After watching this video, you will be able to explain the concept of state change, describe data flow in Redux, and list the advantages of one-way data flow in Redux. In a React application, state stores the properties of a component. When the state of a component changes, React responds by triggering the re-rendering of the document object model, or DOM. As the application expands, it becomes difficult to manage the state in your application. The change in the state may involve the transfer of data between components and a long chain of props that can result in a complicated application code. The solution to this problem is offered by Redux. It is an open-source JavaScript library that can manage the state of your application. It is commonly used with React.js, but is not limited to it and can also be used with other JavaScript libraries such as Angular. A conventional React Redux application comprises a single store along with a single root reducer. As the application grows more complex, the root reducer splits into smaller reducers that operate on the different parts of the state tree. An alternate solution can be setting a global variable that can be accessed by different components. However, React will not react to any changes made in the global variable. Redux provides a central store that reduces the complexity of the code and makes the state updating process easier. The Redux elements that are involved in updating of the component properties include Central Store. The store holds the entire application list in the form of the state tree. Actions. These are the information packages sent by the component with a type or description to the reducer. Actions are simple objects which conventionally have two properties, type and payload. The type property is usually a string that identifies the action, and the payload is an optional property that contains some data that is required to perform a task. So the main function of action is to send data from the application to the Redux store. Reducer. This is a simple function that receives the old state and action as input and returns an updated state. Since the state is immutable, a reducer always returns a new state, which is an updated version of the previous state. Subscription. This is triggered in the components whenever the state is updated in the store. The data flow in a React Redux application is unidirectional. It only goes in one direction. The flow of data in a React Redux application begins at the component level when the user interacts with the application UI. This interaction leads to the action creators dispatching an action. So when an action is dispatched, it is received by the root reducer of the application and is passed on to all the reducers. Thus, it becomes the reducer's task to determine if it needs to update the state based on the dispatched action. This is checked by using a simple switch statement to filter out the required actions. Each smaller reducer in the application accepts the dispatched action, and if the type of the dispatched action matches, it returns a newly updated state. It is essential to note here that the state never actually changes in Redux. Instead, the reducer always generates a new state, which is a copy of the old state, but with some modifications. The store then informs the component about the new state, which in turn retrieves the updated state and re-renders the component. Earlier developers used two-way binding to change the state data such that the UI reflected the change. Robust frameworks like Angular and Ember used this type of binding. However, two-way binding was affecting the browser performance adversely with the expansion of applications. In addition, it became difficult to keep track of the data flow. Large companies had a tough time implementing trivial applications like their chat feature. In the one-way data flow paradigm, building presentational components and wrapping them in containers or store, as in Redux applications, solves the problem. Now, the advantage of one-way data flow in Redux is that building large front-end heavy web applications becomes much more manageable. It is easier to manage the state when actions performed on the UI are separated from the changing and updating of the state that happens due to the action. You can use some of the same containers, actions, and reducers in React Native to quickly create apps for iOS and Android. The presentational components do change a bit when you use iOS or Android View components instead of HTML. In this video, you learned that when the state of the component changes, React responds by triggering the re-rendering of the DOM. The Redux elements that are involved in updating of the component properties are Central Store, Actions, Reducer, and Subscription. The data flow in a React Redux application is unidirectional, and it's easier to manage the state when actions performed on the UI are separated from the changing of the state.
Welcome to a video about the Redux Toolkit. After watching this video, you will be able to define Redux Toolkit in the context of React. Describe the Redux Toolkit utilities used to streamline Redux tasks. Describe the Redux Toolkit architecture. Describe the relationship between a store and a slice. In the context of React, Redux Toolkit, RTK, is an official package the Redux team provides to simplify Redux development and make it more efficient. It includes utilities that help streamline common Redux tasks, reduce boilerplate code, and simplify development. Redux Toolkit includes utilities to streamline Redux tasks. It provides a configure store function that combines several pieces of Redux setup logic into a single function call. The function includes setting up the Redux store with commonly used middleware, such as Redux Thunk, for handling asynchronous actions, and enabling the Redux DevTools extension for debugging. Redux Toolkit introduces the createSlice function, which allows developers to define slice reducers that automatically handle immutable updates to the state. The function makes it easier to write reducer logic without having to worry about mutating the state directly. Redux Toolkit significantly reduces the boilerplate code needed to set up Redux in an application. This reduction leads to cleaner, more concise code and faster development time. Using Redux Toolkit can make your Redux codebase cleaner, more organized, and easier to maintain, especially in larger applications where managing state can be complex. To get started with the Redux Toolkit in a React application, you can install it through npm or yarn. Also, ensure that React Redux is installed on your application. The Redux Toolkit contains at least one slice file and one store file. A slice in the Redux Toolkit represents a piece of your application state and the logic to update it. Slices are typically defined using the createSlice function provided by Redux Toolkit. It consists of a reducer, action creators, and an initial state. A reducer is a function that receives the current state and an action and returns a new state based on that action. Action creators are functions that create actions to be dispatched to the store. The initial state is the initial value of the state slice. The Redux store is a single JavaScript object that holds the complete state tree of your application. It is the source of truth for your data. In the Redux Toolkit, the store is created using the configure store function, which takes in an object with reducer functions as its argument. The store allows access to the state through getState function, allows state updates through dispatch action, and registers listeners through subscribe listener. The relationship between a slice and the store can be summarized as follows. Slices define individual parts of your application state and the logic to update them. The store is where all these slices are combined to form the complete state tree of your application. Each slice reducer is added to the Redux store during its creation using configure store function. The store combines all the slice reducers into a single reducer using combine reducers function. When actions are dispatched, the store delegates them to the appropriate slice reducers based on their corresponding slice. Let us understand the relationship between slices and stores using an example. Suppose you have an e-commerce application that depicts the increase in the product quantity in your cart, the total bill amount, and the number of supercoins you will earn on a purchase that you can use in your next payment. In this application, you will have the following components. App.jsx is the parent component. ProductQuantity.jsx will increment the quantity of a product item. CartValue.jsx will calculate the total amount. CounterSlice.jsx will contain the reducer and any associated action creators within a single file. Store.jsx will store the Redux state. Main.jsx is the entry point. ProductQuantity.jsx displays a product's quantity and allows users to increase or decrease it. It imports useDispatch and useSelector hooks from React Redux to interact with the Redux store. useSelector is used to extract the counter state from the Redux store. The component renders buttons to increment or decrease the quantity. When these buttons are clicked, the corresponding increment or decrement action from the counter slice is dispatched to the Redux store using dispatch. CartValue.jsx component determines the total bill amount and displays it based on the product quantity saved in the Redux store. To get the counter information from the Redux store, it uses useSelector. The final amount is calculated using the number of items and a set price per unit. CounterSlice.jsx file defines a Redux slice named counter. It initializes the counter state to 0 and defines two reducers, increment and decrement. When the increment or decrement actions are dispatched, they update the counter state accordingly. Store.jsx file configures the Redux store using configure store from the Redux toolkit. It imports the counter reducer from CounterSlice and sets it as the reducer for the counter slice. The configured store is then exported and used in the application. The main.jsx component is the entry point of the application. It wraps the app component with the provider component from React Redux, passing the Redux store as a prop. In this video, you'll learn that, in the context of React, Redux Toolkit or RTK is an official package the Redux team provides to simplify Redux development and make it more efficient. Redux Toolkit provides a configure store function that combines several pieces of Redux setup logic into a single function call. Redux Toolkit introduces the create slice function, which allows developers to define slice reducers that automatically handle immutable updates to the state. A slice in the Redux Toolkit represents a piece of your application state and the logic to update it. The Redux store is a single JavaScript object that holds the complete state tree of your application. Welcome to the React Final Project walkthrough. For your final project, you will create the front end of a Paradise Nursery shopping application. The application interface will allow you to browse a variety of houseplants and add them to a shopping cart. The shopping cart feature lets you see all your items and their total cost. Your shopping cart should also allow you to adjust the number of items in the cart before checkout. Your application will have 3 pages: a landing page, a product listing page, and a shopping cart page. Let's preview the application and tour the user experience. Here, you see a sample landing page for the Paradise Nursery shopping application. Create a landing page similar to this one that engages your customers with your product line and provides entry into the main application. Elements on this page should include a paragraph about your company, a background image, your company name, and a Get Started button linking to the product listing page. After selecting Get Started, the application should direct you to a product listing page like the one shown here. This page allows you to browse the houseplants in your product line. Page elements include a page header and a card for each plant. The page should group the plants by a common feature, such as air purifying or aromatic. Some sections may have a single plant in multiple groups. The page header should include the company name and logo, which will navigate back to the landing page. It should also include a tagline and a shopping cart icon, displaying the current number of items. The application will navigate to the shopping cart page if you select the cart icon. Each plant should have its own card, similar to what you see here. Each card has a thumbnail, the plant name, its price, a brief description, and an option to add the plant to the cart with the label Add to Cart. If you add the item to the cart, disable this option and change the label to Added to Cart. Once you select the Add to Cart option, the number on the cart icon should increase by 1. Now, take a look at the shopping cart page and its components. You should organize the shopping cart using cards. one for each type of plant added to the cart from the product listing page. Each card should display a thumbnail image, a delete option, and the unit price. You can increase or decrease the number of items using an increase or decrease button, which, when selected, increments or decrements the number on the card. You will also need to update the total number of items in the cart. Also, the card should display the subtotal for the number of that plant type, as shown here. Next, consider the other elements on the shopping cart page. Prominently display the total number of plants in the cart, the sum total costs of all items, and a checkout button. Use the same page header from the product listing page. You will need to handle the consequences of user events, such as when the number of items in the cart decreases to 0. This affects other elements, such as the disabled Added to Cart option on the product listing page. You need to re-enable that option to select it again when you return to the product listing page. Also, remember to adjust the number of items shown on the cart icon in the header when using the increase and decrease buttons. We encourage you to complete the practice project before developing this application. Much of the functionality and code you wrote for that project will transfer to this one. After completing these projects, you will feel comfortable applying many of the ideas you learned throughout the course to a single application. Good luck! Congratulations on finishing the course. Now that you know the fundamental concepts of using the JavaScript React library, you will find plenty of opportunities to continue your learning and apply your skills. Before discussing those, let's review some of the key aspects of what you learned throughout the course. Components comprise one of the fundamental building blocks behind building client-side applications using the React JavaScript library. You use components to render the UI, for event management, and to update the UI based on the component's internal state changes. The ability to develop apps with modular components in React offers several major advantages. Components make React code simple to test and debug. You can combine components, called component composition, to create complex UIs, yet still easily read the code. You can choose one of two ways to build React components, with classes or functions. Developing in React requires access to a component state. Prior to React version 16.8, developers and architects preferred class components because they provided the easiest access to a component state. Since that version introduced the use of hooks with functional components, those developing with React have steadily moved towards functional components because they perform better and simplify the code, making it easier to read and reason about. The component's properties, or props for short, contain the data for the component. Data can get passed to child components from their parents by passing the props object into the child component as a parameter. React limits you from passing props from parent to child. You cannot pass data in reverse order. If a child contains data passed from a parent code, you cannot change that data. How you access and manage a component state differs significantly between function-based components and class-based components. To access a class component state, you use this.state, and you initialize or update it using the component's this.setState method. When accessing a state with function components, you should use hooks, particularly the useState hook. React uses a virtual DOM that abstracts the actual DOM and allows you to make updates using components, props, and their states. The virtual DOM updates the actual DOM, affecting only specific elements. React's use of a virtual DOM significantly improves the application's performance. When a UI contains a form, you typically store input data from the form in a component state. You will need to validate form data to ensure proper formatting and values. The form validation process includes tasks such as getting input, managing and updating the form state, validating input values, displaying appropriate error messages. You can use the Redux library to help you manage states at the application level. Large applications require application state management to simplify your code. A high number of components indicates the need for a library such as Redux instead of frequently passing props through the component tree. Now that you've reviewed some of the fundamental ideas presented in this course, remember each module's glossaries and cheat sheets. You can use these assets to quickly reference much of what you learned. You can also share the applications you created in the labs and the final projects in GitHub. These projects provide you with examples to showcase your skills to prospective employers. Remember to make these directories public if you wish to make these projects accessible to others. If you are not already enrolled in one of our software developer programs, of which this course is a part, we encourage you to do so. Depending on your schedule and the number of courses in the program, these programs will take about 2 to 6 months to complete. The more robust program topics include full stack development using JavaScript, full stack development using Python and JavaScript, front-end development, cross-platform mobile app development. If you wish to continue your web and app development journey but prefer a shorter program, you may wish to consider the following: Cloud Application Development Foundations, Client-Side, Server-Side, and Mongo Database, Programming with JavaScript. If interested, you can find the links to these programs in the Congratulations and Next Steps reading at the end of this course. Each program contains multiple hands-on labs and a final project. The professional certificate programs also have a capstone course where you synthesize and showcase all of your skills learned throughout the program. Congratulations on completing this course, and good luck in your web application development journey.
Welcome to this course, Developing Back-End Applications with Node.js and Express. Now, you may wonder about the relevance of developing back-end applications with Node.js and Express. In Stack Overflow's 2022 survey, Node.js was used by about 50% of the developers who answered the survey, making it the #1 most used server-side technology, whereas Express ranked as the 4th most popular web technology overall, so making it the most popular server-side web framework. Node.js is a runtime environment that can run server-side JavaScript applications, while Express is a server-side JavaScript web framework that runs on top of Node.js in which to write your applications. This course is designed to help you succeed as a back-end or full-stack developer. You may be in IT looking to step up in your career, or a new graduate seeking to further establish your server-side skills, an IT decision-maker who needs to manage more cloud-centric projects, or someone in another field who wants to be able to talk about server-side computing more knowledgeably. In the course instructional videos and labs, you will learn about server-side development using JavaScript, code your first web server, and use Node Package Manager to manage your application modules and dependencies. You'll explore how to make applications run in a non-blocking manner by using asynchronous callbacks and promises, learn how REST APIs are used in conjunction with HTTP requests and responses with the Express.js framework, and then practice using Express by building a web server and creating dynamic content with middleware, routing, and templating. Additionally, hear directly from experts about their experiences with these server-side technologies in the Expert Viewpoint videos. Let's hear these experts introduce themselves.
My name is James Reeve, and I'm a full-stack software engineer at IBM.
Hi, my name is Rupinder, and I work as a Chief Solutions Architect at SkillUp Technologies.
I'm Dennis Harvey. I work at Coursera as a Content Strategy Manager for Cloud Technology.
Hello there, my name is Bradley Steinfeld. I'm a software architect, and I work for IBM Cloud and Cognitive Software.
Hello everyone, my name is Upkar Litter and I'm a developer advocate with IBM.
Hi, I'm Jan Stoneman. I'm a solution architect at Smartronix.
Now, there's a lot to cover here, so to get the most from this course, view each video, check your learning with each quiz, and build a winning portfolio by completing the hands-on labs and final project. Take the next step along this exciting journey that leads to a world of possibilities, and good luck! Welcome to What is Backend Development. After watching this video, you will be able to define backend development, differentiate between front-end and back-end technologies, explain the components of the back-end of a web application, and describe the importance of a robust, scalable back-end. Client-server applications, such as cloud-based and web applications, generally consist of a front-end and a back-end. The front-end runs on the client machine, and the back-end runs on a server. The client machine runs the web browser and the web browser's engine. The browser's engine is what communicates with the back-end. Back-end developers work on the technologies that ensure a website performs correctly, part of which includes writing the code that communicates with the browser's engine and the back-end server. Furthermore, back-end development refers to the development of the server-side logic, including the code that pertains to databases, servers, and applications. Back-end technologies include servers, databases, web APIs, programming languages, frameworks, and runtimes. Servers consist of hardware, software, or both that communicate with and provide functionality to a client. Servers may also communicate with and provide functionality to each other. Now, there are many types of servers. Web applications often use many types of servers, including database servers, application servers, and web servers. Let's briefly discuss each of these types of servers. The database server is the machine and the application that houses, retrieves, and delivers data. The terms database server and database are often used interchangeably. Web servers ensure client requests are responded to, often using Hypertext Transfer Protocol, or HTTP for short. An HTTP server is part of the software running on a web server. The software part of a web server is what controls how a user accesses files hosted on the server. Application servers host and deliver a business application through HTTP. They sit between a database server and a web server. Application servers transform data into dynamic content and run the business logic, which is the data storage and transfer rules. Servers must communicate with each other as well as the front end in a client-server architecture. APIs, which stand for Application Programming Interface, allow two pieces of software to communicate with each other. A web service is a type of web API. A web service communicates using HTTP requests. In other words, the web service is the programming interface that sends and receives requests using HTTP among web servers and the client. Back-end programming languages are the languages that developers use to make the servers function. These languages include JavaScript, PHP, Python, Ruby, Java, and C#. Now, frameworks provide structure for code. An application can be built and deployed using a framework. The framework often generates code that cannot be altered to perform common tasks. Some common back-end frameworks include Django, a Python framework, Ruby on Rails, a Ruby framework, and Express.js, a JavaScript framework. Express.js is a framework running on top of Node.js that handles HTTP requests made to a web server. Let's now discuss runtime environments. A runtime behaves similarly to a mini operating system that provides the resources necessary for an application to run. The runtime is the infrastructure that supports the execution of a codebase. It is the hardware and software environment in which an application gets executed. Node.js is an example of a back-end runtime environment. So, the reason Node.js has become so popular as a back-end technology is because it runs on Google Chrome's open-source V8 engine, the same engine that runs the browser on the front end. Moreover, most modern browsers, such as Microsoft Edge and Opera, also run on the V8 engine. Node.js makes it very easy for the front end to communicate with the back end. Node.js executes JavaScript. Recall from a previous course that JavaScript is widely used on the front end. This makes JavaScript a handy language for web developers to learn because of its use both on the front end and the back end. Another issue back-end developers need to be concerned with is scalability. Scalability is essential for enterprise software success and is the responsibility of the back-end, which is affected by the load on an application. Now, load refers to the number of concurrent users, the number of transactions, and the amount of data transferred back and forth between the clients and servers. Web applications should be scalable. Scalability is the application's ability to dynamically handle the load as it grows or shrinks without it affecting the application's performance. Scalability is essential for the success of a client-server application. Lastly, other back-end responsibilities include security, authentication, and prevention of malware attacks. The back-end is also mainly responsible for performance because it retrieves and transfers data between machines, delivers content to the front end, and supplies the business logic of the application. In this video, you learned that back-end development refers to the development of the server-side logic, including the code that pertains to databases, servers, and applications. Front-end technologies are those that pertain to the client, such as the interface and the web browser. Back-end technologies include various types of servers and supporting infrastructures, such as programming languages, frameworks, and other hardware. And finally, the back-end is responsible for scalability, security, and performance.
Welcome to Introduction to Node.js. After watching this video, you will be able to describe the role of Node.js for server-side scripting, list the differences between JavaScript and Node.js, describe Express.js, and explain how Express.js helps developers build Node.js apps. Node.js is an open-source language that runs on V8. Being open source means that Node.js can run on Linux, Windows, and Mac OS X. V8 is an open source engine that was developed by Google for the Google Chrome browser. Developers often use JavaScript for client-side functionality. Node.js is the server component in the same language. Node.js is event-driven and uses asynchronous non-blocking I/O. With server-side JavaScript, Node applications process and route web service requests from the client. In Step 1, the user selects an option in the user interface written in HTML and CSS. In Step 2, this action by the user triggers JavaScript code that implements the business logic on the client side, for example, input validation. In Step 3, the JavaScript application makes a web service call over HTTP with a JSON data payload. The REST web service, which is part of a Node.js application running on the Node server, receives the HTTP request. In Step 4, the REST web service processes the request and returns the result to the client as a JSON payload over HTTP. Although developers can still use JavaScript for browser functionality in frameworks such as AngularJS, Dojo, and jQuery, they can now use Node.js in the same components of the architecture where they use Java, Perl, C++, Python, and Ruby. Node.js is used in production by companies such as Uber, Yahoo, LinkedIn, GoDaddy, eBay, and PayPal. It is event-driven and uses asynchronous non-blocking I/O. Express.js is a highly configurable framework for building applications on Node.js. It abstracts lower-level APIs in Node.js by using HTTP utility methods and middleware. Before you build your first Node.js app, let's get familiar with the IDE and some key Node.js concepts. Express.js simplifies application development on Node.js. The following features enable you to develop your application quickly. Public assets like image, CSS, and Java. Templates or views, server-rendered HTML that is sent back to the client in response to requests. Routes defines endpoints that accept and process client requests. Server.js, a file which contains the main application code. Package.json contains metadata information about the project, including dependencies, scripts, and so on. In this video, you learned that Node.js is the server-side component of JavaScript. Using Node.js can improve application performance, and Express.js is a framework that helps you build Node.js applications.
Welcome to Expert Viewpoints, introductory thoughts on server-side JavaScript and Node.js. In this video, we will hear from several application development professionals discussing working with server-side JavaScript and Node.js.
The wonderful thing about using Node.js as your backend language is it's the same as your front-end language. So it makes it easier kind of to context switch between writing for the front end and then writing for the back end. You can have the same developers basically writing both. I mean, a lot of developers know multiple languages, but this way, if you've got someone very strong at JavaScript, all that knowledge will pay off in both the front end and the back end. And you can also use the same code scanning and code testing for the front-end JavaScript as for the back-end JavaScript. So that, and like the dependency security scanning and all of that, both the front end and the back end are going to be using NPM, the node package management, for the dependencies, and that way you've got kind of a unified approach to dependencies and packages.
I think the most obvious appeal of using Node.js, at least for full stack developers, is that you get to use the same language client side and server side. So if you're a new developer, that's one less language you have to learn. And even if you're not, it can be nice to minimize the differences when context switching between front-end and back-end development. Another benefit is actually the community surrounding Node.js. I think on the most recent Stack Overflow survey, it was being used by over 50% of professional developers, and that's really reflected in the wealth of learning resources and support that are available to you.
So if you are a front-end developer, if you understand JavaScript, then picking up backend using a framework like Node.js is not that much of a stretch. I actually started building static websites, and then slowly learned how to put in dynamic content using JavaScript, and then I had to use Java or PHP to build my backend systems on the server. And there's a little bit of a context switch when you're doing that. With Node.js, the cool thing is you're using JavaScript on the front end and you're using JavaScript on the back end as well. So there's a little bit less of a context switch. It's easy to switch between working with services on the back end and then going to your website and putting in some JavaScript. The one thing that I did find a little bit odd at first was the single-threaded nature of Node.js and everything relying on callbacks. So asynchronous programming using callbacks is a little bit of a twist with Node.js, but it's a matter of getting used to that. The one thing I did like was the abundance of packages in registries like NPM for you to be able to use in your applications.
Key benefit of using Node.js is faster processing. It can handle concurrent requests faster than any other server-side languages. Node.js is a popular choice for online gaming, chats, video conferences, or any solution that requires constantly updated data. It is easier to learn Node.js if one already has a good grasp on JavaScript. Developers can write both front-end and back-end in JavaScript using a runtime environment. There is no need for separate front-end and back-end developers in this case.
So JavaScript is obviously the de facto standard for client-side web development, and so it quite naturally makes sense to allow JavaScript developers to leverage those skills on the server side, and that's where Node.js fits in nicely. The big deal with Node.js is its architecture, as it offers a rather unique single-threaded, asynchronous, event-oriented architecture that enables it to handle a very large number of concurrent connections. Think hundreds of thousands of concurrent connections. Node.js is built on top of Google's Chrome JavaScript engine, V8 engine. Parsing JSON is blazingly fast because JSON is a native data type in JavaScript. And Node.js also fits very nicely into the adoption of microservices, since each microservice is dedicated to one or a small number of cohesive services and is inherently therefore limited in scope.
Welcome to Import and Require. After watching this video, you will be able to explain what a module is, explain what a module specification is, explain the purpose of import and require statements, and differentiate between import and require statements. In Node.js, modules are files containing related encapsulated JavaScript code that serves a specific purpose. Modules can be a single file or a collection of multiple files and folders. Developers rely heavily on modules because of their reusability as well as their ability to break down complex code into manageable chunks. So, when an external application needs to use the code contained in a module, the application needs to call that module. When the external application calls a module, the module is called using an import or a require statement. Which statement is needed depends on the specification. Let's talk about specifications next. A directory with one or more modules bundled together is called a package. Module specifications are the conventions and standards used to create packages in JavaScript code for Node.js applications. The most commonly used module specifications for Node.js applications are CommonJS and ES modules. Some of the differences between CommonJS and ES modules will be discussed in a moment. By default, Node.js treats JavaScript code as a CommonJS module. Library authors can easily enable ES modules in a Node.js package by simply changing the package file extension from .js to .mjs. CommonJS modules use the require statement to import modules, whereas ES modules use the import function. When a module is needed outside of its own file, it must be exported first. The module.exports statement should be used with CommonJS. Modules can be exported to an ES specification using the export keyword. Next, we'll take a closer look at the differences between require and import. Let's look at the differences in calling require and import within the application code. The require statement can be called anywhere in the file, whereas the import statement must be called at the beginning of the file. Since the require statement can be called from anywhere, this means that it can be called within conditional statements and functions, but import cannot. This may sound like an advantage of require, but note that the require statement is bound dynamically, whereas import is bound statically. This means errors that occur when linking the function definition to the function call will not be identified until runtime. For import, binding errors are identified at compile time. Require modules are synchronous in nature, and modules imported with import are asynchronous. Synchronous means the modules will be loaded and processed in a linear fashion, one at a time. Asynchronous means the modules can be processed simultaneously. Import runs faster compared to require functions in large-scale applications which involve loading hundreds of modules. Let's take a look at some sample code that shows how to export and import using require and import. Recall that the require statement is used with CommonJS applications. This code snippet will show how to export from a file named message.js. We use module.exports to export the string hello programmers from the message.js module. Next, to import the message.js module into the main application, we use the require statement. In this code, the result of require is assigned to let MSG, then the variable is logged in the console. Now, let's look at code that exports an ES module from a file named module.mjs. This code names a constant a and sets the constant equal to 1. Next, the export statement is used. Note the use of the curly brackets. A is renamed to myValue. Finally, we look at code to import an ES module using import. Simply use the import keyword. We are importing myValue from the module.mjs file. In this video, you learned that a module is a file containing related JavaScript functions that serve a specific purpose. Module specifications are conventions and standards used to create packages in JavaScript code. Import and require statements are used to call a module or a package into an external application. The require statement can be called from anywhere in the app code, is bound dynamically, and is synchronous. And finally, the import statement can only be called at the beginning of a file, is bound statically, and is asynchronous.
Welcome to Introduction to Server-Side JavaScript. After watching this video, you will be able to explain the purpose of the Node.js JavaScript framework and explain the differences between client-side JavaScript and server-side JavaScript. JavaScript is one of the main languages used in the World Wide Web. It was originally built to add dynamic behavior to static websites on clients where there were primary browsers. JavaScript is an interpreted language. You do not need to compile JavaScript applications before running them. Although the language syntax resembles Java, it is not derived from the Java programming language. JavaScript can now be run on different servers and embedded systems, and all modern web browsers support JavaScript. Developers build responsive, interactive web applications with hypertext markup language, or HTML, cascading style sheets, CSS, and JavaScript. With a text editor and web browser, you can quickly write, test, and debug JavaScript applications. With client-side JavaScript, developers create rich, interactive web applications in the web browser. In Step 1, the user interface is rendered using HTML and CSS. When the user selects an option in the web page, it triggers business logic written as a JavaScript application. The JavaScript application sends a web service request using JavaScript Object Notation, or JSON, over Hypertext Transfer Protocol, HTTP. On the server, a representational state transfer, or REST web service, intercepts the call. This service traditionally would be written in Java, PHP, Hypertext Processor, or another backend language. In the last step, the application server processes the web service request using a server-side application such as Enterprise Java components and returns to the client. With a server-side JavaScript, Node.js applications process and route web service requests from the client. Compare the following diagram with the one in the previous slide. Most of the steps are identical. In Step 1, the user selects an option in the user interface, which is written in HTML and CSS. In Step 2, the option triggers a JavaScript application that implements the business logic on the client side. In Step 3, the JavaScript application makes a web service call over HTTP with data payload written in JSON. In Step 4, the REST web service intercepts the HTTP request. And in the final step, instead of invoking an enterprise Java application, the Node.js server hosts an application written in the JavaScript language. This code written in JavaScript runs on the server and not in the client's web browser. In this video, you learned that Node.js is a server-side programming framework that uses JavaScript as its programming language. With server-side JavaScript, Node.js applications process and route web service requests from the client. And Node.js is for developers who want to build scalable, concurrent server applications quickly with a minimal set of tools. Welcome to creating a web server with Node.js. After watching this video, you will be able to describe characteristics of Node.js and write a simple web server with Node.js. Node.js is a server-side programming framework that uses JavaScript as its programming language. Many developers are already familiar with the JavaScript language. It is built with a heavy emphasis on concurrent programming with a lightweight language. Node.js is a single-threaded application environment that handles input-output, or I/O, operations through events. Instead of blocking on asynchronous I/O operations, you write callback functions to handle results when they complete. Node.js is suited for developers who want to build scalable and concurrent server applications by using features like callback functions and the Node.js runtime event loop. These features of the JavaScript language and the Node.js runtime enable quick development with a minimal set of tools. Every JavaScript file is a module in Node.js. A module corresponds to a script file, and a package can contain one or more nodes. The Node.js runtime is packaged with many utility models that you can use to create and extend your applications. With the HTTP Node.js module, you can develop an application that listens to HTTP requests and returns HTTP response messages. To create an instance of a web server, use the http.createServer function. The web server is stored in a variable called server. The createServer function takes in an optional callback function as a parameter. This callback function handles the incoming request message and provides an appropriate response message. The callback function shown here is anonymous. After you create an instance of the server object, you can set the server to listen to a specific port. For example, call the http.listen function with a parameter of 8080 as the port to set the server to listen on 8080. In this video, you learned that Node.js is a single-threaded application environment that handles I/O operations through events. Every JavaScript file is a module in Node.js. And with the HTTP Node.js module, you can develop an application that listens to HTTP requests and returns HTTP response messages. Welcome to Working with Node.js Modules. After watching this video, you will be able to describe Node.js packages, import Node.js modules into your script, export functions and properties from a module, and access exported properties from a module. A package consists of one or more modules. The package.json file describes details about a Node.js module. If a module does not have a package.json file, Node.js assumes that the main class is named index.js. To specify a different main script for your module, specify a relative path to the Node.js script from the module directory. This is an example of a package.json file. The name and version fields form a unique identifier for the module. For example, today-1.0.0. The main field lists a path to the main Node.js script. In this example, the today.js script in the lib subdirectory. Package.json defines many other fields. For example, license states the module's usage rights. You can use the require function to import a Node.js module. The require statement assumes that scripts have a file extension of .js. The require function creates an object that represents the imported Node.js module. In this example, a Node.js script file that is named today.js is in the same directory as your application. When you call require with the name of a subdirectory, Node.js looks for a script file with the same name as the subdirectory. If the script file does not exist, the function assumes that the name is the name of a directory and looks for a script named index.js within that directory. To import a Node.js module that consists of a single script, use the require function with a relative path to the script file. In this example, the main application is in the Node.js script file. Hello.js makes a require function call to the today.js script file. This example uses the same hello.js Node.js file. The Node.js module is saved in a directory named mod_today. The actual script file is saved in index.js. When hello.js makes a call to the require function in the mod_today directory, the script file checks whether there is a file named index.js. This is the default name for a script in a Node.js module. Each Node.js module has an implicit exports object. To make a function or value available to Node.js applications that import your module, add a property to exports. In this example, the day of week property is added to the exports object. Then, day of week is assigned an anonymous function that returns the day of the week. For example, if the day of week function returns 1, this value maps to Monday. When you import a Node.js module, the require function returns a JavaScript object that represents an instance of the module. For example, the today variable is an instance of the today Node.js module that is called today. To access the properties of the module, retrieve the property from the variable. In the same example, today.dayofweek represents the current exported property from the today Node.js module. In this video, you learned that every package has a package.json file that describes details about a Node.js module. To make a function or a value available to Node.js applications that import your module, add a property to the implicit exports object. And when you import a Node.js module, the require function returns a JavaScript object that represents an instance of the module.
Welcome to Overview of Node Package Manager. After watching this video, you will be able to explain the purpose of a package manager, describe the two main aspects of Node Package Manager or NPM, describe the purpose of a package.json file, and compare and contrast a local NPM install to a global NPM install. When dealing with languages that use modules and packages, such as JavaScript, a tool called a package manager is usually needed. A package manager is a set of tools used to deal with modules and packages containing dependencies. Sometimes it is also referred to as a package management system. Now, dependencies are code usually in the form of libraries and packages that are called and reused in a program. So, for example, say you are developing a new module and you call a function contained in another module written by you, which calls another module written by someone else, which calls yet another module written by that third party. The module you are writing is dependent on all of those other modules. A library of code usually contains many dependencies, but the library is self-contained and isn't dependent on code outside of the library itself. Packages work the same. A package manager automates the process of finding, installing, upgrading, configuring, maintaining, and removing packages for a computer program. Package managers usually are connected to and maintain a database of dependencies and versioning information for the packages in a repository. The package manager ensures that a piece of software has the dependencies to run correctly and eliminates the need to do this work manually. Node Package Manager, usually abbreviated as NPM, is the default package manager for the Node.js runtime engine. NPM has two functions. First, it provides a command line interface that allows users to publish and download packages. Second, it behaves as an online repository of binary JavaScript packages. The repository is a database of packages that tracks versions of packages referenced in applications. All NPM packages require a file named package.json that should be located in the project's root directory. NPM uses the metadata in the package.json file to determine all of the dependencies in a package. This file contains the project's identifying metadata in the form of key value pairs that, at a minimum, identify the name of the project and the project's version number. The code shown here displays an example of those two key value pairs. There are two ways in which NPM can install packages, locally or globally. You will want to use the local install if you are installing a package you want to use within your application. Run the local install command from the directory you want the package installed in. The local install is NPM's default behavior. To install the Node modules package locally, use the NPM command line interface to enter npm install package name. This command creates a directory named Node modules with the package and its dependencies in your current working directory. Packages can also be installed globally. A global install means that all packages on the machine in which the package is installed can use that code. Global installs should be used judiciously because all projects on that computer will make use of that package and its dependencies. If you have different versions of a project on your machine, they will all use the globally installed package, which might break compatibility with other dependencies. To install Node modules so the package can be accessed by any application on the machine, which means they are installed globally, use the command npm install -g package name in the command line interface. It is the same command as the local install command, but adds the -g option. In this video, you learned that the package manager ensures a piece of software has the dependencies it needs to run correctly. NPM provides a command line interface tool and also functions as an online database of JavaScript packages. NPM uses the metadata in a package.json file to determine a package's dependencies. And a local install means only the application within the directory of the installed can access the package, whereas a global install means that any application on the machine can access the package.
Welcome to Asynchronous I/O with callback programming. After watching this video, you will be able to explain the concept of asynchronous callback functions and handle inbound hypertext transfer protocol, or HTTP, method calls for a server resource. Network operations run in an asynchronous manner. For example, the response from a web service call might not return immediately. When an application blocks or waits for a network operation to complete, that application wastes processing time on the server. Node.js makes all network operations in a non-blocking manner. Every network operation returns immediately. To handle the result from a network call, write a callback function that Node.js calls when the network operation completes. This sequence diagram for a scenario shows the interaction between the application, the Node.js framework, the web service call to the remote server, and the callback to the callback function. In the first step, the application makes a call to http.request. This function makes a call to the remote web server and requests the web service. Before the Node.js framework receives the HTTP response message from the remote web server, it immediately returns a result for the http.request function call. This result simply indicates that the request message was sent successfully. It does not say anything about the response message. When the Node.js framework receives an HTTP response message from the remote server, it calls the callback function that you defined during the http.request function call. This function handles the HTTP response message. In a slightly more complex scenario, your application calls a custom Node.js module, which then makes an http.request function call. The Node.js framework then calls the remote server's web service by sending an HTTP request message. In the same manner as in the first scenario, the Node.js framework returns a value to the HTTP function call in the Node.js module. This response simply states that the HTTP request was successfully sent out. The Node.js module then returns from the exported function call. At this point, the application continues processing on to the next step, while the response message has not yet been sent. When the remote server returns an HTTP response message, the Node.js framework calls the callback function defined by the custom Node.js module. The purpose of the callback function is to handle two events, request.onData and request.onEnd. In this case, the callback function simply prints the HTTP response message body to the console log. This code example shows you how to make an HTTP request call from a function inside a Node.js module. The first parameter in the HTTP request function is an options variable. The options variable includes at least two variables, the host name of the remote server and a uniform resource locator or URL resource path that you want to act upon. In this example here, you are making a call to the United States National Weather Service to retrieve the weather observation from San Francisco International Airport, KSFO. The second parameter of the HTTP request function is a callback function. In this case, it is an anonymous function that receives one parameter, the response object. When the Node.js module calls this anonymous function, events occur while it is receiving parts of the HTTP response object. In this example, there are two specific events, a data event and an end event. For these two events, you define more callback functions to handle each event type. In the actual coding, you may need to use HTTPS instead of HTTP. The result object is passed into the callback function of a parse string module. The HTTP.request function takes in a URL and a set of options. If both are passed, the two are merged with options taking precedence. You can define the host, ports, authentication, protocol, and other headers in the options object. The HTTP.request method also accepts an optional callback function that is evoked immediately once a response is received. When the HTTP.request calls the callback function, it passes a response object in the first parameter of the callback function. This callback function has the response object as the first parameter. The Node.js framework emits several events during the course of the request function. You can listen to these events by using the object.on method and passing in the event name as the first parameter. If the request is successful, a data event is emitted on the response object every time data comes in, followed by an end event when the response finishes. If the request fails, there is an error event followed by the close event. Let's see how to handle such errors. The request method returns an object of type http.clientRequest. This object represents the request in progress. You can append to the request body, make changes to the headers, and listen for error events as shown here. The code simply outputs the error message if there is an error. To end the request, call clientRequest.end. In this video, you learned that when an application blocks for a network operation to complete, that application wastes processing time on the server. Node.js makes all network operations in a non-blocking manner, and when the Node.js framework receives an HTTP response message from the remote server, it calls the callback function that handles the HTTP response message. Welcome to creating callback functions. After watching this video, you should be able to create a callback function to intercept Hypertext Transfer Protocol, or HTTP method calls. As an asynchronous framework, Node.js makes extensive use of callback functions to return the result to the calling function. Node.js modules in the Software Development Kit, or SDK, pass an error object as the first parameter in a callback function. Here, the function is defined with an error as the first parameter. With this convention, the callback function checks if the first parameter holds an error object. If error is defined, the callback function handles the error and cleans up any open network or database connections. If the error is not defined, then the callback function examines the result from the call. If the error is defined, print the error message. Otherwise, the weather.current function call completed successfully. Print the result from the function call. The codes are in the main app, which has a weather object, the Node.js module, that calls the weather's current function. The location is an input parameter, in this example, an airport. To print temp_f in the browser, we can use response.end. The current weather reading is $temp_f degrees. Now we'll look at an example of passing an error object to the callback function. Recall how callback functions check the first parameter to see if an error condition occurred. Instead of printing the result in the console, you call the result callback function with the error object. You pass back the error object to the result callback function of the main application. If no error occurred, you can call the result callback function with null as the first parameter. The codes are in the custom Node.js module. The callback handler printed the contents of the HTTP response message body to the console. What if you wanted it to return the response message to the original calling application?
If you use a return function, Node.js might call the callback function after the http.request call completes. The application calls the exported function. The module that implements the function calls http.request so that the Node.js framework can make a web service call on its behalf. When that request is sent successfully, the framework returns control to the Node.js module. Then the Node.js module returns control to the application. When the remote server sends back an HTTP response message to the Node.js framework, the framework calls the callback handler that was defined by the Node.js module. However, there is no connection between the callback function and the main application. So how do you link the callback function to the main application? The pattern is that when one Node.js application calls a module in a non-blocking manner, the application provides a callback function to process the result. If the main application calls http.request, it must provide a callback handler to process the HTTP response message. If the main application calls a function that calls http.request, there are two callback functions. The custom module has a callback function that handles the HTTP response message from http.request, and the main application has a callback function that processes the result captured in the first callback function. Let us see how this solution works. We will create a callback function to capture the result from the http.request function call. The application makes a call to the Node.js module. The Node.js module makes an http.request function call in order to send an HTTP request message to a remote server. Before the remote service returns an HTTP response message, the http.request function call returns control to the Node.js module as the request message was successfully sent. Then the Node.js module replies with a value to the main application. At a future point, the remote server sends back an HTTP response message. The Node.js framework calls the callback function defined by the Node.js module. This callback function calls another callback function defined by the main application. Having one callback function invoke another callback function is the only way to pass a message from the Node.js module to the main application when the Node.js module receives a response message. Here, when the main application calls weather.current, it passes an anonymous callback function to process the result from the call. In this case, the anonymous function takes in one input parameter, temp_f. The purpose of this callback function is to take the weather reading in degrees Fahrenheit and print the results in the console log. The result callback function in the function of the custom Node.js module links to the anonymous callback function temp_f of the weather object's current function in the main application. Now you can see a Node.js module that returns a result to the main application with a callback function. Here, a function is defined for the property named current. This property will be exported as part of the module. The anonymous function takes a parameter named result callback from the main application. This is how you pass a reference to the main application's callback function to the Node.js module's callback function. The result callback parameter stores the anonymous callback function from the main application. Look at the bottom of the current property. A response.onEnd event handler handles the transmission of the HTTP response message. When the remote server finishes sending back the response message, the code makes a call to result callback and passes it to the current weather reading in degrees Fahrenheit. This is how you pass a value from one callback handler to another. In this video, you learned that Node.js makes extensive use of callback functions to return the result to the calling function. Node.js modules in the SDK pass an error object as the first parameter in a callback function, and there is one callback function at each level.
Welcome to Expert Viewpoints, using anonymous callback function in Node.js. In this video, we will hear from several application development professionals discussing when they found it helpful to know how to use anonymous callback functions in Node.js and how they were key to the solutions they developed.
Anything in Node.js that requires you to make a request outside your application, which most likely you will, understanding how callbacks work is very important. So when we say anonymous callbacks, callbacks don't have to be anonymous. In fact, a lot of times I will write named functions and pass that as arguments into my functions that need the callback. I'll give you an example. So let's say you're building a website that displays temperature on the main website. Right, so in order to get the temperature, you're most likely calling another website, most likely another web service that accepts some JSON as input and gives you back another JSON as output. Now, when the end user comes on your website and they're scrolling up and down, if you block that and make the request to the weather API, then your user will not be able to even scroll up and down, right? So in the browser, it's doing one thing at a time. Node.js is single-threaded, and so everything gets blocked if you're making that request. And if you think about it, if the weather API is not giving you a response for whatever reason, maybe your credentials are incorrect, maybe the server is down, then your users are left waiting. In that case, the callback functions come in handy. So what you do is you make a request to the weather API and then you go about your business. And when a response comes back, you can handle that response and show the information to the user.
So understanding callbacks is key to mastering JavaScript. Functions are a first-class object in JavaScript and can therefore be passed as parameters to other functions. A callback function specifically follows the callback pattern and involves passing a function as a parameter to another function, and the callback function is invoked once the enclosing function has executed. And so a callback function is a closure in that the callback function has access to the containing function's scope variables. Callback functions can either be anonymous or named, and here we're talking about anonymous callback functions. Anonymous functions are sometimes more readable and are a good solution when the callback function is not intended to be reused. In other cases, a utility module like async.js can help cope with asynchronous JavaScript.
Anonymous callback functions in JavaScript are great. They're very useful to keep your code clean and define a function just on the fly. So I've used them extensively when dealing with messaging. The idea is that I'm sending messages and receiving messages, and I want to process those messages. I don't always necessarily want to define a full function for how to process it every single time. I just want to say, hey, when I get this message, I'm going to do something really simple. So oftentimes it's very easy and very useful to just create a very simple anonymous callback function which gets a message, processes it, does something, and then I never have to worry about it again.
If you're planning on using Node.js for web development, the concept of callback functions is one of the first things you'll need to grasp. When you're defining routes in your web server, you'll be relying on a library to provide you with request and response objects. These will be provided as arguments to your callback function, which will then read the request and modify the response to make sure the client gets the desired result. While it's possible to use named functions for your callback functions here, anonymous functions are often preferred because each route's logic is unique and not duplicated elsewhere. So using anonymous functions keeps your code clean and readable.
Anonymous callback functions allow you to write a block of scoped code that you can use again at a later time. Anonymous functions combined with the arrow syntax allow us to write clear and concise pipelines in JavaScript to manipulate data inside arrays.
Welcome to Issues with Callbacks. After watching this video, you will be able to explain why nested callbacks occur, explain the difficulties with nested callbacks, describe inversion of control, explain the difficulties with inversion control, and identify several ways to mitigate nested callbacks and inversion control. Recall that a callback is a function that is passed as an argument to another function that executes the callback based on the result. They are basically functions that are executed only after a result is produced. Callbacks help us develop asynchronous JavaScript code. Callbacks make sure that a function won't run before a prerequisite task is completed. In this example, message is an example of a callback function. When called, it writes, "This message is shown after 3 seconds" to the console. There is a built-in method in JavaScript called setTimeout, which waits a specified time in milliseconds before performing an action. In this example, the message gets passed into the setTimeout function. So, after waiting 3 seconds, setTimeout writes message to the console. Usually, these asynchronous callbacks, or async for short, are used for accessing values from databases, downloading images, reading files, and so on. Often, these resources are provided by other services outside of the application that needs them. Callback functions wait for a response, and when the response is sent, then they execute. For example, say you're making a cake. These are the steps. Purchase cake ingredients. Combine ingredients, bake the cake, decorate the cake, and serve the cake. These steps cannot be completed at the same time. In other words, these steps cannot be completed asynchronously. The following step can only be started after the previous step is complete. When using callbacks to make something occur sequentially, functions need to be nested one within the other. The pseudocode for our cake example might end up looking something like this, where each subsequent function becomes the argument passed to the next function. Every callback depends on and waits for the previous callback, thereby making a pyramid structure that affects the readability and maintainability of the code. This nesting of callback functions is often referred to as callback hell, and is essentially nested callbacks stacked below one another, forming a pyramid structure. This structure is also sometimes referred to as the Pyramid of Doom. Another issue with callbacks is inversion of control, also called IOC. Inversion of control happens when the flow of control, such as the execution of instructions, is external to your code. Many times, callbacks hand the control over to a third party, but issues and errors with that third-party code can be difficult to catch. You are forced to trust the third-party code, or you must write additional code that ensures the third-party code does not get called too many times or too few times, get called too early or too late, lose context, or pass back incorrect arguments. For example, say the third-party code has a bug where it gets called multiple times when the user mistakenly clicks a button more than once. You may try to solve this issue with a Boolean flag. When the flag is false and the button is clicked, the car gets charged and the flag is turned to true. So now, when the flag is true and the button gets clicked again, the branching logic doesn't charge the customer's card another time. But then, what if the callback never gets called at all? That flag remains false, and now there is yet another use case you have to account for. To catch these sorts of errors, your code becomes riddled with extraneous code to ensure third-party code doesn't fail. Now, there are a number of ways to mitigate callback hell and trust issues. You can write comments, split functions into smaller functions, use promises, or you can use async await. Promises and async await will be discussed in upcoming videos. In this video, you learned that the need for nested callback functions can occur when several of the callback tasks are dependent on each other and need to be completed sequentially. The term callback hell refers to nested callback functions. When using third-party code, you often have inversion of control issues where you cannot trust the third-party code. And ways to mitigate callback hell and trust issues include writing comments, splitting functions into smaller functions,
using promises, and using async await. Welcome to Promises. After watching this video, you will be able to define promises, explain the different states of a promise, and describe how to use promises with asynchronous methods. A promise is an object returned by an asynchronous method. The promise has 3 states, which are pending, resolved, and rejected. Promises are most useful for application programming interface or API requests, input-output or I/O operations, and other operations that are time-consuming and can block resources. A method can be defined to return a promise object if you know it is going to take time for execution and thereby block resources. When you call a method that returns a promise object is created. The initial state of the promise is the pending state. It is in this state until the operation is complete, or some error has caused the operation to abort. When the operation is complete, the promise is said to be resolved. When there is an error, the promise is said to be rejected. You can also create a promise object if you know that the operations you are going to perform could be blocking. In this example, meth call is a promise which is fulfilled or rejected depending on whether the file is successfully read or not. You can see on the output screen that the content of the file is read if the file name is valid and displayed. In this case, the promise is resolved. If the file name is invalid, the promise is rejected and the error message is displayed. You know that Hypertext Transfer Protocol, or HTTP, requests when called synchronously can be blocking. There are many packages in the Node.js ecosystem that wrap promises around HTTP requests. The Axios package is one such package to handle HTTP requests. It returns a promise object. The status of the promise until it hears back from the Uniform Resource Locator or URL requested is pending. The promise object has a then method which is called after the promise is fulfilled. The catch is executed if the promise is rejected. In this example, you first pass a valid URL. It creates a pending promise. Once the promise is fulfilled, the response is logged on the console. Next, you pass an invalid URL. This also creates a promise object which is pending. This promise will be rejected. This state is being dealt with in the catch block. You can see the console log for the resolve and reject. In this video, you learned that a promise is an object that is returned by an asynchronous method. The initial state of the promise object is the pending state. The Axios package is used in Node.js to handle HTTP requests. And you can create a promise if you know that the operations could be blocking. Welcome to Working with JSON. After watching this video, you should be able to parse JavaScript object notation, otherwise known as JSON, data from a Hypertext Transfer Protocol, or HTTP message. JSON is the standard format for Application Programming Interface, API data exchange. It is the standard representation of native JavaScript objects, and Node.js handles it easily. In this example, the object consists of attribute-value pairs. The first attribute is company, and the value is IBM. The second attribute is country, and the value is USA. The third attribute is headquarters, and the value is Armonk, New York. To parse a JSON string to a JavaScript object, use method JSON.parse. Method JSON.stringify converts a JavaScript object to a JSON string. Now that you know what JSON is and 2 important methods that you can use to parse a string into JSON and also convert JSON into a string, let us see an example of using a real endpoint that returns JSON. You can use JSON to find out how many astronauts are in the International Space Station, or ISS. You have found that the number of astronauts is 5. In this video, you learned that Node.js handles JSON easily. And you can use 2 important methods to parse a string into JSON and also convert JSON into a string. Welcome to Expert Viewpoints, using JSON and JavaScript. In this video, we will hear from several application development professionals discussing situations where knowing JSON and JavaScript has helped them and how they think these methods can benefit new developers.
Familiarity with JavaScript and JSON is more or less a requirement for web developers. If you're not working with the front end at all, you might be able to get away without touching any JavaScript, but JSON is the de facto standard for data serialization. You'll want to learn how to use JSON so that you can consume APIs written by other people and also make your own APIs return JSON so other people can easily use them. Another place you'll see JSON a lot is where you have to specify something in a way that a computer can easily understand. So you'll probably first see that when specifying requirements for a Node.js project, for instance, but you might see it again when specifying deployments for platform as a service offerings or Kubernetes workloads.
So JSON, or JavaScript Object Notation, is built into JavaScript, right? So when you're working with objects in JavaScript, you're essentially working with JSON. That being said, with REST web services, a common format of communication or data is also JSON. So as Node.js developers and as JavaScript developers, you cannot escape from JSON. It's actually a very friendly format to work with. Yeah, JSON is one of those things, if you're a JavaScript developer, if you're a Node.js developer, you need to understand and work with JSON objects. So the sooner you pick it up, the better.
JSON is one of the dominant formats to encode objects in a string. And JSON is a native data type in JavaScript. So serialization converts the JSON object into a byte string, and deserialization converts the byte string back to the JSON object. One great benefit of being comfortable with JSON is that the request and response objects in Cloud REST APIs are often in JSON, at least when you're working at the curl level or the shell script level. Another benefit of knowing JavaScript and JSON is working with JSON-oriented document databases.
Writing in JavaScript and using JSON helps me all the time because JavaScript is the language of the internet, so you see it in a lot of applications, and being able to just add some code to an existing project or write some JavaScript from scratch is really useful. It's like speaking a language that's very popular. And JSON is used by many of the modern languages, including Python and Node.js. So I use Python every single day because it's a really useful way to structure your data and pass it back and forth. And you know, that's the way you get a response from most APIs.
Welcome to this video that delves into the core concepts of handling asynchronous operations with promises, async, await, and Axios in Node.js and Express. After watching this video, you will be able to explain the fundamental concepts of promises and how they chain operations in JavaScript, use async/await syntax for clearer and more readable asynchronous code, make HTTP requests using the Axios library. Suppose you use a web application to purchase garden equipment. The application lags in performance, and you find the shopping experience disappointing. Would you like to use that application again to make any purchases? A web application with JavaScript's asynchronous programming doesn't face such issues, as it is responsive and performant. Mastering asynchronous programming is essential if you're working with Node.js and Express, as asynchronous programming improves the performance of your web applications and enhances the user experience. Let's start by exploring promises, a fundamental concept for managing asynchronous operations in JavaScript. A promise is an object that represents success or failure of an asynchronous operation and its resulting value. It allows you to chain operations in a more readable and manageable way. Now, let's learn about the states of a promise. A promise can be in 3 states: pending, fulfilled, or rejected. Pending denotes the initial state, which is neither fulfilled nor rejected. Fulfilled state denotes the successful completion of the operation. Rejected state means that the operation has failed. This allows us to handle asynchronous tasks more gracefully compared to traditional callback methods. Now, it's time to explore how to create a promise. In this code snippet, you can see the creation of a promise. To create a promise, we use the new promise constructor, which takes a function with resolve and reject as parameters. If your operation is successful, the resolve function is called. Otherwise, the reject function is called. Let's now explore how promises allow you to chain multiple asynchronous operations in sequence. In this example, the code allows you to handle the resolved value or the error using then and catch methods. These methods also return promises and chain multiple asynchronous operations in sequence. Now, let's explore a practical example where promises are used to read a file. In this code, the promises module performs the following function. It reads the contents of a file. It prints the file content to the console if the file is read successfully, and it throws an error message to the console if the file is not read successfully. Now, it's time to learn how to work with promises using async/await. Promises complicate the structure and readability of your code. Async and await are syntactic sugar over promises, which makes asynchronous code look more like synchronous code, which makes it easier for you to read and write. As async function returns a promise, you can use await inside an async function. This use of await pauses execution until a promise is resolved or rejected. Let's delve deeper and explore async/await benefits in detail. When you use async and await, asynchronous code appears more linear and easier to understand. It allows you to use the standard try-catch for error handling, which is more familiar to developers. Also, you can debug easier due to the asynchronous flow of the code. Now that you can recognize the key benefits of async/await, let's use async/await in an example. This code snippet shows how async/await function simplifies asynchronous programming in JavaScript. In this example, the async function performs the following actions. It simulates a conditional operation. It returns a success message if the condition is met. It generates an error when the condition is not met. It uses await to call async function. It handles the result or any errors using try and catch. It handles promises more easily than chains. Now, it's time to learn about Axios and how it is used. Axios is a promise-based HTTP client for the browser and Node.js. Axios makes it easy for you to send asynchronous HTTP requests to REST endpoints and perform CRUD operations. Axios automatically transforms JSON data and provides a clean and simple API. Now, let's take a look at some key features of Axios. Axios offers the following features. It uses promises for easy async await usage. It transforms JSON data automatically. It allows you to intercept requests or responses to modify them. It supports request cancellation. And it provides comprehensive error handling features. Now let's use Axios to make a GET request in a practical example. As you can see in this code snippet, first, you need to install Axios. Once installed, you can use Axios and see how it simplifies making HTTP GET requests. The Axios.get method returns a promise that resolves with the response object. This allows you to access the data. Now it's time to learn how to use Axios to make a POST request. Let's look at a code snippet that demonstrates how Axios makes HTTP POST requests and handles responses and errors. This code imports Axios for HTTP requests and creates user data object for POST request. By using Axios.post function, this code sends data to the server. Finally, it logs response data on success and error message on failure. Now it's time to use async await and Axios together to handle HTTP requests. When you combine async await with Axios, it provides a clean approach to handle HTTP requests. In this example, you can see how the code uses await to pause the function execution until the post request completes. Finally, the result is handled inside the try block. In this video, you learn that asynchronous programming in JavaScript can build responsive and performant web applications. Promises provide you a way to handle asynchronous operations, making code more readable and easier to manage by allowing chaining of operations. The async await syntax builds on promises and enables you to write asynchronous code that resembles synchronous code, thus simplifying the handling of asynchronous tasks. Axios can be used as an HTTP client to make requests to external APIs and services, simplifying the process of handling HTTP requests in JavaScript applications.
Welcome to Extending Node.js. After watching this video, you should be able to extend Node.js with third-party packages and define package dependency. You can build a hypertext transfer protocol or HTTP server using Node.js, but the default Node.js framework is limited. However, there are many aspects of building a web server like routing, parsing incoming files, authentication, connecting to a database, and other aspects. For example, you can parse extensible markup language, XML, with JavaScript string functions, but an XML document object is not efficient in parsing a stream of XML data. Developers rely on external libraries and packages to extend the core Node.js functionality. Say you need to know about the weather data of San Francisco International Airport. You can send an HTTP request to an external web server. After you receive the weather data, you can parse it manually. Here, you parse web service messages as a string. When Node.js receives the final part of the HTTP response message, it calls the response.onEnd event handler. Inside the callback function, the first line of the buffer.match function call locates the part of the XML message that begins and ends with the temp_f XML element tag. This string, including the temp_f start and end tags, is saved in the matches variable. If there is a match, the second call to matches0.replace strips out the start and end temp_f XML elements. Consider the disadvantages of treating XML data as a string. String matching ignores the structure of XML data. The message body might contain malformed XML data. Depending on the complexity of the XML data, string matching might be more efficient than building an XML tree of the data. String matching is less tolerant to changes in the XML data structure, and if the message adds or removes any XML elements, you must change the regular expression on the string match function. You can use the XML2JS Node.js package to parse a string of XML elements into a JavaScript object. This is a Node.js package that uses only JavaScript. It does not require an XML parsing library written in another language. Because third-party packages might have a different software license, confirm that the licensing terms work with your company and your application before installing the XML2JS Node.js package. You can use the npm application to manage Node.js packages in your Node.js framework installation. For instance, run the npm install command to retrieve and set up a Node.js package and any package dependencies. In this example, you call npm install xml2js from the command line. The npm application goes out to the internet and retrieves the Node.js module xml2js and any dependencies that it requires. Here, you import the package into your application. In the first line, the parseString function calls the callback function when it finishes processing the XML tree in buffer. In the last line, the result JavaScript variable represents the contents of the XML fragment in buffer. In other words, the result JavaScript variable represents the XML element but in JavaScript form. The property current_observation.temp_f0 maps to the first child element in the temp_f XML element. The temp_f element is a child of the current_observation element. In this video, you learned that developers rely on third-party packages to extend Node.js's features. String matching ignores the structure of XML data. The XML2.js Node.js package parses a string of XML elements into a JavaScript object. And the npm application manages Node.js packages in your Node.js framework installation. Welcome to Expert Viewpoints, working with third-party Node.js extensions. In this video, several application development professionals will discuss which third-party Node.js extensions they commonly use and how these extensions could often benefit application developers.
One of the npm, Node.js packages that I've used the most is the serverless framework, because that allows you to deploy serverless microservices in the cloud very easily without writing a lot of the resource and infrastructure as code yourself.
So there's a number of Node.js extensions I use all the time. For instance, I use Lodash, which is a great package for dealing with collections and arrays, finding the right elements, sorting, so on and so forth. It saves a lot of time. Axios is also very useful for dealing with RESTful APIs, submitting gets, posts, so on and so forth. Also, in my Express applications, there's a ton of middlewares, especially middlewares dealing with authentication and JWT tokens. Those are all extremely useful and really help accelerate any cloud developer creating services and other tools in the cloud.
When working with Node.js, I'll give you two of my favorite packages that I use on a daily basis. So first is making requests to web services. So my application, more likely than not, has to request information from another web service. Now this could be a web service that I've written, or this could be a web service that somebody else has written. Regardless, I need to send a request out with some input parameters and then wait for the request to come back, or wait for the response to come back and handle that response. Instead of writing all of this code myself, I use a library like Axios that helps me create these requests with the right headers and also provide me with callback functions or promises to be able to handle the responses that come back. My second package would be when I'm working with databases. I'll use npm packages more likely than not to talk to an external database, regardless of if it's a relational database or a NoSQL database.
Welcome to Introduction to Web Frameworks. After watching this video, you will be able to explain the difference between Node.js and Node.js-based web frameworks, explain MVC and REST API architectural styles, and describe prominent features of several Node web frameworks. Sometimes Node.js is incorrectly referred to as a web framework. Node.js is not a framework, but a runtime environment that executes JavaScript on a server. Runtime environments are the hardware and software that can execute programs with a particular code base. A framework, on the other hand, is like a skeleton on which an application is built for a specific environment. The framework is the fundamental structure that supports the application. So, in order to utilize Node.js, you need to use a web framework that works in conjunction with it. A framework that works with Node.js is called a Node Web Framework or just a Node framework. There are a number of different Node frameworks, and we will discuss a few later in this video.
So, before discussing individual frameworks, let's first discuss two approaches to building backends that web frameworks can employ. Model View Controller, better known as MVCs, and Representational State Transfer, Application Programming Interfaces, or REST API for short. An MVC approach can be used simultaneously with REST APIs. They are not mutually exclusive. MVC stands for Model View Controller. MVC is an architectural pattern that divides an application into three components: model, view, and controller. Let's discuss what each of these components is. The model layer is responsible for managing the data of the application. It interacts with the database and handles the data logic. The view is responsible for rendering the presentation of the data that is passed to it by the model. And the controller regulates the flow of the data. It is responsible for processing the data supplied to it by the user and sends that data back to the model for manipulation or storage. MVC frameworks are generally used to develop applications that need a separation of data called the model, the presentation of the data called the view, and the module that manipulates the data, which is the controller. Frameworks that lend themselves to developing the back end with an MVC pattern include Koa, Django, Express, and Nest.js. Now let's discuss REST APIs. REST APIs allow multiple web services to communicate with each other. RESTful APIs are subject to certain constraints. The code on the client side must be completely independent of the server code. Client-side code can be updated without interfering with the server code and vice versa. Secondly, RESTful APIs are also stateless. Stateless means the client does not need to know the state of the server, nor does the server need to know the state of the client for communication between the two. REST APIs communicate via operations on resources, and they do not rely on a particular implementation of the API. When a client requests resources using a REST API using HTTP methods such as GET, POST, PATCH, or DELETE, the server responds with a representation of the state of the resource to the client. The representation of the data transferred between client and server is usually a JSON payload, but can also be HTML, XLT, Python, PHP, or plain text. So now that we've discussed a couple of ways to structure the back-end code, let's dig deeper and discuss some of the popular frameworks themselves. Express.js, aka Express, is one of the most popular Node web frameworks. It is used for routing and middleware. Its straightforward coding using JavaScript means there is a fairly small learning curve. It is easy to implement an MVC architecture pattern with Express. It provides debugging mechanisms to help easily pinpoint the errors in the application. Express delivers high performance because it handles multiple operation requests concurrently that are independent of each other with asynchronous programming. It has many HTTP helpers that make programs intelligible and reusable for handling HTTP requests. It has great content negotiation that helps the client and server to communicate by efficiently providing HTTP headers to URLs, fetching the exact data needed for the requesting client. Koa is a relatively new web framework designed by the same team who designed Express. It is designed to be smaller, more expressive, and provide a more robust foundation for web applications and APIs. Koa uses async functions in such a way that callbacks are not necessary, and it increases the ability to handle errors. Koa is appropriate for applications that are high-performing, demanding, complex, and developed by large, experienced teams. Socket.io is an excellent choice for developing apps where bidirectional data is exchanged between clients and servers in real time. You can develop applications that utilize WebSocket rather than HTTP for communication. Its servers push data without the need for the data to be called by the client. It is appropriate for applications such as chat rooms, texting applications, video conferencing, and multiplayer games. Next, Happy.js is a reliable open-source Node web framework with lots of security built into it. There are many built-in plugins, so you won't need to use unofficial middleware. It is most known for developing proxy and API servers, HTTP proxy applications, REST APIs, and other desktop applications. And finally, we have the Nest.js framework, which is appropriate for building dynamic, scalable enterprise applications in conjunction with its flexibility due to its multitude of libraries. It follows an MVC architecture. Nest.js is built on top of Express, so they have similar purposes and provide comparable functions. It is compatible with TypeScript, which is a superset of JavaScript. It works in conjunction with the front-end Angular framework, and Nest combines both object-oriented and functional reactive programming, which potentially doubles productivity and application performance. In this video, you learned that Node.js is a runtime environment, whereas Node web frameworks use the Node.js environment in order to run. The MVC architecture style divides a back-end application into 3 parts: the model, the view, and the controller. REST API frameworks use HTTP methods to communicate with each other, and several popular Node web frameworks include Express, Koa, Happy.js, and Nest.js. Welcome to Express Web Application Framework. After watching this video, you will be able to describe the Express framework, explain the primary uses of Express, and download Express. Express is a web application framework based on the Node.js runtime environment. However, Express abstracts low-level details. Express helps you organize your application better and develop your application faster. It provides robust mechanisms for integrating middleware packages and handling different hypertext transfer protocol or HTTP request methods. The Express Web Application Framework is widely used in the field today and forms the basis of other frameworks as well. Now, Express is primarily used for 2 purposes. One, as an API, and the second is to set up templates with server-side rendering, also known as SSR. Using Express to build APIs means setting up an HTTP interface to interact with the data layer. In the case of APIs, data is sent back to the client in JSON format using a response object, or res for short. The res.json method is used to notify the client of the content type of the data being sent, such as if it's an image or a text. It can also be used to stringify data, in other words, converting JavaScript to JSON format. In server-side rendering, or SSR, Express is used to set up templates. Express is responsible for using the data sent from the client supplied by an HTTP request in conjunction with the template to dynamically write HTML, CSS, and/or JavaScript. The HTML, CSS, and/or JavaScript is sent back to the client as text so that the browser can render the page. This is accomplished using the Express res.render method.
Express implements an app class that you map to a web resource path. In contrast, when using the Node.js Core Application Programming Interface, or API, the http.createServer function relies on your custom callback function to parse through the web resource path. Here is an overview of how to work with Express. There are 5 steps. Step 1. Declare Express as a dependency in the package manifest of a Node.js project. 2. Run the npm command to download any missing modules. 3. Import the Express module and create an Express application. 4. Create the new route handler. And 5. Start an HTTP server on a given port number. Next, you will see how to complete steps 1 and 2. First, to declare Express as a dependency in the package.json file, create a package.json file in your project folder. The package.json file stores information about the contents of a Node.js module, including 5 items: name, version, description, main, and dependencies. Name is a name for the Node.js module. Version is a string that defines the major and minor version number of the module. Description is a sentence that describes the purpose of the module. Main identifies the Node.js script as the entry point into the module. And dependencies is a list of which Node.js modules the current module requires. To declare Express as a dependency, list the Express module and a version number in the dependencies property. Here in the package.json dependency file, the name of the module is temperature. Its version is 1.0.0. Its description, retrieve current weather conditions in the United States. The main script file, which is the entry point in the module, is set to app.js. It has a dependency on the Express framework, which is version 4.x. Now, in step 2, you run the npm command to download any missing modules. When you run the npm install command inside the Node.js module directory, it resolves any missing dependent Node.js modules. The command downloads and saves any missing Node.js modules into its own node_module directory. This scheme allows you to use different versions of the same Node.js module in different packages. For example, a custom Node.js module installs a version 4.0 release of the Express framework. Another Node.js module installs version 5.0 in its own Node module repository. To install a Node.js module into the shared node_module directory, run npm install with your module name from the directory with your Node.js installation. To download Express, run npm install in your project folder. When you run the command npm install with no parameters, the npm application scans your package.json file. It checks your node_module directory to see if any modules are missing. In this case, the Express Web Application Framework is not in your current installation. The npm application downloads the Express framework and all of its dependent modules. In this video, you learned that Express is a third-party module that provides a framework for building web applications. Express serves two purposes: to set up APIs and to implement SSR. And to install Express, there are 5 steps. Declare Express as a dependency in the package manifest of a Node.js project. Run the npm command to download any missing modules. Import the Express module and create an Express application. Create a new route handler. And finally, start an HTTP server on a given port number. Welcome to your first Express web application. After watching this video, you should be able to create an application using Express and identify the 5 steps to install Express. Follow these 5 steps to work with Express. 1. Declare Express as a dependency in the package manifest of your Node.js project. 2. Run the npm command to download any missing modules. 3. Import the Express module and create an Express application. 4. Create a new route handler. And 5. Start a Hypertext Transfer Protocol HTTP server on a given port number. When you declare Express as a dependency in your Node.js project and download any missing modules, you create a mynodeserver.js file in your project folder. Now you can start coding with your first Express program. In this example, we are writing a program to retrieve current weather conditions. When you have imported a copy of the Express Web Application Framework, create an instance of the app JavaScript object from the framework. Next, create a new route handler. In your application to handle web application requests, map an HTTP method and a web resource path to the JavaScript function. Here, you are listening to incoming HTTP GET requests, which make requests to the temperature resource path. You are also saving the value after the temperature resource path in a variable named location_code. You can access the variable in the path by using request.params.location_code and store the value in a location variable named location. When you run the weather.current function, you pass the parameter location which is taken from the resource path. In the last step, you start an HTTP server on a given port number. To create an instance of the server from the app, call app.listen to create a web server object, that is, an instance that listens to incoming requests on the specified port. The app listens to incoming requests, for example, on port 8080. The second parameter defines an anonymous function that the Express framework calls when it creates an instance of the server object. For the result, enter the Uniform Resource Locator or URL in your browser. In this video, you learned that when you declare Express as a dependency in your Node.js project and download any missing modules, you can create an application and start coding with Express. And to install Express, there are 5 steps. 1. Declare Express as a dependency in the package manifest of a Node.js project. 2. Run the npm command to download any missing modules. 3. Import the Express module and create an Express application. 4. Create a new route handler. And 5. Start an HTTP server on a given port number. Welcome to Expert Viewpoints, working with back-end JavaScript frameworks and Express. In this video, we will hear from several cloud-native application development professionals discussing why they use Express.js for building back-end web applications.
The Express framework for Node.js is a great choice for building back-end web apps. It allows for very high-level expressive declaration of REST API endpoints, which is great for productivity as well as code readability. I believe it's the most popular web framework for Node.js, and the Express team and the community surrounding it have created a bunch of great middleware for things like parsing body content, authentication, handling user sessions, and request logging.
There are a number of reasons to use Express nowadays. It's popular, there's a ton of packages for it, so it'll give you the ability to create something with only a few lines of code. Also, Express is really great for working with middlewares, I find, which lets you pretty much do anything you want with any requests coming in or any responses going out when people are using your service. Also, Express can be very, very fast and very, very easy to use. So I find the development life cycle can be very short if you know what you're doing.
When it comes to using backend JavaScript frameworks, I am most familiar with Express.js. It's very prominent, and you can use it to create applications that live on the web. So Express.js abstracts a lot of low-level code that you would be writing yourself if you were building your website or web application on Node.js itself. So it makes me a more effective programmer or software developer. But more than that, Express is built on certain best practices that you would have to follow anyways if you were building all of this from scratch. So it's good to rely on this community-driven open source framework that more likely than not will do the right thing for me.
By using Express.js for backend development, we are able to scale applications quickly. We can code both frontend and backend with the help of JavaScript easily by using Express.js. Express.js is supported with the Google V8 engine, with the help of which you would be able to get higher performance without any lag or error in processing. It also supports the caching features, so you would not have to re-execute the codes again and again. Moreover, it will help web pages to load faster than ever. You can also integrate several third-party applications and services using Express.js.
I was taught to use Express when learning backend development, but I ended up not using it that much because I was able to use fully managed services in the cloud to handle a lot of those things for me. So I could have like an API gateway service to handle the API requests for me, and then I would just need to write the code for what to do in response.
Welcome to Routing, Middleware, and Templating. After watching this video, you will be able to explain routing in Express, describe middleware and how it is used, and explain template rendering in Express. Routing is an important aspect of server-side scripting. Requests to different routes to the same server must be handled by the server. Requests can be GET, POST, PUT, or DELETE. The server must handle each request to each of the routes or return appropriate error messages. Routing can be handled at application level or at router level. Here you are handling each method on each route with separate methods at the application level. This is simple when there are fewer endpoints or routes. This app.get handles GET queries to endpoint/user/about/ID. This app.post handles POST queries to the same endpoint. This app.get handles GET queries to endpoint/item/about/ID. And this app.post also handles POST queries to endpoint/item/about/ID. When there are many routes to handle, code maintenance is better with routers. A router by itself is used for branching query handling and routing each query differently. Here you are defining two routers. One is for an item and the other is for a user. All the requests that come with the item are handled by the item router. The /item/about and /item/detail routes are handled. All the requests that come with /user are handled by user router. Here /user/about and /user/detail routes are handled. Depending on the uniform resource locator or URL, the response changes. Middleware includes functions that have access to the request and response objects and the next function. The next parameter determines what is done after the function is executed. An Express application can have more than one middleware, and they can be chained to each other. Middleware is categorized based on purpose, use, and source. 5 types of middleware are application level, router level, error handling, built-in, and third-party. Middleware is useful for activities like parsing requests, adding authentication, and handling errors. Application-level middleware is bound to the application using app.use. All the client requests to this server application are routed through this middleware. This routing is useful for activities like authentication and checking session information. Here, you are defining middleware that will check the password that is passed. If the password is equal to pwd123, then it will log the time and chain to the next logical action, which is processing the request. If it is not, then the response status will be set to 402 and a message will appear saying that the user cannot log in. Consider application-level middleware as a gatekeeper. No request to the application server can go past it. Router-level middleware is not bound to the application. Instead, it is bound to an instance of express.router. You can use a specific middleware for a specific route instead of having all requests going through the same middleware. Here, if the route is /user, then you want the request to go through the user router. And if the route is /item, then you want it to go through the item router. You define the two routers, define the middleware function that the routers will use and what happens next, and then you bind the application routes to each router. The response will vary depending on the request route in the client side. Error handling middleware can be bound to either the entire application or to specific routers. Error handling middleware always takes 4 arguments, which are error, request, response, and the next function that it needs to be chained to. Even if you do not use the next parameter, you still have to define it in the method signature. This is an example of application-level error handling middleware. If the user ID 1 is accessed, then an error is thrown saying that it is the admin user. This error is handled by the middleware, which returns a response with a 500 status code. For all other users, the request is seamlessly processed and a Hello User ID message is displayed. Built-in middleware can be bound to either the entire application or to specific routers. Built-in middleware is useful for activities such as rendering hypertext markup language or HTML pages from the server, parsing JavaScript object notation or JSON input from the front end, and parsing cookies. This is an example of static middleware that is used to render static HTML pages and the images from the server side. Here at application level, you are defining that static files can be rendered from the CAD 220_static files directory. On the right, you see the HTML being rendered from that directory. Notice that the URL has only the server address and the port number followed by the file name. You can also define your own middleware or use third-party middleware, which can be made available through npm install. Because Node.js is open source, there are plenty available to install and use. Creating middleware is simple. It is a function that takes 3 parameters, which are request, response, and next. You can define a method that takes these 3 parameters and then bind it with app.use or router.use. The order in which the middleware is chained depends on the order in which the .use method is used to bind them. Here you are creating middleware named myLogger and making the application use it. The output rendered includes the time the request is received. Template rendering is the ability of the server to fill in dynamic content in the HTML template. This example uses Express React views, which renders React components from the server. You set the view engine property, which is responsible for creating HTML from your views. Views are JSX code. The views are in a directory named myViews. The view engine will look for a JSX file named index in the myViews directory and pass the property name to it. The output rendered will have the name of the user. This example shows the output for 2 users. In this video, you learned that routers are used for branching query handling. 5 types of middleware are application level, router level, error handling, built-in, and third-party. And template rendering is the ability of the server to fill in dynamic content in the HTML template.
Welcome to this video on exploring authentication and authorization in Node.js. After watching this video, you will be able to describe the need for authentication and how it validates a user's identity in Node.js, explain session-based authentication, including the creation, storage, and destruction of session IDs, and contrast token-based authentication and passwordless authentication, highlighting the use of JWTs and public and private key pairs. Imagine designing an e-commerce platform with Node.js, where users sign up and make purchases. However, you realize that the platform's authentication and authorization mechanisms are not robust enough, as user data may be at risk, making unauthorized access possible. This could lead to severe consequences, such as data breaches and loss of customers' trust. How can you avoid this situation? Learning about the concepts of authentication and authorization in Node.js is essential for securing user authentication, safeguarding sensitive data, and enhancing your app's reliability and user satisfaction. Let's start by looking at authentication. Authentication refers to verifying who a person claims to be by checking their credentials. This is a fundamental aspect of securing applications so that only authorized users have access to certain parts of the system. The application's backend is responsible for handling this verification process. Now, let's learn about the 3 popular authentication methods. 3 popular authentication methods in Node.js include session-based, token-based, passwordless. Let's explore each of these in detail. Session-based authentication is one of the earliest methods. Here's how it works. Log in with your credentials, which are validated against a database that stores the accessible resources based on the session ID. If valid, the server creates a unique encrypted session ID, which is stored in the database and as a browser cookie. When you log out or after a certain period, the session ID is destroyed, logging you out from both the browser and the database. Now let's explore a code snippet demonstrating session-based authentication in an Express application. In this example, the code performs the following functions. It sets up an Express application and configures session management. Next, the code configures the Express session middleware with a secret key for encrypting the session data and other options like resave and save uninitialized. Then, it handles post requests for your login. If the provided username and passwords match, it stores your username in the session. Finally, the code checks if you are authenticated as a user. If authenticated, the application welcomes you. Otherwise, prompts you to log in. Now that you've learned about session-based authentication, let's move on to token-based security. Token-based security includes two key concepts: authentication and authorization. Authentication is when you provide credentials and receive a token that validates your user credentials. Authorization is when you use the token to access resources, ensuring the resource server knows which resources you're permitted to access. Tokens, often in the form of JSON Web Tokens, JWT, consist of three parts. Header contains the token type and the algorithm used. Payload includes user attributes, known as claims, such as permissions and expiration times. Signature ensures the token's integrity during transit. JWT, pronounced JWT and written as JWT, is an internet standard for creating encrypted JSON payload data. In token-based authentication, your browser requests access to a web application. The authentication server responds with an ID token, stored as an encrypted cookie by the client, which is sent to the web server providing authentication. Now that you understand token-based authentication, let's move on to token-based authorization. Token-based authorization occurs when a web application requests access to a protected resource, such as an API. During this process, the user authenticates with the authorization server, which then generates an access token that is sent back to the client and stored. With each HTTP request, the token is passed to the resource API server, carrying embedded permission details, eliminating the need to query the authorization server. Even if stolen, the token doesn't expose credentials due to encryption. Next, you'll see a token-based authentication example in an Express application. In this example, the code performs the following functions. First, the code configures an Express application with middleware, like body parser, to parse JSON requests. Then, the code handles post requests for user login. If credentials are valid, it generates a JWT or token containing the username. Checks for a JWT in the authorization header of incoming requests. If present, the code verifies the token and extracts the username to grant access. Next, let's look at passwordless authentication. Passwordless authentication eliminates the need for traditional passwords using methods like biometrics, magic links sent to your email, or one-time passcodes sent to your mobile device. This approach is often used in password recovery systems. It relies on public key and private key encryption. When you register, your device generates a private-public key pair linked to your identity. The public key is used to encrypt data and is accessible to anyone, while the private key, securely stored on your device, decrypts data. During sign-in, the app creates a login challenge, encrypts it with the public key, and decrypts it with your private key to authorize access. Next, you'll see how passwordless authentication is implemented in an Express application. In this example, the code performs the following functions. The code sets up an Express application with middleware to parse JSON requests or body parser. Then, it handles post requests where users provide their email to request access, and then the code generates a 6-digit verification code and stores it in an in-memory object. Next, the code handles post requests to verify the received code against the stored code. If matched, the code grants access to the user. Otherwise, it denies access. In this video, you learn that authentication confirms your identity using credentials by validating who you claim to be. Session-based authentication uses credentials to create a session ID stored in a database and the client's browser. When you log out, the session ID is destroyed. Token-based authentication uses access tokens, often JWTs, that get passed between server and client with the data that is passed between the two. Passwordless authentication uses public-private key pairs to encrypt and decrypt data passed between client and server without any password.
Welcome to authentication in Node.js. After watching this video, you will be able to discuss advantages of token-based authentication in Node.js and implement token-based authentication and authorization in Node.js. So, authentication is the process of confirming a user's identity by obtaining credentials and using those credentials to validate their identity. Authentication is meant to identify users and provide access rights and contents depending on their ID. As discussed in another video, authentication can be achieved using the following approaches: session-based authentication, token-based authentication, and password-less authentication. Token-based authentication is the most popular approach to implementing authentication in Node.js. And the following are some of the advantages of using token-based authentication. Token-based authentication is more scalable, as the token only needs to be stored on the client side. Also, since the server only needs to verify the token along with the user information, it is easier to handle multiple users. Token-based authentication offers flexibility as they can be used across multiple servers, and they can offer authentication for diverse websites and applications at once. And JWT used in token-based authentication can be signed and encrypted, which means they cannot be tampered with and also cannot be read without the private encryption key. Now let's set up an Express.js API server that provides access to employee information based on their usage rights. The application will have two APIs, each with its own endpoints. We will first use a POST API for logging in that returns a web token to sign in by sending the username and password in the request body. The call to this API endpoint should be made from the web server that hosts the application's front end. And a second GET API will be the resource endpoint to get employee information that only authenticated users can access. Let's consider what this code might look like. This code creates a web server module by calling the express function and assigning it to the constant myApp. The myApp.get function creates a GET API endpoint for the employee's API, and any call to this endpoint currently returns an HTTP status code of 401. And 401 means not authorized, with the message, "Please log in to access this resource." The server also listens on port 5000 for any HTTP calls to the server and logs the message, "API server is localhost: 5000" to the console. To execute the API first, save the file and name it API-server.js. Now run the command node API-server.js. To verify that the secure endpoint cannot be accessed unless the user is authorized, run this curl command on the screen. In the output, you should see the message, "Please log in to access this resource per your code." In the next part of the code, we allow users to sign in and send back a verified generated token as long as the username and password are correct. Generally, usernames and passwords are stored in the database. However, since setting up a database connection is out of the scope of this code demo, we will hardcode user and password as the username and password in this code example. Now, to generate the verified JWT, use the JSON Web Token npm package. Install it using the command npm install save JSON Web Token. At the start, you will need to require the module JSON Web Token from the JSON Web Token package. This module is used to generate the JWT using the JWT secret. A constant is then declared to store the JWT secret. The myapp.use method enables returning a JSON response by the API methods. To display the code in this video, we are hard-coding the username and password. Please note, however, that the JWT secret should always be generated using a password generator and stored in the config file as an environment variable and not hard-coded in the API as shown here. The username and password from the request body is then compared with the values fetched from the database. And once the username and password match, the JWT is generated using the JSON WebToken.sign function by including the username and the JWT secret as parameters and is returned as a JSON response from the sign-in API. Now, if the username and password match fails, then an HTTP status code of 401 is returned with the message, invalid username and/or password. Next, we define the getAPI method with the employees endpoint. The token fetched from the call to the sign-in API is passed in the authorization header. The getAPI employees is updated to read the authorization header from the incoming API request using the request.header function. And if no header is found within the request, then a status code of 401 is sent back by the getAPI with the message no token. The authorization header always starts with the string bearer at the start of the header, and therefore this token is also known as bearer token. The fetched JWT is verified using the function JSON-WebToken.verify by passing the fetched token and the JWT secret. And the value returned by this function is then used to verify if the user property matches with the username fetched from the database, and if that match happens, then the user is authenticated and is provided access to the employee's API. The API then returns the 200 success status code with the message access successful to employee endpoint. Now, if the verification fails, then the 401 unauthorized status code is sent back to the client with the message, please log in to access this resource. Lastly, write a listener function that listens for the response on port 5000, then log the phrase API server is localhost 5000 to the console log. Recall that the code you just wrote has a sign-in API endpoint that reads the username and password from the request body and then validates it against the username and password stored in the database. If there is a match, it then uses the JSON WebToken.sign method to generate the token and send it back in the response. In this video, you learned that the advantages of token-based authentication include scalability, flexibility, and security. The POST API is used during authentication to log a user into an application. The GET API is used in authorization to determine which resources a user can access. And a JSON Web Token is used to authenticate a user and authorize which resources they have access to use. Welcome to Express Best Practices. After watching this video, you will be able to describe the folder structure conventions for building an Express application and APIs, and identify commonly followed best practices for building Express applications and APIs. Web frameworks such as Ruby on Rails, .NET, and Django have required directory structures for storing files. Express does not require a predefined directory structure for its applications. However, defining a directory structure in advance is usually a good idea because as the size of the application grows, it can be difficult to maintain otherwise. The following folders are conventionally used to store files. Within the project folder, it is suggested you use the following directories: Node modules, config, models, routes, views, and public. Let's describe the contents of each of these folders next. The Node modules folder contains the application's modules and packages. It is automatically created after running the npm install command. Node Package Manager, or npm, is discussed in another video. The config folder should contain configuration files, such as database connection configuration, an environment variables file, and a credentials file containing the API keys for external services used by the application under development. The models folder contains the data models for the application. The files specify the type of data store, such as relational or non-relational,
and are defined by an Object Relational Mapping or ORM library. The routes folder is used to specify all of the routes for the different entities in different files. It should have one file for each logical set of routes, such as one file for one type of resource. The views folder contains template files. A template dynamically writes HTML, CSS, and JavaScript to send back to the client, and this approach makes it easier to generate user-specific user interfaces. And the public folder will contain all static content, such as images, CSS, and JavaScript. It is often helpful to have a subfolder for each type of content. Now, the project folder should also contain a few files: app.js, routes.js, and package.json. The app.js file is the main configuration file for your application. The routes.js file is a central location to access all of the routes in the application. This file requires or imports all of the files in the routes folder and then exports them as a single module, which is imported into the app.js file. This helps create a single point of entry for all of the routes in the application. And the package.json file contains the metadata used to manage the project's dependencies. When building the folder structure for an API, it is quite similar to the project folder. It does not need the views or the public folders, so the folder should look something like this: Node modules, config, models, and routes. And then the following files: app.js, routes.js, and package.json. When naming an API route, be sure to use a noun as the resource identifier. This table provides examples of HTTP routes for post, get, patch, and delete using the word employee in the route. These routes are examples if you are writing HTTP methods and API routes to modify employee data. Also, be sure to use HTTP status codes correctly. A 200s code means everything is okay. A 300s code means the resource has been moved. A code in the 400s means there has been a client-side error. And a number in the 500s means something went wrong on the side of the API. Another best practice is to black box test your Node.js REST APIs. Black box testing means you test the code without looking at its internal structure. The system is tested as a whole without mocked or stubbed dependencies. Mocha, which is a JavaScript test framework that runs on Node.js, contains a simple module called Supertest. Supertest provides you with a way to test HTTP requests, which is exactly what you need when you want to black box test REST APIs. And when your API needs to authenticate, it is best practice to use JSON Web Token or JWT-based stateless authentication. Since the REST API must be stateless, your authentication will need to be as well. Stateless authentication verifies users by supplying most of the session information, such as user properties on the client side. The last best API practice we will emphasize here is creating proper API documentation. The whole purpose of an API is so that someone else can use them, so you want to provide appropriate documentation for your Node.js REST API. Two open source projects that you might find useful to create documentation for your APIs are API Blueprint, which can be found at apiblueprint.org, and Swagger, which can be found at swagger.io. There are a number of other helpful tips that are widely followed when building an expressed Node.js application. Regarding the use of Node Package Manager, or NPM, use the npm init command when initializing a Node.js project. When using the npm install command to install dependencies, use the -save or the -save-dev attribute. This makes sure that if the application is moved to a different platform, the correct dependencies will be installed with it. Never push a Node modules repository, and always use npm to install. Stick with the following capitalization conventions. Use all lowercase for file names,
use camel case for variables. NPM modules are named in lowercase, separated by dashes, and when using the require method for NPM modules, use camel case. In this video, you learned that use a directory structure in both an express.js application and an API that includes node modules, config, models, and routes folders. Best practices when developing RESTful APIs include use a noun as a resource identifier, use HTTP status codes correctly, black box test REST APIs using supertest, use JWT-based stateless authentication, and include good documentation. Finally, other tips include following capitalization conventions, using NPM as recommended, and use config files for variables, and group similar functioning routes into their own files.
Hello, I'm Joseph, and I will be your instructor for this course. You made the right choice. If there is just one programming language I had to learn for data science and AI, it would unquestionably be Python. The best part is Python is super easy to learn and is often one of the first languages people turn to when trying to learn to code. Python is very powerful. It has a huge ecosystem of libraries that will help you get the most complex things done with just a few lines of code. Python is great from everything from data analysis, web scraping, to working with big data, finance, computer vision, natural language processing, machine learning, deep learning, and much more. Python can do anything you can throw at it. This course is designed for beginners, but if you know how to program, you can also take this course and quickly learn Python. In Module 1, you will learn Python basics, including types, expressions, variables, and string operations. In Module 2, you will cover Python data structures, including lists, tuples, dictionaries, and sets. In Module 3, I will teach you Python programming fundamentals such as conditions, branching, loops, functions, and objects and classes. In Module 4, I will teach you how to work with data, including loading data with Python's built-in functions, using popular libraries such as NumPy and Pandas, followed by application programming interfaces, or APIs for short. You will apply what you learned by doing projects using real-world data sets. If you have any questions or require clarification, feel free to post on the course discussion forum. Good luck and happy learning.